Ladies and gentlemen, this is it. This is going to be the 10-hour plus video, a full project where we are going to build a decentralized and fully distributed content addressable file storage that can handle very large files, right? That can stream very large files. We're going to build this completely from scratch. We're going to build our own peer-to-peer TCP library, all from a blank page in Golang, right? So guys, before we continue, before we're going to kickstart this off, I put a lot of effort into these videos. And I also promised my grandma that I will have 100K subscribers by the end of the year. So 50% of my viewers are still not yet subscribed. Consider subscribing to the channel. Like the video, put some comments, put some questions in the comments, and jump into the Discord community. Link to the GitHub repository, and of course also the link to my two amazing courses, Golang courses, are in the links down below. So you can check that out if you want. I wish you the best of luck, guys, because if you can complete this and you understand what's going on, which you probably will, you are going to be a Golang maniac. Trust. Good luck and see you soon. First of all, let's start with the basics. We're going to make a main Go file. I'm going to say package main. What's going on here? Like this, and then we say func main, so we can actually test things. Man, I need to warm up, not gonna lie. Func main. I'm going to say fmt print ln. I'm going to say we Gucci like this, and then we're also, what is this fmt doing? Whatever, it is what it is. Sometimes the compiler cannot follow. We're going to say a new folder. Actually, maybe we should make a makefile first, right? A makefile, we're going to say go, we're going to say build. Output is going to be bin fs maybe, forever store, like this. Then we're going to say run, which always will do a build. And then we're going to say / bin fs. And maybe, of course, testing. And that's going to be go test the whole shebang, and maybe minus verbose, right? You could also do -- race here, but I don't know. Cool. Okay, is this working? Make run. What's going on here? Go build. Go mod. Oh yeah, I see. Maybe we should do go mod init. Can we do this? GitHub com ndm forever store. We Gucci. Okay, and I'm gonna do this. I'm gonna place ads so we don't have these outputs in our terminale. Make run. We Gucci. All right, so we are ready to get this party started. So I think we're going to make our peer-to-peer lib first, or maybe we switch things up and then we can go over to our disk storage, which is basically what I think is going to happen is we just going to send a file. We're going to hash that file, just a hash, a simple hash, so we can have a nice key. We're going to use the hash as a key. Then we're going to add some kind of an interface func to transform the key, to transform the hashed file name, yeah? And then we're going to make these subfolders just like Git does. We're going to make these subfolders, maybe in pairs of 2, store the actual encrypted data somewhere there, and then we can have a nice way to do versioning of these files. Maybe I don't know, versioning and all that good stuff, right? That's what we're going to do. So we're going to do a lot of working with readers, writers, read closers, and all that good stuff. We're even going to make a cache and an index system and all that beautiful stuff, man. It's insane. But first things first, of course. Let's close this file, and maybe let's close main. We are going to make, we have this bin. We're going to make a new folder that's going to be peer-to-peer, right? And in peer-to-peer, I'm going to make a new file. Maybe I can call this transport.go, package peer-to-peer, because we're going to make things very generic, right? Like it was a real library. So I think maybe we should first do TCP, and then we can actually see what kind of things we need to do for our interface. Not quite sure. Or maybe we can do something like type peer, which is going to be an interface like this. Of course, and then we could have something like a type transport interface. All right, I could say transport is anything that that handles the communication between nodes, between the nodes in the network. Yeah, and for a if you're writing documentation on your functions, you should always start with this word should be the first word here, right? And then we could say something like peer represents, actually peer is anything, peer is an interface that represents the remote node, right? That's what a peer is, right? A lot of people don't know, but a peer is basically just the remote node. It's a representation of the remote node, of the remote connection, of the dude or the girl that is dialing us, or the dude or the girl we are connecting to. So of course these interfaces are actually empty for now. So basically, transport is anything that handles the communication between nodes in the network. This can be of the form TCP, UDP, WebSockets. Right, gonna make some documentation. Maybe we'll make it better. I don't know. It is what it is. But I'm teaching you best practices, right? Okay, so what I'm gonna do is real quick start with the TCP, because I think if we have the TCP right, we can derive what kind of interfaces, functions we need to have, we need to implement, and yeah, it's gonna be TCP. Wait, it should be TCP and then transport, right? And you see where this is going, right? You could make your UDP transport and whatever transport you want, right? In separate files, as long as they implement the transport interface. And actually maybe transporter interface should be better, but I don't think it makes sense. In Golang, they want you to make interfaces, right? But I mean, why is interface not interfacer then? Hey. Anyway, we're gonna say type. Can you please close this? Yes. It's gonna be type TCP transport. It's gonna be a struct. I think is that we need to be very careful so we can actually have something that we can implement in all our other projects. So we need to engineer this like a boss, right? TCP transport. Man, that's a good idea, a good thing. What are we going to? I think we need to have a listen adder. Actually, no, I'm gonna start. I thought making some configuration for this configuration. Listen address, and that's going to be a string. Maybe you want a listener, and that should be a net listener, which is an interface. Like listener, yeah. And I think the transport should be responsible for holding its peers, right? So we could do, actually this listener, I don't like that it's, I'm gonna make everything private for now. And we will see, if we need to make something public, we will check how. But I think starting with everything private makes a lot of sense. Peers, that's going to be a map of peer, right? It's an interface. No, not peer, it's gonna be a map of string. And maybe we should make our own type for this. We could use a net other like this. Actually, that makes a lot of sense, to be honest, to use this. That makes a lot of sense, and we will see. But it's not going to be the address. I'm trying to think out loud, right? I think that's good. That will benefit you more than just copy pasting stuff. Let's start with a net adder. We will see. We will see. Because a net adder, if you open this, it's basically nothing more than network and string, right? It's a super easy interface to use, and it makes a lot of sense. So GD, right? You need to do GD, and you're here if you use the Vim plugin. Peers map adder, and then we're going to say it's going to be a peer, right? And if we open up our normal transport thingy, we see peer is going to be an interface that represents the remote node, right? So it's going to be this, and we need to have an mu, right? And a mutex. And I think you could call it mu, but maybe a peer lock. Actually, we're going to call it mu. It doesn't really matter. You will see. Because if you have different mutexes, how are you going to handle that, right? That's going to be a sync RW mutex, right? And you see how you need to group things, right? Because we have this map and we have this mutex, right? And that basically means it's a common practice in Golang that you do this, that you put your mutex above the thing you want to protect it. So we can see, oh, this mutex will protect the peers, right? That's good. Then you're going to say func new TCP transport. There's going to be a listen adder. Like this, going to be a string. Should it be a net adder, or are we going to create one? Good question. And that's going to return, we have a couple options. We could return a TCP transport like this, right? And then say return TCP transport and say that the listen address is basically the listen address we give it like this, right? But we can also say, we can also make this actually a little bit more convenient and say, hey, this is going to be a transport, right? Of course, if you're testing this, if you make a test, right? Let's say you have a test here, func test, things. The problem is, of course, that if you want to test this thing, and you say, for example, transport T is going to be a new TCP transport like this, right? And you give this an address, like, I don't know, could be anything. The problem is you cannot say T listener, right? You see, it doesn't work. Because, yeah, even though you need to cast this to a TCP transport like this, and then it's going to work, right? Except, you see. Decisions you need to be that need to be made, and I want to show you this kind of stuff because, yeah, it's a little bit advanced. And like I said, Patreons, you're going to learn in-depth stuff, right? Very important stuff that will make the difference between a decent engineer and basically, you know what I mean? You are the double weight, you are the double champion, or you're the double division champion, right? Conor McGregor, you know what I mean? The best of the best. That's what I'm going to teach you. So that's the thing. In my opinion, I'm going to try to keep the TCP transport like this because it doesn't matter, in my opinion. I just want to show you these things because sometimes people are returning the interface, right? Cool. So we have this. Then I think we need to have something. You know what? Let's try to do this in a TCP transport test, something like this. And let's open up test here, and then the transports TCP here, so we can do stuff. Right? We're gonna say package peer-to-peer. I'm gonna say func test TCP transport just to do stuff. T is going to be testing T, right? So let's save this real quick. Yeah. So we're going to say, for example, TR, is going to be a new TCP transport. I'm going to say the address is going to be, for example, we could say that the listen address is going to be 3000 or 4000. I'm going to say, okay, listen address. And then we could do something like, wait, let me first go, we're going to use this for our tests. Go get getup.com. I think it's a stretcher. And then test t-fi. And can I do something like assert equal tr listen address. No, we can't. Because if you're designing libraries and such, or you're making production systems, that's actually what we're going to do. We're going to make this as if this was a production system for one of your clients that are going to pay you a lot of money to build this. So I need to teach you exactly how to make this quality code, right? Quality. It's going to take a little bit longer, but hey, it is what it is. So we're going to say getup. I'm going to check if we imported this package actually. Getup.com stretcher. Not quite sure it is. Stretcher and then test t-fi. And I think assert. Man, what's going on? Yes, it's working. I used this package so many times in my life that I know it on the top of my head. All right, and now we can actually run this test like this, and then everything is passing, of course, right? But just want to make a point. So we could do something like, if we have a transport, we should say a start function or an accept function. Depends on how a server is willing to use this. So let's say we have, for example, this is our server, right? How would you use this? We're going to say, for example, tr accept, or is accept already called by saying tr start, right? Some things we need to take in consideration. So let's say so what does a transport always do? A transport always listens and accepts, right? It listen and accept. That's why I think maybe a function transport, TCP transport, we could say listen and accept, something like this. And then we could say, or a listener error is going to be net listen TCP t listen address. What the hell is going on here? VS Code a little bit too enthusiastic. T listener is not going to be, it's going to be t listen address. So we already know that we have an error here, right? So we're going to say if the error is not nil, we need to return this. So I think listen and accept should return an error at all cases. So we can actually return this error. And then we could say tln equals listener equals ln, like this. Or you could do, for example, say var like this, and say add error, and then yeah, or actually, because it's only one, and then could say something like t listener, man, this listen address, man, t listener r, and then relieve the colon. That could actually also work. Depends. All right, so we have this listen and accept, which is muy bien. And then we need to start up an accept loop. But yes, this is going to return the error. So we could say maybe a private function, TCP, to make it cleaner, TCP transport. We could say something like accept loop, like this. and say for t listener. It's going to be this. It's con accept, right? So we need to listen. Wait. This is a connection error. It's going to be t accept. If there is an error in the accept, we actually don't want to do anything for now. You could say fmt printf. You could say TCP transport, but actually TCP maybe. TCP error, accept error, like this, and then we could do a percentage s, a new line of course, and then say the error, right? And then we have a connection. What are we going to do with this connection? We're going to handle the con, I think. And then we could say accept loop, go accept loop. I think we should say go start accept loop. And then we could say here go t start accept loop. And then we could say return null here, right? Then we have a con. And then we could say make an other private function. And I'm going to make handle con here. It's very important if you're writing production code or very high quality code that you organize all your public functions at the top and your private functions at the bottom, and always organize them based on how somebody would read it or based on the importance of a function, right? So if a function is more important, put it more above. And if it's just a simple helper function, demote it to the bottom, right? That makes a lot of sense because I don't want to scroll to a couple of string operation functions that basically makes no sense for me to read. So, and I think here you could say something like TCP transport. We could say handle con, which is going to be a con, net con, and handle con, because we know that we're going to call handle con in a Go routine, so I don't think returning an error makes a lot of sense unless you're going to do some, maybe a channel or something, but hey. So, and now you could say we have our connection here, and then you could say go t handle con, and call it a day, right? And then it can keep looping and keep listening, and nice and tight function. And then here we could do, for now, we could say fmt print f percentage plus v, maybe a new line, the connection, and we could say, for example, new incoming connection, right? Cool. So yes, so basically how it's gonna work is we have our transport, which is a new TCP transport here, and then we can say tr, we don't have anything to start this. So listen and accept. Listen and accept. Right. So we could actually make test. Listen and accept. This we're gonna return an error, so we could say assert null t. Right, that should give us no error, right? Let's run this test. So it's working fine, and we could also do something like, for example, if we do this and we run the test, then it's going to return an error because this is not a valid thing. So, hey, all good. Okay. So thing we already know, no matter what kind of transport we have, I think calling listen and accept is always something that can work. So we can go to transport and we could say in our transport interface, you could say listen and accept. And basically it does nothing, it returns an error. That's the only thing it needs to do. We don't care how or what this function is going to do. It just needs to be listen and accept because that's something we are going to call in our server, right? And depending on what kind of transport we're going to have, we're always going to call listen and accept. If it's UDP, it needs to listen and accept UDP. If it's WebSockets, it needs to do that. If it's a local transport, I don't even care what kind of transport it is. It could be even a gRPC. Listen and accept could make sense here, right? All right, TCP transportos. We're going to see test. Okay, so what we're also going to do is if we are handling the connection, we need to basically the question rather is, so are we going to decode, encode, or encoder and decoder is going to be an interface also? But where are we going to call this? Is that something that's on the server side or on the transport side or something in between, right? That's a thing. I think we're gonna make a peer. We have this TCP transport that's here. Let's make, for now I'm gonna make it here. TCP peer. It's gonna be a struct. We're gonna have a connection. We're going to say TCP peer represents the remote node over a TCP established. Can we do connection? Yeah. What's going on? Lost in salvation. TCP represents the remote node over a TCP established connection. Yeah. Con is going to be a net con. I think because we learned our lessons in all our protocols in the poker engine and in the blockchain shenanigans, we're going to say if this is an outbound peer, which is a bool. Right? What is an outbound peer? If we say TCP transport dial, right, and we dial to a peer, that's going to be an outbound peer. If we make connection with that peer, it's going to be an outbound. But if we accept and make a peer of the connection, that's going to be an inbound peer, right? It makes a lot of sense. Like this, for example. Let's make documentation. So basically, dial. Wacht hè. If we dial and accept. Wacht hè. Wait a minute. If we dial. If we dial a connection. Outbound. But if we accept and retrieve a connection, is this correct? Accept. If we accept and retrieve a connection, it's going to be outbound false. Well, right? Because that's going to be an inbounded peer. I hope that makes sense. You could say con is the underlying connection of the underlying connection of the peer. Yeah. All right. Next thing we're gonna do is basically maybe make a constructor func new TCP peer It's going to be a TCP peer or a peer, doesn't even matter. You're going to say return and TCP peer. Of course, if you make a new TCP peer, you're going to say a connection, which is going to be a netcom. And we're also going to say if this is an outbound peer. And then we can say com and outbound like this. Of course, I prefer to do this. Although they have the same names, still as verbose as possible is always a good thing, because I think if you followed the blockchain from scratch, we already had some nasty issue by not providing the names in a more verbose way. New TCP peer, so we're gonna make this peer, right? We're also gonna need to have some way to add peers. The question is, are we going to do this with a channel? I don't think so. But we're going to have a channel to communicate, right? Because every kind of transport is going to have a channel to communicate. And we're going to call that as an interface function. Handle connection. Do we actually... I think we're going to need a peer here. Handle peer. That's the thing. The question is, where are we going to... Ha! Handle con. I thought maybe we should do something like, let's create a peer. Right? You could say that the peer is going to be, in our case, a new TCP peer. I'm going to say the con, right? And then if you accept, it's going to be an outbound peer. So it's going to be true. Or you could make the peer here. Not quite sure. Probably going to change this actually. We're going to make a new peer. New incoming connection. And let's do this peer. And let's see if this actually works. The question out there is we cannot block for now. Actually, we can. We could do select. Like this. And then... or we should call this in main. You could say that the transport is going to be a peer-to-peer new TCP transport. Forever store slash peer-to-peer, I guess. For some reason, Visual Studio Code don't want to implement these things. 3000 like this. Then we're going to say tr is going to be, let's say, log fatal start and accept. Question what's going on here. Listen and accept. Yeah. Listen and accept. And of course we need to block here real quick. Let's make run this. No, what's going on? Okay, of course, because it's not. Yeah. I see. Let's do it like the traditional way, right? Add. Clear. Make it. All right, so we are doing this thing. Let me quickly do telnet. Telnet localhost 3000. All right, so you see We are connecting and we say a new incoming connection. So we already have, easy, we are already doing TCP. Dopamine. Dopamine. You see that this gives me dopamine and it should give you too. Okay, cool. Listen accept is working. So we have a new peer, that's fine. Now we need to make a very important decision because I want to make a handshake func, which is going to be, look, what we're going to do. I think because handshakes, some libraries need a handshake, like our poker. And what's a handshake? A handshake basically means you connect to me or I connect to you. It doesn't not really matter. We connect. And first of all, before we are going to accept you as a new peer, we're going to shake hands. And if this handshake is not good, we're going to drop the connection and say goodbye, right? So that's why I think in TCP, we're going to have something like what I call a handshaker. Or a TCP. Actually, the handshaker does not even, it can, no, I have an idea. It could be any handshaker. The handshaker could work over a handshaker is going to be a handshaker. And we could do something like this, new file, for example. You could say this handshake.go. We could say package peer-to-peer type shaker interface. And that could be something like, is this correct? My spelling, hand? Yeah. We could say handshake. Or maybe shake hands. Nah, handshake. And the question is, we're going to return an error. Doesn't really even matter. It's going to be hard, this handshaker. Because we're going to think about this. But the thing is, because I'm not quite sure. You see, you could do like a handshaker right here. Let's go to handshake. And let's say type default handshaker. Man, my spelling. Default handshaker is going to be a struct. Do we need to make this a struct? Does it actually make sense? Because we could do something like that doesn't matter. We're going to make this. We could also do something like a type handshake func, which is going to be a func of type error. Something like this. And I think that makes more sense, because are we going to add stuff to this handshaker? Are we going to have things inside of this structure? That's a good question. I don't think so. I think we can do something like this and make it even better. And say the handshake func, right? And maybe we could do something like any. Could take an any. I don't know, to compare or something. I have no clue. And then in TCP transport, wait, handshake. And we could say, yeah, I have a good idea. We could say transport. And this is going to be the handshake func. Handshake func, right? And this is going to be handshake func. right? And if we're gonna construct this, we're gonna say the handshake func. The handshake func is going to be a func. You could actually make this func somewhere else, but for now we're going to make a knob func. It's going to be func any error and say return null. Right? So it's basically doing nothing. So we could also do something like this, right? Like I said, I'm going to teach you a lot of stuff, so it could be a little bit slower, but I hope you have something about it, and let me know. Poke me, let me know what you think about these things. Should I go faster or should I explain these things? You could also do like this, like a knob handshake func, which takes in an any, we don't care, and an error, and we say return null, right? And then we could say, instead of doing this here, we could say, yo, this is a knob handshake func, we don't care, right? And if you really want to be cool, you can do in the handshake, you could say, hey, I'm going to provide my users with a knob handshake func, right? So if they don't need a handshake, they could say, yo, oh man, I need to sneeze. Oh no. And I'm not going to cut this out. I'm not going to go in this video to cut these things out. That's not my style. Man, everybody needs to sneeze. And this big light is shining in my eyes and make it even worse. So you could say handshake func. Handshake func is... I don't know. I don't know how to explain this. Because we need to probably make this handshake func a little bit better. And we're going to see how this is going to work. So let's say we have the connection. We have a peer, which is good. And then we could do... I have an idea. This handshake func is going to be, look, we're going to say something like this. If r equals t handshake func with the connection, and if the error is not null, actually, I'm so sorry, but I'm going to be a perfectionist. Shake hands. Shake hands is going to be a handshake func. So we're going to say t shake hands with the connection, and if it's an error, we're going to say because we're going to here do go handle connection, so we can actually start a read loop right here. We could say here con, no, not con, nr or decoder. Man, I have so many good ideas. This is insane. Bro, man, what you gonna do, guys? Listen, oh, we're only at 44 minutes and I want to show so much stuff, man. We're gonna make, this is gonna be, oh my goodness, I'm so excited. I have so much dopamine. You see, I did this maybe 1,000 times in my life and I'm still getting so excited by making these programs as cool to use. It's crazy. What is this? Why do I have an error? Unknown field. Yeah, I know. Hey man, let me be happy. Is it possible? Compiler. Handshake func. We're also gonna say a decoder. A decoder is going to be should we call this decoder? It's going to be a decoder, or is this too generic? Right? And then we could make, look what we're going to do, guys. It's going to be insane. New file, we're going to say encoding maybe. We're going to call this encoding. We'll go and we're going to call package peer-to-peer. Basically what I was saying, this decoder thing, right? So let's get back because maybe you guys had a longer break than I. So we have the shake hands, right? Which we actually need to handle. What are we doing? This is going to be our read, our message read loop. So we're going to read from the connection. And actually, if you want to read, you need to do something like this. Let's say we make a buffer, which is a new bytes buffer, right? And then you could say nr is going to be, is it con read the buffer, right? Con read the buffer like this. And then let's just eliminate the error for now. Man, what's going on? And then we could say something like the message is basically debuff n, right? That's a message. But I wanna have something better. We're gonna make we are in the file, in this encoding file. We're gonna say type. We don't need an encoder, but we need a decoder. But I wanna keep these files in the same, keep these structs interfaces in the same thingy, in the same file. So we could say decoder is going to be an interface, and that's going to be decode an error. The question rather is, how are we going to do this? We could say decode any. No, it's not, it's going to be decode me a slice of bytes. No, we're going to say decode me an IO reader. That's what we're going to do. Decode me an IO reader and an any. I'm thinking we could actually make this. We could do so many things. Is this what we need? I think so, because we could do something like this, right? Instead of doing all the shenanigans, we're gonna delete this. And we're gonna say read loop. And actually, we could boot up a new one, but it is what it is. We're gonna do it here, and we're gonna say actually. The decoder is going to be a decoder, that's good. So we're going to say, in this case, we're going to say T, decoder, decode the connection into whatever type we want. For example, we are doing so many things at once, it's crazy. We're going to say type, this is going to be a placeholder, temp. It's going to be a temp, it's going to be a struct. There's nothing in temp because we don't care. And we're going to say, here in this case, we're going to say message. Wait, what's going on? Message is going to be and temp. And then we're going to say decode me the message. Right, that's good, and that's going to be an error. If the man, I'm thinking so hard that I cannot type. If R is going to be this, man, yes, no, that is not nil because my brain is already at the handshake because it's red. It gives me an error, and I'm going to say. We cannot actually log here, right? We cannot return. Are we gonna do a permadet? Are we gonna do a permadet connection where if he sends us something we cannot decode, we're gonna drop him? I don't think so. Maybe we could do cool stuff. We could say, for example, something like a len decode error. right? And that's gonna be 0. And each time we have an error, we're gonna say length error plus plus. And if the length error equals 5 times or something, then we're gonna drop the connection. Hey, spam protection, something like this. I don't know. I'm not sure. I just came up with this, to be honest. I just came up with the shenanigans. It could be a good idea, actually. Man, I'm so... Today, it's my creative day. Not gonna lie, I'm creative today. I need to abuse it. So we're gonna say fmt print f. We're gonna say percentage. We're gonna say, actually, it's TCP, right? We could say TCP error once again. And then we're gonna say s new line error continue like this, right? There's no peers. Do we actually care? Could be connection. I don't care. Maybe we need to delete this login. I don't know. So we have this peer. We're shaking hands with a connection. Maybe we want a peer. Maybe we want a peer. Handshake. What's going on here? Handshake funk. Handshake with a peer. Man, what's going on here? Crumbles on my keyboard. I hate it so hard. I'm not gonna lie. Shake hands. Why is this giving us issues? We don't have this function. Did we? What's going on here? Did we not rename this? What's going on? Oh man, I forgot something. Let me quickly do git init. Yeah, sorry guys, I missed actually committing the first episode, but I'm gonna do it right now. Git commit ip1 peer-to-peer peer-to-peer lib, something like that, right? And then it's gonna be a couple more things in it, but hey, it's in the Patreon community, right? It's in the Patreon community. You guys understand? So we have the shake hands. That's good. That's good. Everybody's happy. Okay, cool. So we're gonna shake hands. If there is an error in shake hands, we actually need to drop this connection. So we're gonna say actually we should start the peer loop with the Do we actually want already a peer? I'm not sure. Yeah, maybe we're gonna set something in the peer. We never know. My kids joining the YouTube studio, which is basically my living room. Wait, we need to do some money design decisions. New peer, shake hands. Let's shake hands with the peer. We don't care, right? We will see. If this is an error, we're gonna say close and actually return this thing. Man, why? So many lag in this VS Code. Var r invalid handshake equals errors new invalid handshake, and always make your errors low caps. Why is it not working? It is working. Could say Add invalid handshake is returned if the handshake between the local and remote node could not be established. Established, man. All right. So we're going to say return add invalid handshake like this. Shit, we couldn't. Of course we can't. We are literally retarded. Damn. It was such a nice thing. The problem is, of course, we have this start except loop, and then we have this. No, man, we cannot have this because it's all just return, and we're gonna just log this out like this. Actually, let's tidy it up. I'm going to say TCP error, TCP handshake error, like this. Very important that we first shake hands before we are going to decode here, right? Because in this handshake, it could be that we in the handshake function are actually reading from a connection. So we need to be very careful with this. All right, so. Yeah. Let us actually open up main. So we don't, do we have a decoder? We don't have a decoder, right? That's a problem. So we're going to say TCP transport. We need to have options, right? Because otherwise we need to have some options, to be honest. Type TCP transport opts going to be a strict, and we're actually going to say, listen, man, we need to do a lot of stuff. I'm not going to lie, this is going to take a lot of time. We're going to say that the listen address is going to be a string. We're going to have handshake func. Handshake func is going to be a handshake func. We need a decoder, which is going to be a decoder. Or make options like this, maybe, I don't know, or ops, or conf. I don't know, how do I need to call this? TCP transport ops, that's what it's gonna be. And then we're gonna say, instead of the shenanigans, we're gonna say give us the opts, which is gonna be the TCP transport opts. And then we're gonna say shake hands. We don't need all of this again shenanigans. We're gonna say that the opts, I mean the TCP transport ops is gonna be the opts like this, and then instead of we can make this public. Listen adder. Yeah, that's fine. It's all fine. Of course, T shake hands, that's going to be T handshake func, right? And then of course it's going to be T decoder, right? T decoder, decode, yeah, like this. So if you go to main, we're going to say that the opts, TCP opts, right? We're going to be peer-to-peer, TCP transport opts, like this. We're going to say that the listen adder is going to be 3000. Decoder, that's a good question. I don't know. And the handshake is going to be a default knob handshake func. Knob handshake func, because we're gonna do no handshake, because it's always gonna be okay. So yeah, you could also say that the handshake func is gonna return a boolean if it's gonna handshake yes or no, but if it's return an error, you can have a better logging thingy. The problem is we don't have this TCP opts. We don't have this decoder, right? So if you go to decoder, encoding I mean, you could say type gop. Gop. And why am I laughing? A lot of people maybe don't is gonna understand this, but we are using gop so many times and I don't like gop. I actually like it, but it's not. Yeah, it is what it is, man. Gop decoder struct. Is that only a struct? Yeah, why not? Actually, we don't need this, right? So we could say func deck, which is going to be a gop decoder. Help. Do we need a pointer? Probably not, right? I mean, well, we could do that because then we could check if it's null. And anyway, we're going to try it without. It's going to be a gop decoder. We're going to say decode. We're going to decode the IO. R is going to be an IO reader. And we're going to have V is going to be an any. I'm going to return an error, right? So how are we going to do this? Actually, very easy. We're going to say return. Can we return? Yeah, we can. We can say gop new decoder. We're going to say the reader. And we're going to decode V. Hey, I cannot do it. It's that easy. I mean, it's plug and play, right? Then we're going to go to main. And then we're going to say, yo, the decoder. In our case, you can make any decoder you want. You could decode it in I don't know. You're the Bob Ross. If you want to extend this with your own decoder, man, go ahead and send me the code. So I don't need to do it. Decoder is going to be a gop. A peer-to-peer gop decoder. Easy. That's what we're gonna do. Yes. All right. So now we can actually do some cool stuff, right? We can test. All right, so we have this handshake, yes, decoder. What's going to happen? We have this message. This is not true. First of all, we need to make something that we can actually use in some kind of a channel, a message. If you want to send something over the wire, I'm thinking actually, how are we going to do this? Maybe we could do, nah, that doesn't make any sense. We could make a new file. I know it's a lot of files, but message go, we could say package peer-to-peer. We can actually refactor this and do whatever we want, right? I'm going to say type message RPC. Is it not RPC? Is it RPC? Actually, I'm gonna make this even just more generic. I want just message, right? It's going to be a strict. And a message is going to be, or we make it like this, BTP message. Actually, why? Because it's already in follow BTP. Message. It's going to hold a payload, which is going to be a slice of bytes. Actually, it could be any. Is that payload? Do we need to know from who it comes? We actually always know, right? Or not? I mean, message represents any arbitrary message, any arbitrary data. Message holds any arbitrary data that is being sent over each transport between two nodes. The network. And then we could say something like this. Message is going to be a message. We're going to decode this stuff. And after this, we're going to say fmt print f percentage v new line, the message. And we could say message. We're going to change this, right? But just for testing to see if this works. Actually. Does it make sense to make or we actually let's do make run. All right, that's running. So we're gonna use or telnet shenanigans localhost 3000. All right, so we have new incoming connection. Hello there. Ay caraca. Or we handle, yeah, we handle it. Can it actually decode this in a message? Because we're not sending a message, right? Because the message is always going to be, unless we have something it cannot, GOP cannot encode this. That's the thing. Why are we decoding, by the way? Yeah, decode, right? Decode. Encoding, decoding. The problem is, look, if we do this real quick, damn, this was such a good idea, I'm not gonna lie. We could do like a buff, it's gonna be a new bytes buffer, and then we could say nr is gonna be con read debuff right? If add, of course, is not null, we're gonna the error, and then we're gonna say like here, we're gonna say buff n. Can we do this? Okay, so this is basically something else, right? So we say telnet localhost 3000. Now see that's working, right? So we have this these messages, and the reason why a normal message not work is because it's GOP encoding. But hey, of course it's not gonna work because telnet does not send any GOP encoding. So how do we fix this? How do we fix this? Well, then we write our own encoder that works for normal connections, isn't it? I'm gonna comment this out. Make this message. Yes, that's what we're gonna do. We are actually insane. Trust me. We're gonna go to encoding, and we're gonna say func NOP encoding, just plain bytes. Yeah, that's a good idea. We're gonna make a type NOP decoder, which basically not gonna decode anything, right? And I think always providing something for your library, like NOP this, NOP that, NOP everything, it's interesting because users can just use this directly for their tests and all that stuff. So we're gonna say func. Actually, I'm gonna copy this whole shebang real quick, so I don't need to type that much. I'm gonna say this is gonna be a NOP decoder. Decode is all the same thing, and we're gonna say, basically, we're gonna say, actually, I'm gonna make a new buff. I'm gonna make a new bytes buffer like this, and then we're gonna say buff read. Can I do this? Is that a thing? It's probably, no, it's different, right? It's r read buff. Is that a thing? We can't, it needs to read bytes. Doesn't matter. We're gonna say that the buffer is gonna be 28 or something. I'm gonna read the buff. It's gonna be nr like this. If r, return r, and otherwise we're gonna say of course this any is of course well is a problem, right? Ay caraca. I'm thinking actually because do we want to do the encoding in because we are in our transport, right? We are here in our transport, so making this is already hard coded. Isn't it? Because this could work like this, but I think we I mean, how do you decode everything into a message, right? Into a message instead of this any type. We could say it's going to be a message, and we're going to use this as a communication at all times. But what's the payload gonna be? That's generic. That's depending on the platform. That's what you're gonna. That's what you're gonna decode. With whatever. We don't know. We actually don't know. We need to give the user the option, ourselves the option, because maybe depends on what we are gonna build. So we could actually do something like this. Yo, the message is gonna be. This needs a pointer, right? Because then we're gonna say the message payload. That's gonna be the buffer with this, right? And then we could actually delete all the shenanigans. Always make it a message. Oh, I think my caps lock is on. Right, and then we have this message, which is gonna be the message. And yeah. Do we? Oh, wait. We need to make sure it's a knob. Or default. Default decoder, yeah. And then we're gonna say basically in main. We can just configure this. We're going to say this decoder is not going to be, it's going to be the default decoder, right? Like this. What's going on here? Yeah, I see. It's not going to be any. It's going to be a message. Make run. Wait, V again. What's going on with V? Where is V? All right. So let's say telnet localhost localhost 3000. Hello. You see now it's working, right? So we could give some messages, some random stuff, and then we can see that we are actually having a message with a payload. Yeah, and then what we could do, before we're gonna pipe this into a channel, we are going to go to, what's going on with TCP transport test? Yeah, that's broken, I guess. But you could go into TCP transport, and what we could do is, if we take message, we could say we're gonna have a from, so we always know, it should be a net adder. And then we could say something like, we have this message, decode it, and then we're going to say message from is going to be com remote address. And that's not going to work. That's going to be a problem because, like we mentioned in the poker engine, it's not because if we dial somebody and his remote address is going to be the address he's listening to. And actually, I want to have his listen address because so we can actually send back much more easy. But that being said, actually, for now it's good enough, right? We could say make run, and then we can say here, go run telnet local host 3000, and then we can say hello, right? And then we have this message, and it's coming from this other guy here, and that's the payload, right? And then we're gonna send that into a channel. Just a generic channel with a message, right? And everybody that's using the library, for the most part, we can then say, okay, it's a channel, we have this here, and we're going to handle it in the server, and that's going to be decoded. The payload is going to be decoded. Could be an any. It could be in any. We're gonna see. We're gonna see, because now it's a default encoding, which is basically plain bytes, but it could be that even those two messages are going to be sent over GOP encoding, over proto buffer, and then how we handle the inner bytes could be another encoding, decoding. I don't know. We're gonna see how this is gonna work. I think this is good for this video. I think the next video we are going to actually finish this up. We're gonna finish this complete up, so we can actually start with our key, with our disk storage thing, make a server, use our own library to connect and everything. It's gonna be nice. Or maybe we actually gonna do our peer discovery and stuff also in this library. Not quite sure. We're gonna see. So let me do make run. Okay, I think we started with this peer-to-peer package, right? We are implementing our own peer-to-peer package. Let me see. The main. Yes, and then I think TCP transport. Alright, we have these things. So I think what we're gonna do next is basically we are doing this message decoding here. And it's not the decoding of our payload, but it's the decoding of the RPC. Actually, the RPC between two peers. And I think what is this stamp actually? What the hell? I think remove the stamp, some relics, some leftover relics. And let me do settings real quick first. And make this 18 for the blind homies. I think what we're gonna do is open up message. And I think we're gonna rename this to RPC. An RPC struct. That makes more sense. RPC. And maybe we should rename the package to RPC, but hey. Message. So we're gonna say this is an RPC. We're gonna say RPC. This should be an RPC. And this is gonna be an RPC. And of course, this is going to be an RPC. RPC, all the things. What is going on here? This should be a small caps RPC, by the way. And let me open up. I think we're Gucci actually. And I think we have some. The test is actually broken. Yeah, that's because we basically have our transport options, right? Instead of making this, so we should do like ops. It's gonna be transport. TCP transport ops like this. And I'm gonna say that the listen address is gonna be, let's do 3000. 3000, please. We need the handshake, right? We did our handshake func. That's gonna be a knob handshake func. For now, we're not gonna implement any handshake func. So you see that we have the ability to create a handshake func, but we don't gonna use it. And then we need a decoder. And of course, we provided the default decoder. So we can just use that and then put in opts. What's going on here? Opts inside here, and then we want to assert the listen address. That's going to be the listen adder. Listen adder. Like this. And that's going to be... We could do something like this, right? To test it. Like this. Make test real quick. Undefined message encoding. Yeah, we need to change this. It's going to be an RPC. Do we actually want a pointer? Not quite sure. Not quite sure. Make test. I think we're blocking in a test, by the way. Yeah, the select statement. This should be good. Let's make test real quick. And everything is working fine. That's good. Then let's go to main. Let's do a make run. That's working. Let's open up telnet. My microphone is doing crazy stuff. Telnet's gonna be localhost 3000. Now we're gonna actually send some messages, by the way. We're gonna say, hello, you. And then see what's going on. Yeah, so it's all working fine. We have from who is this coming, and the payload which is sending, which is fine. Working all good. Let's open up transport real quick. The peer interface. I think the first method we're gonna have in our peer is close. Very important. Close like this, so we can close the peer is connection. And if we open up TCP transport, or transport itself, enable to read these messages, we need to have some function which is called a consume, which will return a channel of RPC. And now we need to make sure that it's going to work. So we're going to say TCP transport. And that's going to be, let me quickly think about this. We're going to say an RPC chan, which is going to be a chan of RPC. A channel of RPC, and then we're going to say here that the RPC channel is going to be make me a chan of RPC. Easy. Then we need to implement our interface. We're going to say TCP transport. We're going to say consume, and that's going to return a channel of RPC. And you see this syntax, right? This basically means, if you watched the concurrency for beginners, this basically means we can only read from the channel and we cannot send to the channel, right? Very important. And we're just gonna return the RPC channel like this. And then we could say consume implements the transport interface, just like that. You could say which will return a read-only channel for reading the incoming messages received from another peer, actually. Received from another peer in the network. Yes, that's good. All right, so now we need to, let's get this cursor out of the way. Now we need to find a way to actually put that into our channel, right? So right now we're just printing this channel, but we're gonna say something like that the RPC channel is gonna be the RPC. It's gonna be an RPC. It's gonna be the RPC, right? What's going on? That's a pointer. We don't want that. Although we need the address here for decoding. So that's good. Yeah, this is failing because peer does not implement the close interface, right? The peer interface. So we're gonna say peer, TCP peer, by the way. We're gonna say close, gonna return an error, and we're just gonna say return p com close, and then we can say close implements the peer interface, just like that. All right, I think that's good. Let's test that out, right? How are we gonna do this? We're gonna say listen and accept. Maybe we're gonna boot up a new Go routine here quick to test this real fast. We're gonna say for tr consume is gonna be the message. think it's something like that. Println message. Or we could say printf. What's going on here? Printf and then say percentage plus v. Maybe a new line. Something like that. Is it gonna work? I have no clue. Let's run this. Running is going. It's working. You could say telnet localhost 3000. Hello. Yeah, it's working fine, right? Although we have this relic, this /n relic for some reason. Yeah, we don't have a bad new line. It's crazy. Why is this wrong? Oh yeah, of course. This is not a new, this is a new line. I see. Make run. We could say telnet localhost 3000 and then do it again. Yes, perfectly fine. So now we can consume. It's very important because if we attach or transport to a server or something in some way, then we need to call consume on any kind of transport, and the TCP transport will return his channel. But for example, any other transport will also return his respective channel, which he communicates over the wire. And in our case, it's TCP, but it could be anything, right? We need to make it generic. So that's fine. It's actually capturing output. What's going on here? Let's close that. MIOBS. I hope it's fine. All right, so we have that. The next thing we're gonna do is we need to find a way, because let's open up real quick TCP transport. I'm gonna show you. Yeah. So this peer map, I don't think we're gonna keep it. We not need a peer map because I think the transport is not going to be responsible to keeping the peers, because peer is an interface. So we could, I think the server is responsible to maintaining a list of his peers, which could be a peer interface, which could be any peer, right? It could hold peers that are connected with TCP. It could hold peers that are connected with a local transport. It could even hold peers connected with gRPC. It does not really matter. A peer is an interface, and our server could hold any kind of peer, any kind of connection with his respective transport. That is the beauty of this generic implementation. But we need to have a function, we need to have a way to notify the server that there is a new peer, that the server can do with a new peer whatever he wants. So I think to do that is to do something in TCP, and we could say something. We have decoder, we have handshake func. We could say that the peer func or on peer is going to be a function of a peer with an error, right? And then we could say that if this function returns an error, we're going to drop the peer. How are we going to do this? First of all, I think I'm going to do something like this. I'm going to say a defer func here. I'm going to call it. Or not. How does it work? It's like this, right? And then we're going to say, actually, do it here. And then maybe say var error. Error. Then yoink. Paste it in here. And then we could say something like dropping peer connection. Read loop. Yeah. Dropping peer connection, and then we could say an error, which is going to be the error here on top. Then we're going to say con close. So we could not do anything here. We could just return here. This can be good. And here we could say if error. First of all, we're going to say if t on peer, right? If that's not nil, if somebody provided this function, then we're going to call it. If somebody does not provide this function, then we're not going to call it. But if somebody has provided us this function, then we're going to call it. Then we're going to say if r is t on peer, and we're going to say peer. No, it's going to be the peer, yeah, we just made. And if the error is not null, then we're going to say these errors needs to be new errors actually. Then we're going to just return. Yeah. Something like that. So basically what happens is we're going to do our handshake. If that's okay, then we're going to do the on peer. If that fails, we're going to drop. If that continues, then we're going to start our read loop. Right? Yeah. I think that's fine. So if you go to main, we could say here on peer. Let's try this without. Let's try this without first. Make run. So that should be normal, right? You could say telnet localhost 3000. Hello. You see everything is working fine. We get these messages. But if we say something like on peer, right? And we're going to say that's a function of peer error. And then we're going to say something like return fmt error f failed the on peer func. There should be a peer-to-peer peer, like this. And we run this again. Right? And then we connect then, localhost 3000, right? Wait, let me do this. Right? It instantly drops a connection. Right? So we connect it, and suddenly telnet just exits out. And that's because here, right, dropping peer connection failed the on peer func. Which is nice, because that means that our logic is working. And of course, we could say here, right, we could say, let me do, we could say on peer or something. We don't need to specify it in the directly into the transport options. Right, we could say on peer is going to be the on peer here. It's going to work perfectly fine as long as it has the correct signature, right? That's fine. Now we return an error, but we could also just return null, right? So it's going to work. So we could return null here, and then we could say fmt println, and we could say doing some logic with the peer outside of TCP transport. And let's boot telnet up, and then we could say hello. We can send messages, and then we're going to say doing some logic with the peer outside of transport. So it's all working fine. If we have a new peer, we are actually in a good spot. That's nice. All right, let's close it up. Yes, I think it's good. So, yeah. I think we're in a good spot. It's going to be a short episode, this one, because I think right now we have everything we need to have. Or maybe wait, we can actually not. I want to test something. Because on peer, we could say this is the peer, right? And I want to test something. What happens if we do peer close? That's a good question. What happens if we do that? I'm gonna check it out. It's a very important thing because that's gonna basically drop the peer from whatever. Yeah. So we see that's good that we have this error. Now we have this loop, right? Use of closed network connection, and it's in the read. How are we gonna fix this? Let's open up P real quick, which is in transport, right? Close. It's in TCP transport, actually. It's here, right? If you have an error, we keep looping. Let me see. So what happens is that we have an error here in this decode. What are we gonna do? Are we gonna drop the connection? Or are we gonna check the error? Good question. Let me. Can we do net R closed? So I think we could do something like this, because I think if somebody sends us a wrong payload, I don't think we need to punish it. I don't think we need to punish him and say, yo, you're out because you sent a wrong payload. But of course, we could say something like this, right? R is going to be this. And then we could say if R is going to be net R closed, then we're going to say return. And we could do it like this. And otherwise, we're going to say it's a TCP read error. Is that something that's going to work? Let's try it out. Telnet local host 3000. Use of closed network connection. It's not working. Oh, it's return. Yeah. I think it's fine. R closed. It is. R closed is return my IO is already been closed. Yeah, I think that's good, right? Because can we panic the R to see what kind of R this is? It's a very important thing we need to get working. Let's not make run. It's gonna be telnet, right? Yeah, you see, it's a use of closed network connection. The question is let us see. Reflect type of R. It's a net op error. That's can we not do this? Damn. Okay, I think we need to investigate this. I think enable to make this Let's return. Let's return for now. Let's see. Let's just return. Right. And now it works, right? Now we have dropping a peer because we have a use of closed network connection. I think there should be a way so we can assert this specific error. So we only drop the peer if it's that error. Instead of just a normal error, actually. Another error. For example, a decode error or something, right? But hey, I think we need to figure it out soon. I will check it out, how we can do this. Maybe it's I don't know. We can see. We're gonna make it work. It's not a big of a deal for now. I think we have a good portion of our peer-to-peer lib. Then we're gonna make the storage. Then we're gonna make a server, implement that storage into the server, and then we can do some shenanigans. Let me see. What do we have? Main. I think we're gonna make a new file. We're gonna call this storage go, I think, or store. Doesn't really matter. Package main. I'm gonna say type storage or store. Maybe store. Maybe store is good. It's gonna be a structure. And then let me quickly find a good spot here. And do we need something? Maybe store options or something. Type store opts. There's gonna be a struct also. And we're gonna have some stuff. I'm gonna keep this here for now. Let's do. What's going on with this cursor? Store test. What is this? I'm gonna do the first function. So if you wanna write to disk, right? So basically what we're gonna do is some kind of a content addressable storage where we can save anything in a deep nested folder based on the transformation of the key. You will see. So I'm gonna say something like func as store write stream, because I'm gonna stream it, or try at least. We're gonna say key is gonna be a string, and then we're gonna say an R IO reader, right? What's going on here? A reader like this. We're gonna return an error. Yes, let's save it real quick. And then, so something like this, right? So the path name, we could do it maybe this. The path name is gonna be some kind of a transformation of the key, right? So we could say something like transform func, or maybe path transform func, which is going to be a type of a path transform func, right? And I'm going to say it's going to be a function. We're going to say of the string of the key, and it will return a string. It's easy as that. And then you could say the store ops that the path transform func is going to be a path transform func, right? Needs to be that signature. Yes, and then we could say here that the store opts, we could just embed it. And then we could say a func new store. We're going to give this opts, which are store opts. And we're going to return a pointer to a store, maybe an error, not quite sure. And we're going to return pointer to the store, and then we're going to say that the store opts are going to be the opts, right? Something like that. Of course, if you make a test file, I'm going to make the store test actually. Store test go, right? And I'm going to rename this real quick to store. Yes. Let's close this and let's make another file. What's going on here? Let's open up store on this side, and of course test on this side. We're going to say package main func test store t It's gonna be testing t, and then I'm gonna say, for example, that the s is gonna be a new store. We need options, and options gonna be store options. Yeah, and the transform func. Let's make a default one for now. Default path transform func is going to be a func of key string to a string, and we're going to return. Actually, let's make it clean. What's going on? Let's make it clean. We're going to say return the key. Very simple thing. That's going to be a var. Yeah. And you could say default path transform func, which is all good. And we're going to say the opts here. And then we have a store. What's going on here? All right. Yes, so we have this path name. And then we could say something like s path transform func this key. Right? And then we have a path name. Let's return null. Let's bring it up higher. And then we're going to say something like the file and the error is going to be OS. Actually, we need to make if r is going to be OS mkdir, and I think we need to do all, especially for our content addressable shenanigans. We're going to mkdir all the key, no, the path name. Like this, we're going to say if r is not null. We're going to return the errors. What does mkdir all do? A file name. I think it's, I'm not quite sure with this file name, these file permissions. We will figure that out. I think it's mode perm. Not quite sure. So we're going to make all the folders we are needed, and you will see why. And then we're going to say, then we need a file name actually. And the file name for now is going to be the key. We can't. Let's say it's some file name. We don't care for now. We're going to fix this because we're going to use some tricks. We're going to make a hash of the contents, right? We're going to make a hash, and that's going to be the file name inside of that path name folder. That's pretty neat. You will see. Thought about this last night. Then we're going to actually say here f r is going to be os open. We're going to open the file. I think it's the path name plus slash the file name, like this. And we're going to say if there is an error, we're going to return the errors. Then we have a file, and then we're going to say if, I think it's n, and r is going to be IO. Copy for streaming copy, right? Because IO copy, let me quickly, I will show you. We're going to stream this, right? We're going to not, you will see. IO copy, we're going to say copy the file with the reader. And if there is an error, we're going to say return the R. Maybe we should do an FMT, or maybe a log print F. I'm going to say written %d bytes to disk, like this, and that should be good. Maybe we could do something like this, right? We're going to say path and file name is going to be going to be the path name. Plus, it's going to be this thing that we did, and then the file name, right? And then we could say path and file name. That's not true, this one. Path and file name. Did I make a mistake? Path and... What's OS open, actually? Just the name, right? Oh, yeah. Let's see what's going on here. Like this. We could do something like %s. And maybe do the path and file name. Alright. Yes. Let's test this real quick. So we're going to say... And now we're going to make our transform func and make it beautiful. So we have this S is going to be a new store opts. Yes. And then we're going to say... let's say we want to store something, right? Let's say we want to store as write stream. Let's make a key. Let's say it's going to be my special picture, right? Could be a special picture, and I'm going to say this needs to be a reader, right? Let's say data is going to be bytes new reader, and we're going to say bytes some JPEG bytes, right? It doesn't matter. It's bytes, but right. So we're going to say it's going to be some JPEG, right? And then we're going to say data, and then we're going to say if r. Actually, we should use testify, to be honest. But hey, we're going to say t error, and then the r like this, and then yeah, I think that's good enough to test. Can I do make test real quick? No such file or directory. Or what are we making? Do we need to make create file? Maybe we need to do os create. That could also be a case, eh? Make test. Yes. So you can see written 14 bytes to disk, and this is our location, right? My special picture, some file name. Let's open up B. Let's open up. You see, it's my special picture, the folder, and then we have our file name, right? Which is good. Let's keep it there. Of course, we're also gonna do a configuration where we can set the root of the file system and blah 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 blah. Yada yada yada. Right. So, all right. So let's make a nice transform function. We're gonna test this real quick here. We're gonna say func test path transform func. I'm gonna say t testing t. And we're gonna make this. Let's make it at the top. I know we're gonna split things out as usual, right? We're gonna make things beautiful as later on. Let's make it. How can I call this? Let's make it cas. Cas control addressable path transform func. And we're gonna take in a key, which is a string. We're gonna return a string. All right. And this is the magic. You will see this is gonna be so cool. So we're gonna say func. All right. So we're gonna take a SHA-1 or an MD5. It doesn't matter. I'm gonna take a SHA-1 because we will have more bytes. We're gonna have a longer thing. Because I think MD5, let me open up MD5. MD5, sum. Yeah. What's MD5 size? We don't know. I think it's 20 or 16. I don't know. I forgot. So guess control addressable path transform func. How are we gonna do this? First of all, let's hash this thing. So we're gonna say that the hash is gonna be SHA-1 sum of the key, right? Can we not do this? We need to have bytes, right? Bytes of the key. Then we have a hash. Then we're gonna say that the hash string is gonna be hex, because now we have bytes, right? You're gonna say hex and code to string, and it's gonna be the hash, right? What's going on? Oh, this will, what does it return hash? I think hash returns a 20, yes, 20 byte. And of course, encode to string takes a slice, so we can convert this to slice by doing this. A very neat trick, by the way, guys. If you want to convert a fixed, let's say you have a 20 byte, right? And you want to convert this to a slice, then you need to do this, right? Easy trick. Because a lot of people are still using these loops to convert it to a slice, which is okay, but it's unnecessary, right? It's unnecessary performance waste of CPU. So we have this hash string, and then we're going to say something like the block size, and that's going to be, so we have 20, right? Let's say a pad block size. Let's say a block size of 5. And I'm going to say that the slice length, and that's going to be, I have no clue. I think it's len, the hash string, divided by the block size. And then we're going to say that the pads, wait, now I need to think. This is gonna be on the top of my head. It's not pads is gonna be, is it slice length? Yeah, it's this. It's slice length. Yeah. So pads, wait, so we could do, yeah. Pads is gonna be make me a slice of bytes, I guess, or even a slice of string actually. And we're gonna say the slice len. I'm gonna pre-make it. Oh yeah, and then we're gonna say for, and we're gonna loop through len pads, I guess, or even you could say slice len. It doesn't really matter. Slice len is actually it's already a number, right? So what am I doing here? Like this. Then we're gonna say from to is gonna be it's gonna be I times block size. I times block size plus block size. And then we're going to say we're going to say pads y equals the hash string. Look at this, the hash string from to. Right? And then we're gonna, then we have this pad. And then we could say return strings join. Man, this is actually insane. Strings join. Strings join. The pads. Can we do this? Actually, we can't, because we can. Strings joins pads. And then we're gonna join it with the slash, right, for the pad thingy. Yes. Woohoo. Let's try this. We're gonna say that the pad name from our key, right? So we're gonna, let's say we have a key, right? We're gonna store, for example, a byte, it's going to be a string actually. So we're going to say mom's best pictures, mom best picture, right? And the path name of that thing is going to be, so we're going to, each key is going to be transformed to a certain path on disk. Mom's best picture, and the path name is going to be cas path transform func. We're going to give that key, and then we're going to basically, I don't know what it's going to be, so let's print it out. fmt print ln the path name. Let us run this. You see, this is our path name. Right, so we're going to make a folder, this folder, then inside this folder we're going to make this folder, and inside this folder this, so we're going to go in depth, right? So we're going to have a nice depth of folders for everything, and yeah, so we can store these things on disk that way. And we can change this up, right? It could be that we only have 2 depth or 3 depth or whatever, but now we have a 5 depth. Which is good. Nice. The question is, how are we going to test this? Actually, what we could do is run this again. I have no clue, man. I'm going to just copy this. And I'm going to say if path name. It's not the best thing to do, but hey, if path name is not this, then we're going to say t errors. We could say actually expected path name. We're going to say something like this. Let's yoink it and paste it in here. Expected path name, and we're going to say t errors f t have this, want this, path name, expected path name. And we don't need to do this t, by the way. All right. Something like that. Something like that. All right, so we're going to say that the path name is going to be transform func, so we could do, it's not going to be the default transform func, we're going to say it's the cas path transform func. And you can make your own transform funcs, and we can extend it with whatever you wanna do. You could do a git type thing. It doesn't matter, right? All right. So the next thing we need to do is this file name. This file name is not okay. We want to have an MD5 hash or something, or even a SHA hash. It doesn't really matter. It needs to be hashed. So. And of course, things are going to be encrypted, I know, but for now. I think the problem is we have this reader, right? This reader. So what we could do, enable to hash the contents of the reader, the bytes of the reader, right? We need to read. But we also need to read to copy it to the file. Right, we have the file, we have our reader, and we need to copy the reader into the file, which will read. And once the reader has been read, it's done. So enable to do that, I think you're going to first read into a buffer. So we're going to say buffer is going to be a new bytes buffer, right? It's very interesting actually, because we do a lot of these networking stuff, and now we are doing these file reading shenanigans, which is nice, right? And then we're going to say, I'm going to say IO copy, and we're going to copy this reader into a buffer. And then we're going to say something like that, the file name itself, the file name bytes is going to be MD5, the sum of the buff bytes, like this. Then we're going to say that the file name is going to be a hex encode to string of the file name bytes. Then we can do this path and file name thingy. Then we're going to create it. And of course, this reader is already we can do anything with it. So we're going to say, can we do buff? That would be nice. That would be nice. Is it going to work? Yes. Look at this. So now we're going to see, right? Let's open up our folder. So we're going to say this one, and inside this folder we have this structure, this structure, this structure, 1, 2, 3, 4, 5, 6, 7. Why do we have so much? Yeah, it's normally, it's because, yeah. Is it? Yeah, so we have these nested folders, right? I think it's okay. Let me... It's Tina, and this one. This one, this one, this one. And then we have this file, which is .jpeg. So we are storing this on disk already. It's nice, nice. Look at these folders. I like it, I like it. And if we want to read, it's the same principle. We know exactly. We transform the key we want to read, and it will be... Wait, we have a trouble. We cannot transform it like that. Because how do we read something? If we read it, we need to... No, we can't. We made a mistake. Let's close this up. We cannot do this, file name bytes. I think... that's not true. Because right now we are storing. Let's make... I think we need... You know where I'm going, right? Because if we want to read the key and we have our key, we don't know what's inside most of the time. So if we want to have the full path, we need to have the bytes of the thing we want to read, the content of the data, so we can hash it to know its file name. But that's impossible, right? To get something. So I have an idea. We're gonna say something like a type, a path key. Gonna be a struct, and a path key is gonna hold the path name, which is gonna be a string, but also the original. Is that the thing? Original key, maybe. Original is good. So this path transform func could return a path key. Right, we're gonna return a path key, and then we're gonna say that the we could say return me a path key. And the path key is going to have the path name, and the path name is going to be strings. I'm just gonna type it out again. Strings join this thing that we did, right? We're going to say paths, and then we're going to join it with this, and then we're going to say that the original is going to be the hash string, right? Like this. Expected path name, and I'm going to say expected path, expected original key, and that's going to be the path key, but without these things, right? I'm making so no, man, I cannot type original. So then we're gonna say path key here. Then we're gonna say the path key. Path name is gonna be this, right? And then we could actually copy this again, paste it in. I'm going to say pathkey.original should be the expected path name. It's going to be path name original. What's going on with the original key? No, it's going to be expected original key. Yes. This is going to work. Yeah, of course we have some issues, I understand. So we're going to say that the path key, can I make this like this or this? I don't care. And then we're going to say make everything is going to be the path key, path name, path name. Wait, we don't need this. We don't need to copy this. Actually, we can. I think we. Path and file name is going to be the path key. This, and then we're going to say. Actually, what we could do. Look at this. Let's do it like this. I don't know what I'm doing actually. Path name. Yeah. Of course, we have some issues in our test. Like this. And then we're going to say, what's going on here? What's going on? Oh, it's the... Yeah, it's true. What's going on? Unknown field path name. And then we can make a function, right? We can say func. We could say p path key, and let's say file name. Yes, file name is going to return a string, and we could just return like this. We could say return, and we can make it clean. We could say fmt sprint s, and we could say it's going to be %s slash %s, and that's it. And then we're going to say p path name, p original, s print. What's going on? F. Yes, that's the file name. So we're gonna make the path name, the path and file name. Only thing we need. Actually, we could do it. That's going to be path key, file name, right? And instead of copying this buff, we can copy the error, right? I think that's gonna be something. There's gonna be something. I think we are at a good track. Let's test the storage. Yes, so we are written to disk, this whole shebang. Right, so now you can see that we make these folders, right? And the file name is going to be the path name, but then laid out. So then we can find it, right? Then we can retrieve it, right? All right, so what I want to test is basically reading. So let's make something like func s store. Let me move it up here. Func s store, and we're gonna say read stream, a key which is a string, and it's gonna return us. That's a good question. IO reader. It sounds weird, but and an error maybe. Because we're gonna wrap these functions, right? So now read stream, write stream is gonna be internal functions, but we're gonna wrap them with read, right? And easy API to use. Right, so we're gonna say that the path key, we're gonna say the same thing, right? The path key is gonna be as path transform func of the key, right? Then we're gonna say that the file name, or the full path actually maybe, the full path is going to be Actually, can we? I think we're going to say OS open. And we're going to say there's going to be an FR file and an error. It's OS open. And I think we're going to say the pad key file name. No, it's file name. It's... I don't like this file name thing because... Where is pad key? File name. The pad name. The original. I don't like original. This is going to be file name. We're going to refactor this. And I'm going to say this is going to be the full pad. The pad name and the file name will give us the full pad. Is that correct? Leave some comments if you think I'm wrong. If you think we can do this better, because hey. So the full pad is going to be the pad name with the file name. Because this is the file name, right? I mean, it's clear as that. Of course, that's we're gonna pad name original is gonna be the file name. Yes. Full pad. Of course, we have some issues here and here. Let's make it full pad. And of course here also it's gonna be full pad. Yes, and then we're gonna say here pad key full pad. That's what we're gonna open. If there is an error, we're gonna return. Can we return null as a? Yeah, we can. We're gonna return null. Then we have a file. The question is, we can what do we want to return if we want to do a read stream? That's a good question. I think file is a reader, right? File is a reader. But I think we need to have this read stream because we're gonna do decryption and stuff. Decryption needs to happen on the client side, I think. Which happens, right? Well, I mean, we're gonna get... this is a hard one. Is file a reader? That's a question. I think so, right? Yeah, it needs to be. Yeah, we can. Of course, we need to close these files, right? That's the thing. So the problem is with we're reading a file from disk, but we need to make sure we close this. So I don't think it's going to be a reader, but a read closer. Which basically means we can just do this. Return the whole shebang, but that doesn't make any sense. But then we can wrap this in a function and we could say, for example, as store and just read. Read the key as a string. And then what we could do here is... we could return bytes or a reader. Not quite sure, guys, what we need to do here. There are a lot of options, to be honest. So we could say, for example, we read stream this string, this key. We return null r. Right. And then we could say we can make a buffer. new bytes buffer. We're gonna say IO copy fbuff. No, buff f. And then we're gonna say f close. And then we're gonna return the buff nil. Actually, what you could do is let's do this. What's going on? What did I do? Let's defer it here, f close. Should I do it like this? Actually, I think it's fine. I think it's fine. We can say defer. And we're gonna say add, and then we're gonna return add, right? Does it? Huh? What happens here? Return add, right? Oh yeah, new variables. Yeah, I see. Yeah, it's fine, it's fine. Is that a thing? Let's test this, right? So let's put it up higher. So we're gonna say here data. We're gonna read what is this? My special picture. Let's make a key. I'm gonna say the key. What's going on? It's gonna be mom specials. We're gonna read the key. These are the bytes. These are the data, right? This is a new store. La la la. We're gonna write this, and then we're gonna read this, right? Then we're gonna say that the R is gonna be S read. We're gonna read the key. We're gonna say if R is not null, the error R, right? The error R. Now we have this reader, right? And I think it's important to return a reader because then you are flexible. Then we are flexible. If you just return the bytes, I think it was important to close the file, so we don't need to do that. The user, well, we don't need to do that later on, but a reader is important to have. So we're gonna say R is gonna be, we're gonna say that the B R is gonna be IO till read all R. If R is, do we need this? And I'm gonna say wait, what you could do is instead of doing, we're gonna say this is gonna be bytes like this, and we're gonna say this is gonna be a byte new reader here. My mic is constantly doing stuff it doesn't need to do. Hey, anyway, it is what it is. Yes, we're gonna do it like this because then we're gonna read this byte, and then we could say if B is not equal to the data, right? That we put in. We're gonna say t error f. We're gonna say want this. Can we do s? I think so. Have this. We want data. We have b. What's going on? Well, as b is not data. Damn, it's I see. Well, what we could do is this, right? We could say string b string data. Is that a thing? Yeah, look at this. It's just working. So because we could say fmt print println, and you could say string b, right? So you could see what we read it, right? Some JPEG bytes. It's fine. It's working. Yay! All right. So help me. What's going on here? We can read. Of course, I think we need to do some more stuff in here, but hey, it's fine for now. And I'm thinking. My special picture. So we have these cool stuff. Oh, we have. What the hell is going on here? Of course, if you store the same file again, this is weird behavior. Well, so it's gonna hash, but why is it the same path and not the same thing? Ah, see, yeah, of course, it's hashing the same path. We do an MD5. No, we don't. Anyway, doesn't matter. We will fix that. We will see what is this, how that happens. It doesn't really matter because it's the same file. The question about there is, what do we need to do when we are storing the same file once again? So we're gonna fix that all later on. The basics first. Actually, we should let's make a delete function so we can actually clean up our tests. Otherwise, if we run the test, we will have these folders sitting around, right? We have read here. Let's make a delete. If you really want to delete something, right? We're going to say delete. We're going to delete a key. We're going to return an error. And the first thing we're going to do, like usual, is make our path key. That's going to be as transform func with the key. And I think we need to do let's do FER. Actually, do we need to stat this, to be honest? Because can we not do something like OS remove? Removes the named file or empty directory if there is an error. And what's remove all? Remove all, removes path and children. It contains, it removes everything it can, but returns the first error. Okay, I see. Maybe I think I remove all. And it's going to be the path key full path. Like this. Let's return the errors. Of course, this we can actually just return this. Unless we want to lock. And even then. But we, like I said, this is very, very early. I think we're going to add much more to this later on in these things, right? Especially if we want to work with a cache and everything. So I'm going to implement the cache, and if you want to work with a cache, we need to bust the cache, and if you delete and blah, 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 and all that good stuff, right? So that's why this function will be bigger. We can actually make a defer. func. I could say something like this, right? Or even this. It's gonna be pad key full pad maybe. Actually, file name maybe. Right. This is gonna work. No idea. Can make this test, right? You could say func test delete. Gonna be a t testing dot t. Could copy this. Let's write it. Let's write mom special key. And let's then say if r is s delete key. T error f, not error f. R. Let's make another function actually. Has key. We need to make these pad keys all the time, right? We need to make these transform funcs all the time. What's going on? I think you could do something like file information is os stat. The key. No, not the key. The pad. Full pad. What am I doing here with this capital P? Full pad. What are we gonna do with this error? Has. Do we care about this? Look at this. What we're gonna do is if add is not null, I'm gonna return false. Is that a thing actually? Should we do this? So let's say if we have and we are trying to stat something and we get an error in statting, I'm gonna return false. You know what I mean? It's then we're gonna say how can stat actually return an error? Anyway. Wait, maybe let me see what stat does. Stat returns a file info describing the file name. If there is an error, it will be pad error. It's a pad error, right? Because we don't get this file info, right? Is not exist returns a boolean indicating whenever the error is known, report directly, exit. New code should use fs. Fs are not exist. Is that a thing? I don't exist. Man, this is crazy. If R, what is this? Should use return R is not equal F not exist instead of if. Why? Because if the error is the file not exist, then we return false, right? Because we don't have the file then. I don't understand. Am I stupid? Maybe. Maybe. Whew, man. Let me clean up these folders real quick, actually. Do we have no shenanigans, right? So basically what I'm going to do is I'm going to test store delete key. I'm going to store this key and I'm going to delete this key. So I'm going to run this test. And then you see deleted from disk. But the problem is this is still here. But the file is gone. The file is gone. The file is gone, but the folder is still there. Oh, man. So what do we do? Do we remove these folders also, or what is this? I thought remove all. I really thought remove all would remove the whole shebang. Not gonna lie. What happens if you do remove all, the path key, and we say we're gonna remove the path key path name? What's gonna happen then if we do this again? Let's delete this. Boom. That's crazy. It's deleting, that's for sure. Removes the named file. Removes path and any children it contains. Oh, but man, why is it not working? The path name, path. That's crazy. That's crazy. I was really assuming that OS remove all would delete the whole shebang. But apparently it isn't. Let me think. Then we could do 2 times what you could do, but that doesn't make any sense. Oh, but this, it's full path. Yeah, full path, right? So we're deleting the full path. So I don't know why this is not gonna work, to be honest. Why does VS Code not? Yes. Boom. So we deleted this file name. Yeah, I understand. It's gone. I completely agree. Weird behavior. So let's do something like. I don't know. I'm not quite sure if this is the right approach, to be honest. But hey. Now return. We're gonna say path key full path. We're gonna say, yeah, no, not the full path. This is gonna be then the path name, right? Path name. It should delete everything. It is what it is. I don't understand. Let's open up. Let's remove this folder once again now. Right, and let's do this again. All right, now everything is no. What's going on? You know what? You know what we're gonna do? Wow, what is this, man? Is this Windows shenanigans? What we're gonna do is we're gonna say path key. Make a new function. We're gonna say p path key first path name, and that's gonna be, it's gonna return a string. And we're gonna say return strings split the p path name, and we're gonna split it with this, and we're gonna return the first. All right, and we're gonna double check because we are doing arrays. So let's do paths like this. We're gonna say let's make it actually good, right? Because people are gonna roast me. So we're gonna say this is gonna be the paths, right? I'm gonna say if len paths, if len paths is 0, right? Then we're gonna say we could panic here because if we want a first path name and it's 0, but let's return nothing. It doesn't matter. I mean, you could say, yeah, path name needs to return a string and an error, but you could, man, if you could, yeah, I know, but still, I'm a big fan of errors and handling errors, very important, but these things, if you are trying to get the first path name, but you cannot make a path name, something is terribly wrong in your system, in my opinion. Something to think about. We could say return, then we're going to return the paths 0, right, the first one. Right? So instead of doing this, where is MR? Remove. Delete. Here. Let me try something real quick. Let me comment this out. We're going to say remove everything, but we're going to say path key, the first path name. Okay? Delete permanently. Do it again. Hey, you see? Now it's working. Haha. So can we actually do the complete test? Actually, let's do it. Test delete key. Yeah. So we're gonna do our test here. Read everything, and we're gonna test this, and then we're gonna basically just say. As delete key. Yes, it's working. Yeah, baby. Yes. Of course, we also want to, basically for our test, if we want to do a complete tear down where we delete everything we just stored, we need to implement the root of the storage. We need to know where the root of the storage is, and once we know that, then we can just delete the complete root, basically. So we could actually say, should we make a function clear? Not quite sure. But anyway, let's open up store and store test real quick. And what we already can do is save things. We're going to make these folders based on the key, right? Based on the key, we're going to transform that key, and then we are going to create some path to the file, right? Content addressable. But the problem is there is no way to specify a root, right? So we cannot just store that randomly on disk. We need to have a root that contains the whole shebang. So how we're gonna do this is basically a couple things actually, because I was inspecting this code base and we made a mistake. Well, not a mistake, we forgot something. So we have this, let me put out of the way, this cursor. So we have this default path transform func, which is basically the default. And we have no way to basically add default values, right? So we could do something like here, new store, and we could say like if the opts, the path transform func is null, then we could actually say that the opts path transform func is the default path transform func. But that's not gonna work because we changed this interface. Let's go up top. We changed, where is this thing? This path transform func is basically takes a string and returns a path key. But we are returning a string still in this transform func, so we need to say it's going to be a path key, and that's going to return a path key. And I think because it's the default function, we can say that the path name is going to be the key, and then the file name can also be the key. Why not, right? So that's gonna work perfectly fine. The next thing I want to do is basically add a root in the store opts, which is going to be a string, which is going to be root. We can say root is the folder name of the root containing all the files, maybe folders, files of the system, like this. And then we could say something here, right? You could say if the opt, actually we could say, let's make a constant. We're gonna say default root folder name or something, I don't know. And we could say it's gonna be GG, wait, my keys, it's back to international and it needs to be US keyboard layout. Otherwise, my quotes are fucked up. We're gonna say GG network. Like this. And then we could say something here. If opt root, actually we could say if the length of the opt root equals 0. That's basically how I check if strings are 0. You could do basically like this, right? It's the same thing. If opt root equals this, right? But I don't like it for some reason. I don't like it. So I'm always doing if len of the string is 0. Then we could say that the opt root is going to be the default root folder name. Of course, now the whole system is broken, right? Because we have what is this? We can delete it, I guess. Because if we want to write, so we're going to say path key, and then we're going to mkdir the whole shebang, right? The path name of the path key. The problem is we need to append, prepend. We need to prepend the root name to this. So actually it could be something like as root, like this, but that's a nasty way to do that, I know. Right? It's like, I just want to test this real quick. Let me open up my folders and let's run test here. Right, it's not gonna work. Why is it panicking actually? I don't understand. Basically it's tried to open. It tried to open that shenanigans. It's a write stream. It's maybe because we're also doing a read streams here. Let's delete. So we're gonna write stream here. We already have these complete folders here, that's fine. So something is working. Alright, let us test just writing. Right, that's gonna fail. That's gonna fail. It's the full path. Yeah. I see what's going on. So we basically do this mkdir all with the root, and then we're making a full path, and then we are gonna create, but the full path also needs to be the root plus the full path. Right. Let me delete this folder once again. Now let's run this again. Right, now it's gonna work perfectly fine. So we have our root, and then we have our file here, which is some JPEG bytes. So that's already a good start. Okay, so how can we make this cleaner with this root thingy? Let me close this bytes thingy. Awesome. I'm tired. It's still early. And I'm trying to do this as raw as possible, right? No pre-recorded shenanigans. So, wait, what is this path name? And then we have the full path, which is basically the path with the file name. And this is going to be the path key, path name, which is going to be the path without the file name. What we could do is make a transform func with the root. Do we want that? I don't think so. Or we could do something like path key, root or something, and then say that's going to be the s root. But I don't like it. I don't like that. So what we could do is basically, we can keep it like this. I'm also thinking maybe we should do a path transform func with the key and the root or something. Like this. But then it's not a separation of concerns, right? I want to have this function as pure as possible. So what we could do to make it a little bit cleaner is basically, it's going to be the path name with root. And that's going to be an fmt sprintf. Yeah, sprint f, yeah, like this. And we're going to say percentage s slash percentage s. And then we're going to say it's going to be the s root. And the path key is going to be the path name, I guess. Path name. Yeah, like this. Right. It's already a little bit cleaner. And we're going to say path name with root. And then we have this full path. And then we could say the same thing like full path with the root, right? And let us copy this bad boy. But that's not going to be the path key path name. It's going to be the full path, right? Actually, yeah, now we can say full path with root. Full path with root. And then this is going to be, we written to the disk, and it's going to be the full path with the root. Is that a thing? I don't know. Let's delete this. And let's run it again. It's all working as expected. That's perfectly Gucci. So let's delete it again. I think what I'm going to do is make the delete function right now, because then we don't need to do it manually. But let's make this test work first, right? So then we're going to read. We're going to read the key. We're going to read the key, actually. So that basically means we need to fix it. What's going on with the write stream? Man, test. It doesn't detect it. It's telling me probably that it's not getting used. Although we're using it in our test per day. And this thing, this can be different. We could do if errors is ROS not exist. It's the same thing. Right, so if it's not existing, then we return false, otherwise return true. Read. Where is read? What's going on here? Like this should be fine. Where is read? Here. So we're going to do a read stream. Is this one? We're going to say that the path key is transform func with the key. And then we're going to say read me the full path. That's not true. We're going to say that the path key with root is going to be an fmts. Actually, what we could do is... it's fine. I mean, we could make these things, like I said, in an application you can keep making things even better and easier to use, but hey. Percentage %s slash percentage h, and it's going to be the s root, and then with the path key, like this, and then we could say open me the path key with root, right? Is that? I think it's going to be the full path with root, to be honest. It's going to be reading. That should actually work, I think. It isn't. I see what's going on. What's it doing here? Oh yeah, I do the path key. That's crazy. Full path, right? Yeah. So we have written 14 bytes to disk. That's fine. The question is, why don't we print that out? We don't. We could try, right? You could try if you're actually reading this thing. Print f. Yeah, it's working fine because we say want f, so that's fine, right? But hey, if you want to see it on the screen, we could do string b and run this thing again. What's going on here? Print f. We could do print ln and do this. Boom. Some JPEG byte working as intended. That's good. And then we're going to say delete key. The question is this going to work? Probably not. We need to do some changes. So let's open up delete. It's above here. So we're going to say path key the file name. But we're going to remove the first path name. That's fine, right? So we could say first path name with root, which is going to be an fmts print f. Same shenanigans, %s slash %s, and it's going to be the s root and the path key first path. Let's just type it out instead of type hinten. And then we're going to delete everything inside this. We're going to say the first path name, and let's type it out again with root. Sometimes it's fine to not rely on your type hinting. I'm so sorry. Still rusty. And then we're going to delete this. The question is, what is it going to delete? It's going to delete the whole shebang. Let's see, right? So we have this thing. I'm going to do run test. Hey, look at this. It's working perfectly fine. Yes, that's already a good start. Sometimes things go like it should be. That's great. That's clean. That's clean. That's clean. Let's. Do we need to have something else? We have delete has key. Where is has key? Has key. Has. We're gonna do this transform func. We're gonna see if the stat to the full path. I need to say full path with root, right? Full path with root. And that's going to be, again, I know, s print f %s slash %s is going to be s root, and the path key is going to be the full path, I guess. Yeah. So a function, actually, is it? Yeah. And then we're going to say that the full path with the root is going to be this. How do we test this has thingy? Test delete. Well, let's just test everything in... let's do it here, right? You could say if okay as has the key, and it's okay. It's not okay. Actually, what we're gonna do is this, right? Actually, no. If it's not okay, it should have it, right? So we could say if not okay, then we could say t error f. We could say expected to have key. Noise, man. Sometimes, and like I said, this chair. I need a new chair. It's my back hurts. Everything hurts. It's just a simple living room chair. You know, where you just eat and dip them. But I'm sitting here for hours and hours. It's crazy. And I'm an old man. And I need to have, I don't know. So yeah, this is nice. What I'm gonna do is real quick. I'm gonna say git add, and then I'm gonna do a git commit added root to the store. Maybe we're gonna say added root option to maybe store opts, like this. Right. Gucci. And once again, for the people that are Patreons, thank you for the support, of course, like usual. Thank you very much. If you're not in the Discord, DM me or DM me on Patreon or something, and I will give you the correct role in Discord, right? You get a better role. So we have our private, you can join the private channels, where I'm basically continue helping people out, right? So do that. Let me know if you don't have the correct role yet, and I will happy to give you an exclusive status, the status of the high value engineer, software engineer, which you are, or you're going to become. Yes, so that's fine. What do we need more? Actually, what I want to do in these tests actually is maybe make a tear down, or maybe make some helper functions. For example, we could say new store. We're gonna say testing. Do we need a testing? I don't think we need actually. Yeah, we're gonna some helper functions for us test it. It will make our life easier. What's going on here? A store. We could say return. Actually, let's do this. Copy this. Do we want a root? We don't want to. I think GG is fine. G network is fine, the default one. So we're going to make our cast transform thingy. And then we can actually just return this new store. Let's make a function. It's going to be tear down. And what do we want with tear down actually? Ha! Do we want testing T in? I think testing T, and maybe the store itself. Not quite sure actually. Wait, in a teardown we need to delete everything. Do I have coffee actually? Yes. Lucky. Well, this is basically a once in a lifetime opportunity that I have coffee available when I didn't expect it. So we're gonna do a teardown function. How can we actually remove the whole shebang? I think we could do something like if R is going to be OS. Where do we do this? Remove all. Actually, we should make a function like, for example, f store. And then the store one, then I think the store is basically complete. We can store things. We maybe need to come back to add our cache and everything. But hey, the next thing is to couple this on our network so we can store things and then distribute it. That's the that's where the magic is gonna happen. But this needs to happen also, right? So we're gonna say a clear function, right? Not quite sure what it's gonna do. It will probably return an error. We're gonna say OS remove all, and I think we could do something like s root and actually do return. Isn't that amazing? Is that a thing? If add is gonna be s clear and the error is not null, then we're gonna actually the error r. Is that a thing? Let's try this real quick. So we don't need this stuff. What we could say here is basically say s is gonna be a new store like this. And then we're gonna say defer as tear down. Clear. No, tear down. Tear down. Help. Tear down. TS. Is that a thing? I'm not sure. Let's try. Yes! You see? Now GG network is completely gone. And now we can keep running these tests, right? Okay, of course. It's getting cached, right? It's getting cached. Maybe we're gonna make a new key. Foo and bar. It's getting cached, so let's change this so the cache can be busted here. Hop. You see, and everything is working perfectly fine, and we don't have any relics in our folders from the test, which is nice. And the reason why we pass teardown in test, why we pass the testing.t and teardown is basically so because clear can return an error, and then we can assert it, and it's all fine. And to be honest, we could move these shenanigans completely at the bottom of the file. Because they are just helpers, right? So how do we need to test actually a little bit better this test store? What we could do is we could do this, right? We could make a for loop, and we place everything in this for loop, right? Oh, I'm itching. What is this foo and bar thingy? Wait. I made a mistake, I guess. So this is a for loop. We're writing these bytes. Where is our key? We don't have a key. What the hell's going on? Okay, key is gone, but it's no problem because we're going to make a new key. We're going to say that the key is going to be fmt s print f, and that's going to be. Let's make this foo underscore d, which is going to be the y. Right, so we have count. How many times are we going to do this? You can test this 50 times, right? Then we're going to make some data. We're going to say some JPEG bytes. We could make some function for random bytes, but hey, doesn't really matter. We're going to make a new key. Does it matter actually that we have a different file size? I don't think so. So now we can actually do this completely at the same time. We're going to write to disk 50 times and with different keys. You see, and it's all different keys right here. 14 bytes, I know. What's going on here? Stop VS Code. Yeah, fine. And we have no relics in our folder, which is fine. So we're basically testing writing, we're testing hash, we're testing read, and we're testing delete at the same time. But if we delete, we need to assert, we need to make our test pinpoint precise, right? Pinpoint perfect. We're going to say r not null. Then we're gonna error this error that we are returning, and then we need to say, to make this actually perfectly fine, then we need to try to see if we have a key, and then we're gonna say if it's okay, right? If we have the key, expect it to not have that key, right? Because we just deleted everything, right? And we're gonna do this 50 times, so that basically means we're testing everything we have, so we don't need to test this delete because we're already testing this, and we don't need, yeah, that's fine. Test store, new store, tear down. I think this is perfectly fine. We're testing in one test, we're testing the whole shebang 50 times with different keys. So we could do, make test is gonna fail because we have an error in our TCP somewhere, some test that's failing. Boom. Right, and I think the tests are perfectly working. Yes, Gucci. Do we have in our make file actually? We have verbose on. I'm gonna delete verbose and make file, so if we test, make test, right, then we don't, oh yeah, it's printing anyway. I see why it's... Make run, yeah, I see. Make test actually. Anyway, why is it failing? It's in peer-to-peer. What's going on? TCP transport test or something? What's going on? Help! Yeah. What's going on here? Run test this. It's gonna. That's working fine. Whoa. What do we have tests? We have transport test, handshake, store test. Why is it failing? That's insane. Make test. What's going on? Fail. It's the pad transform function that's failing. That's weird. That's weird. That's weird. Store test. This is failing. You see? We want this. Whoa. This is the exact same thing. What's going on here? Wait. If the path name and file name is not the expected file name. Wait. What's going on here? Have. Wait, in VS Code we can actually hover. My mouse is broken. You see? If you hover this, then you see on the other side that it's basically mimicking the same. You see, it's the same thing. So we have this, but we want this. But it's the same thing. So store test is going to be... Why are we doing this not equal? It's 19. Line number 19. What's going on? It's this one. If the path name file name, the path key file name is not the expected file name, but they are the expected file name. Wait, this is not correct, right? Because the expected... The path key file name, that's not this one, right? The file name is the expected original key. This is expected file name. This is the expected file name, and this is the expected path name, right? So this should be equal, and the file name should be the expected file name. right? And then we're going to say here expected file name. That should be right. All right. I remember that we changed some stuff up, so that could be the issue. Okay. Yeah, I think this is fine. So we can write stuff, we can read stuff, we can delete stuff, we can clear the whole shebang, we can test if we have a key. I think this is a very good start to swap back to our server. To swap back to our server, and then we can attach this storage there. Store a file, and then we're gonna basically replicate it to all our other nodes in the network, and we're gonna do some encryption, and now we're gonna see what we need to do. So hey, we're at the good part. Somebody from the community noticed something. Not quite sure if you remember, but we had this weird warning on error is somewhere. I think in the hash key. Yeah, here. Although the warning is already fixed, I think we can make this even better, right? Instead of doing error is and check if it's false, blah, 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 we can actually do this and return this directly. What's going on? Like this, right? Actually, return is like this. Hop. And that should work perfectly fine. Let's do make run. Test, actually. Yes, perfectly fine. The next thing I also want to do is make an exposure of the write stream. Because we have this write stream here, and I want to expose this as a private function. So we're going to say, instead of making this... because I think we're gonna do some more stuff in it later on. But for now, I'm going to expose it as a simple write. Store, we're going to just say write, which will take in a key, which is a string, and also take in an IO reader. We'll return an error, and then we can actually just say return me as write stream with the key. What's going on here? Key and R like this, and it will all work fine. The next thing I want to do is start creating our server. New file. We could call it file server or server. I don't think it really matters. Let's call it server. Package main rather. We're going to say a type server, which is going to be a structure. We're going to have, wait, let's make some options, right? Server options is going to be a struct also. We need a listen adder for our transport, right? Because we need to embed our peer-to-peer lib into the server thingy. So we're going to say, let's call it file server. File server ops. Listen adder is going to be a string. We also need a storage root, right? Storage root. It's going to be a string also. And of course, we also need a private key and all that stuff. Not quite sure. We need to implement that. Because we're going to encrypt, right? We're going to encrypt probably some stuff. Or maybe an encryption key. Doesn't need to be a private key. We will see. We will see. Storage root, file server. We can say file server opt right here. New file server. It's going to return a file server. We could actually say something like return and file server. We need a store. That's what we need. A store which is going to be a pointer to this thing. Store we just created, right? And then we're going to say that the store is going to be, I think, a new store, if I remember correctly. It's going to be the file server opts. And then we could say here that it's going to be the opts storage root. What's going on in new store actually? What's going on? Store. Bad transform func, that's the thing. Are we gonna... Yeah, I see. So what? I think we should... There's gonna be a bad transform func, to be honest. Because we need to pipe in. We need to aggregate all these options, I think. Yeah. We can. No, I see what's going on. I see what is going on. I think there's gonna be the store opts. We need to make the store opts, right? It's gonna be a store opts like this, and then we're gonna say at the storage root, it's gonna be opts storage root, and the bad transform func is gonna be the opts bad transform func, right? It's not gonna be. It's gonna be the root here, I think. Yeah. And then we're gonna inject these store opts into this new storage thingy. That's fine. And of course, we're gonna the file server opts gonna be the opts here. And then we need something like a function run. It's gonna be. We could say fs, but as is fine. We're gonna say file server opts is gonna be a run, or maybe start actually. Don't like run. Let's put it higher on the screen. I think we also need a TCP transport, which is gonna be a transport. I think it's gonna be an interface. We could say transport. Going to be a peer-to-peer transport, is that in the configuration? All right, so how do we run this transport, by the way? Right, we only have this interface only to listen and accept. Where is listen and accept? It returns an error. So we already know that start can return this error, and then we could say that if r is going to be s transport listen and accept, and the error is not going to be null here, then we're going to return the error right away. Is this blocking? It isn't. So it's gonna start this accept loop, which is fine. Which is perfectly fine. Let's do quickly return null. Let's go to main to see how we can make this work. All right, so we have this TCP transport ops, right? The question rather is, are we going to pipe everything into file server options? Probably we do. Because we're going to configure this complete server, which then will spread out its configuration to the other ones. I think that's the way to go. So we're going to have a transport. Or maybe we can just say that the transport options TCP transport options. That's nasty because yikes. TCP transport ops. Transport ops like this, right? Yes. TCP transport ops, that's voin. Wait, I'm thinking, right? So then we need to specify. Actually, no. We're not gonna do this. We're gonna say transport, and we're gonna, yeah. I see. Look what we're gonna do. Let's clear everything here on peer. That's what we need. We need an on peer, but we're gonna say like this. We're gonna say that the fs, no, let's say s, because otherwise we can. It's gonna be a new server, file server, by the way. We need to take options. We're gonna say the s. File server options. It's gonna be a file server options, right? What do we need? We need a listen address, which is gonna be, let's say, the classic one, 3000, one of my favorite ports at all times. The storage root. We're gonna say storage root is gonna be. It's pretty important because we're gonna say 3000 files. The reason. Or network, I don't know, man. The reason why we're gonna do this is because we're gonna boot up multiple nodes, right, to see if they are replicating their state, right? Because everybody needs to have that thing. Everybody needs to have the storage, the same deterministic storage, so we can make 3000 network, 4000 network, and all that stuff, so we can see that. Otherwise, they will store everything on our disk, right? That makes a lot of sense. Then we're going to say the pad transform func. We're going to say it's just going to be a gas, a default one. We can make as much as we want, but we already have a gas and I like it. You can implement whatever you want. It does not need to be exactly that content addressable storage. And then we're going to say transport, right? So the transport is going to be a TCP transport, and we can make it like this. We could say TCP transport is going to be a peer-to-peer new. A TCP transport like this, and we need to give it ops. So we're going to say TCP transport. Actually, well, man, it's fine. We're going to say TCP transport ops, and that's going to be a peer-to-peer TCP ops. What do we need? Let me open up TCP the other side real quick for the options. Transport ops. We need handshake func. Decoder and an on peer. I don't like to specify all that shenanigans. I think we need to have some defaults. Do we have that? Do we check that? Decoder decode. Damn. Do we have decoding? Encoding. I hope yeah, I see, I hope. Not quite sure. Let's say listen address, actually. So we don't need this listen address here. Man, this is gonna be nasty. Listen address, we don't need this. Back to TCP transport. Options. We need a handshake func. Can we do NOP? Peer-to-peer. I saw it already. Yes. A NOP handshake func, because for now we don't need one. And then we're going to say decode. You see how cool it is that we can actually control all these things. Of course, we only need to specify it once, but it's nice to have these interfaces and these functions so we can make our program much more generic and testable. Although this decoder is also an interface, but we're going to say this is going to be a peer-to-peer. We have a default decoder. Look at this. Man. We are literally gods. Look at this. We have a default decoder. And then an on-peer function. We need that on-peer function, but not for now. We could say to do on-peer func like this. And then we can say it's going to be the TCP transport ops. That's our TCP transport. And then we can say in our transport, which is going to be an interface, but TCP transport implements that, we could do this. Then we say file server opts, and then we say s start. It's going to return an error, so we could say if r is going to be this starty thingy, and the error is not nil, we can actually, let's just log fail out here, because it's just testing, you're just architecting stuff. Of course, if we make run, I think the problem is with make run that we will let's block here real quick, like this. Okay, the problem is we don't see anything happening. So I think we should have some default, and the birds are basically eating breadcrumbs outside. It's nice to see. But they are distracting me because they're with a lot. So some logging, I think in transport wouldn't be too bad. Right here, we're gonna say go accept, and we could here do a simple login. Actually, maybe a log or something. Print ln or nf. Actually, we could say TCP server. Actually, transport maybe. TCP transport listening. Actually, listen. Listening on port, and then we could say %s, and then maybe a new line actually, and then we're gonna say here t listen adder, listen adder, yeah, because this is yeah, it's fine. Make run. You see, so TCP transport listening on port 3000, all good, all set up. And I wish I could, this terminal on Windows, basically you see that the difference between my font size and this terminal font size is different. And I already looked it up, and I have this settings, zoom level. Where is zoom level? Zoom. I think it's in my other settings, but I'm going to plan remake my config and actually drive VS Code to the limit, because you can basically do everything in VS Code, right? You can hook into everything. I'm going to make it completely myself, completely minimalistic, even more performant as it is on my side. So I will share that. Just a side. I know this is forever store, but hey, I have no friends. Let me talk to you. I cannot explain this to my girlfriend because she doesn't understand. So talking to you, you understand what I mean. So that's nice. All right, let's go. So yeah, everything is running. I wanna. That's our server. So it's all fine. Wait, I'm thinking we could do a couple things. We could make this with an HTTP, which is fine, but I'm going to make this as a terminal app, right? So we have our terminal, and then we can basically run it, and then we can execute commands or something with it, right? We can execute commands with it, and we can add files to the terminal. And replicate it, store files with them. I don't know. We can do a couple things, but I'm thinking what the next step is. Do we need the peers? We probably need them. Let me quickly think about this, to be honest. How are we going to do this? I think we should actually find a way to encrypt these files, which is going to be a simple encryption. That's going to be fine. That's for another episode. Let's go to server real quick. So how are you going to use this? We have our file server, which basically will boot up. And then we need to find a way to command this thing. which could be directly, no, we can't. The thing is, file server right now embeds store. But do we want to store embed file server? We don't. So actually we give commands to the server, right? So we could say, which does not mean that it needs to be over HTTP. It could be, you could say f file server. File server, you're gonna say store or something. Store file. I think store is good. Key, string. How do we want to do this? Do we want to store bytes? Can we do this? Return. As store right. And we're gonna say key with the reader. The thing is, what we could do is basically have a channel for this thing. A channel with a reader. And I probably should thought about this a little bit more before I started this video. I'm gonna do this because otherwise we are losing a lot of time. So just to share my thinking process here. We have a storage, which is just a simple thing that can store files on disk based on the transform func and everything, right? Then we're gonna have a server. And this is basically the server that will be running as a daemon, right? And it will receive it will receive messages. It will be in a distributed peer-to-peer network. So if it's I know what the next step is. We need to have some messages, to be honest, instead of doing this store. I know what the next step is. My bad. So what we need to do is this server needs to have a loop. It's going to be as file server. Was this file server upstart? This is not. We're going to make a loop. You're going to make a for select loop, by the way. Let's make it a quit channel real quick. Quit channel is going to be a chan with we only... Actually, it's going to be a channel of an empty struct, like this. I'm going to make a channel is that? No, we don't need to do this. That's only when we actually want to close that. And of course we're going to say case, and I think we could do as transport. Don't we have that? It's this, right? Transport. TCP transport? What's going on? Transport? Yeah, it's transport. It's as transport. It's consume. I think that's the thing. Can we do this? Let's print ln real quick this message. We made an error. What's going on with this message? Expected. We made a little mistake, I guess. And I cannot... find where it is. What's going on? Unexpected default, unexpected case, 36. Oh yeah, we need. Is it case? Man, hey, what am I doing? What am I doing? Wake up, FMT. Wake up, my man. Yeah, yeah, I know. But we're also gonna have a case quit and everything, right? We're gonna say like this, right? We're gonna say case quit and you could return here, whatever. You could break here. I like to break. Maybe we can do some defer functions here, right? Defer. So if we return that, we can execute that defer functions, or we can use an outer loop, and then we can break this outer loop, and then do our shenanigans here, or logic. Everything is fine. Nothing is wrong. It's what you want, right? How you want to do it. What's going on? Why? Yes. So we have this quit, and I think something what I'm always doing is make this quit function here. Wait, this is loop. We could say func as file server quit or stop. I don't know, maybe stop or something. And then we could do something like we could do this close as quit chain, right? All right, so we have this loop. Where are we gonna loop? I think at run, right? Start. You could say go. Actually, we can block, right? We can block at start, or we don't block at start. That's a question. Are we gonna? I think it's always a good idea to block and then give the opportunity to the user to call this in a go routine. Because then he will have a quit channel if he wants. You can quit it if he wants. Yeah, maybe. Yeah, let's block. For now, not quite sure, right? And then we can do this, right? Yeah, so it's all fine. It's blocking. That's good. That's good. That's good. And actually, we could do. We can start it here, and we can say go func like this, and then we could say time sleep time second times, I don't know, 3 seconds, or let's say 3 seconds, and then we could say s quit like this. Stop, actually, what the hell? S stop, right? Is that a thing? Like this, right? Not quite sure if it's gonna work perfectly fine. I think so. Yeah, you see, it stopped, right? Because we closed our quit channel. But there is. We can actually do it like here. You see, that's why maybe let's do something different. Let's make it a defer func here for that shenanigans. User quit action. I don't know. File server stop due to user quit action. The thing is, because sometimes it can stop for another reason. I don't know. Maybe we can just do this. Do we need to close something? I think we could clean something up. Maybe the transport. I don't think we have a close thingy, right? In our transport, you see we have listen and accept and consume. Maybe what we need to have is something in our TCP. Actually, let me open up TCP transport, because it could be that we need to stop something, right? We have a listener, right? You see, you have a listener. So I think a good thing to have in our transport interface is a close. All right. Let's return an error because close and an error is always good. And then we can go to TCP transport because we don't implement this. We could say func TCP transport close. And we could say return T listener. Close. Do we need something else? To close, listen, what am I doing? Listener, right? Transport interface. Look at this, boys, girls. We are doing good stuff, right? So that's what I was saying in the beginning, like, okay, we have this transport interface, but we don't know yet what types of functions is going to be exposed. What's going to be needed. Although I don't want to have a whole complete shebang list of interface functions on that interface, because that's not a good practice. Then we can do some composability if we want. But I think, what do we have now? Let's open up transport real quick to check. I think 3 functions. I think 3 or 4 is the maximum. I think. Maybe, I don't know, 3, 4, 5 max, right? So we can do, we close stop, and then here we do quit, and then we have our defer func. We could say as transport close, right? Like this. And maybe we need to do more cleanup in TCP transport, like the P's and everything, but we will see. Make run, and let's see if everything is going to be fine, no errors or something. Okay, we have, because we say use of closed network connection. That's fine, we can fix that. New incoming connection, yeah, that's because we close that stuff. We're going to say TCP transport. Because this keeps running, right? This keeps running, so that's bad. So what we're gonna do is we're gonna accept here. So if it's closed, it's fine. Ah, I see. Yeah. So we're gonna close it here, right? And then we say this, and then we're gonna handle. Yeah. I see what's going on. I think we need to do something like this, right? Because we're closing it, this listener, I think it's fine. But we're gonna say here, if errors. And once again, if errors is R, it's going to be, I think it's net R closed. Yeah. You're going to return this function, right? That should actually fix our thing, I think, right? So then everything is nice and tidy, cleaned up. File server stopped to user interaction, that's fine. You see, we don't have any errors. It's the listener is being cleaned up. We fetch the error because, yeah, I think everything is fine. What we need to do later is to see if we have peers or something. How are we gonna clean that up, right? Because each peer is a connection and right, it's going to be here, right? So we need to check that later on if we have connections. How are we going to fix that? Yeah, so I think in the next episode what we're going to do is basically try to connect and exchange messages so we can, if one stores, we're going to try to connect with each other, and then if one is storing, we're going to have a list of bootstrap nodes, right? That's always important that you have a list of bootstrap nodes. So we can connect to 2 or 3 people, and then these people are going to give us their peers, and at a certain point of time, we're going to connect to whatever, maximum connections of 20 different nodes, or maybe 100, whatever we can configure. So they basically gossip and do peer discovery, right? But to make it simple in the beginning, we're just going to have a simple list of predefined Bootstrap nodes. We're going to connect to them. And if we store a file, we're going to broadcast that file to everybody else, right? That's what we're going to achieve in the next thingies. Then we're going to do some encryption, and we're going to make it better and better and better, right? All right. Let's continue with, I think, is going to be episode 8 of Forever Store. And the previous episode, I think, I'm pretty sure because I just made it, we basically created our file server. And now we need to, I want to connect a couple servers together, or at least 2. And I think what we need in the file server ops is basically a list of Bootstrap nodes, right? Bootstrap nodes, which is going to be a slice of string. And what we're going to do then is basically if we start, we could do a listen and accept, and then we could make a function actually. We could say like this is going to be the file server. Bootstrap network. I think there's going to be a return an error because it could be. And then we could say for s. Not quite sure what it's going to be. I think it's adder in s bootstrap nodes range actually. What is that? Let me quickly see. Yes, string. Okay, cool. Sometimes I switch these guys up with each other. And then we need to do something like s transport dial, right? That's what we need to do. And we don't have a dial, right? Let's return nil here, real quick. What we're gonna do in our TCP transport, actually here, I'm gonna make a dial function. And then we're gonna dial an address, actually a string. It's gonna return an error, right? So if you go to TCP transport, we can make this dial function. We have consume, close, yada, yada, yada. Let's make it here. It doesn't really matter. It's gonna be TCP peer, no transport. Dial adder string error, and we could say that the connection and an error is basically net dial, which is going to be TCP the adder. Man, my hands are itchy. What's going on? Random stuff. If there is an error, of course, we're gonna return null. Now we have a connection. So what we need to do is actually create a peer, I guess. Because right here in stored loop, handle con. We can do handle con. Is it? We can do handle con. But we see that it's outbound, so we could say in handle con, we could say, is this outbound? Like this here, right? And this is start accept loop, so this basically outbound is going to be. What did we true? We're accepting, so it's not an outbound, right? It's going to be false. And I think we could do here go t handle con, which is going to be the connection. And this is going to be true, right? This is going to be an outbound con because we're going to dial. And we're going to return null here. Does it make sense? I think so. Dial implements the transport interface. I'm always, after all these years, I'm not sure. Do we need to do a punctuation after our comments? Yes or no? I have no clue, right? Because some people do it and some people don't. And the question is, what is the correct thing? Is there a correct thing? What do you think? Let me know. Let me know in the comments. I'm curious. Although this is basically nothing we need to discuss, to be honest, because it's basically, it doesn't really matter. But still, sometimes that question raises up in my mind. So let me know what you think about it, right? Let me know. And it's up to you. You can choose. It's all fine for me. What is going on with this? I'm gonna mute my output volume of my audio capture. Yeah, that's not quite sure if the volume, guys, let me also know if the volume is fine. I have no clue what's going on. Let me know if the volume is good or bad, right? All right, so we have this dial, right? Can we do this? So we're gonna say here if R is gonna be, actually, we can dial them in a go way. We can say go func here, right? Like this, and I think we need to. Do we need to do add a string? We will see what the thing is telling us VS Code. What the linter is gonna tell us. As transport, we're gonna dial the address. This is just for logging purposes because actually, it's a good question, to be honest. Are we basically going to... This is returning an error, although we cannot return because we're doing it in a Go routine. Let's just print this, right? Let's just print this out. Why not? Okay, you see, this is basically already the error we have here, right? The warning. So it needs to be an address, which is a string, and then we say adder. All right, that's what we're gonna do. We're gonna bootstrap the whole shebang, and we're gonna do that in start, right? I'm thinking we are looping, but we're also bootstrapping the network. I have no clue. Let us see. Let us experiment. Yeah, we're closing the server here, yada. Yada, yada. So transport options is here. We're going to say that the bootstrap... Do we have this in transport? No, it's not in transport options. Actually, are we... No, I don't think transport is going to be responsible for dialing. Well, it's responsible for dialing, but not responsible to do shenanigans with the bootstrap thing. That's something we need to take care of ourselves. It's going to be here, bootstrap nodes, and we're going to make a list of a string. And I think what we're going to do here is basically, let's do 4000, although we are not connected, right? I'm going to see what error is it throwing at us. Yeah. Nothing. What's going on here? Are we calling this? Yeah, right. Let me quickly do this. What's going on? What is going on? We don't do anything here. What's going on here? I'm gonna say bootstrapping. Net work. Man, what's going on? I'm confused because I'm thinking already a step further. And I cannot do two things at the same time. Bootstrapping the network, that's fine, right? It should return as an error. Or at least panic, though. What's going on here? Bootstrapping the network, it's all fine. I think the problem is that we don't have any of these... Yeah. I'm gonna say attempting. Attempting to connect with this guy, and then we're gonna say transport dial the address, and then we're gonna panic. So it's probably something in TCP transport then. So there is no error. That's crazy. What the hell is this? What is going on here? Are we calling start? Yeah, we call start, right? And why is this? Maybe we stopped. Maybe it's basically it's trying to dial. And dialing timeout as basically longer than 3 seconds. That could be nasty if it's... So we're going to stop quitting the server. We're going to just wait what's going on. Look at this. I see. Maybe... No, we can do that, right? We can do that. We could do localhost, but this is going to be fine. We don't get any errors. What is going on? Connection refused, right? So returning an error, right? If error is not nil, return an error. We dial this here. Because start is maybe... What is going on? So we don't get any error, no panic. Attempt to connect with remote. We panic here. Whoa. Maybe I made some stupid mistake and you guys already can see it. But I cannot see it. After the panic. Man, I'm literally confused. I'm not gonna lie, I'm totally stuck here. It's not executing this panic. If R is transport dial the address and the address is not nil. Wait. Eternal! Oh my goodness! Oh my goodness! Oh! I could easily, it's 15 minutes in, I could easily remake this video, right? That's 15 minutes. I just delete my code, git reset hard, and go back and do it if everything is fine. That I'm basically a god and don't make mistakes with this. I'm gonna leave this in. I'm not gonna redo it. Fuck it. Oh man, look at this. Oh yeah, and I didn't see it, and you guys probably saw this. Oh man, I'm gonna leave this in. This is actually too funny to delete. Oh man. Oh. It's actually smiling because it's. I thought, what the hell is going on? This makes no sense. Okay, cool. Man. After the panic and everything. Yeah. Okay, what's going on? It's still not doing anything. Okay, that's because. Wait. So we dial this thing, and if the error is not nil, we're gonna return the error and dial here. Which actually should panic. Man, what is this? It's Arniel. Anthony, please can you stop doing this shenanigans for once in your life? All right. What the hell? I'm gonna leave this in. It's just too ridiculous. Okay, cool. This is fine. So we're gonna print this error here, and we can actually return this. Yeah, let's do not go routine this, so we can actually have an. But do we care if we don't wanna? Actually, guys, I don't think it actually matters here. I think we're gonna. I think we're gonna break. No, continue actually. If this guy is not dialing, and then what we're gonna say is basically do the go func anyway. Here. I'm gonna do the go func anyway. Okay, we cannot continue. Why not? Oh yeah, I see. Of course we cannot. It's another thing. It's fine. Oh guys, what is this? We're gonna print this thing. Yeah. Now we need to share. We block. Are we blocking? I think we're blocking. Make run. Okay, so the connection is refused. That's fine. No big of a deal. It's good, right? So what we're gonna do is, oh man, it's too funny. What we're gonna do is make a function here. Actually, I'm gonna make it at top. Make a server. I think we're gonna set the listen address here real quick. Listen address, which is gonna be a string. And actually, what I'm gonna do is also the root, which is gonna be a string here. And it's gonna return as a file server. And maybe an error? I don't know. This is actually just a convenient function to test things, right? So we're gonna do all the shenanigans here. Copy the whole shebang, paste it in here, right? And then we're gonna say that we're gonna take the listen address here. All the same. We could do something nasty. We could say listen address plus this, right? Bootstrap nodes is going to be we cannot do this actually. I'm going to say string root and then nodes is going to be a slice of string, right? Yeah, like this. Actually, I'm gonna do it like this. String. Wait, it's gonna be this, right? Can I do this actually? Probably we can. It's fine. Then we have the server, and we can actually return a new file server here. Do we? Yeah, why not? Return a new file server. And then we can say something like that deleted this whole thingy. And we could say S1 is going to be make server actually. Make server. This is going to listen at 3000. What's this? The root is going to be. Actually, we do the root itself. So we don't need the root. Yeah, it's fine. And then we're gonna say bootstrap nodes. That's gonna be 4000. The problem is, actually, he's not gonna have one. Doesn't matter, because if there are none, we're not gonna connect, which is fine. Then we're gonna say S1 start. Maybe an error. Actually, could we do? We can't, because we need to run this in a separate thing. Like this, right? And maybe we could do. Is it not gonna format this for me? What's going on? The reason why I want to do this in a function is because then we can actually catch. We can do this, right? Log fatal. This, is that a thing? I think it is. Yeah, it's fine. We're also going to make a server 2, which is going to be this guy, 4000, right? And then we're going to say that the bootstrap node is going to be 3000, right? Which is easy. And then we're going to say here, as to start, like here, what's going on? And that will actually boot up these two nodes. I think, not quite sure. Yeah, it's working. The only thing we need to fix is transport listening. Yeah. Attempting to connect with remote 3000. TCP transport listening on port 3000. Attempting to connect with remote. That's because we have no bootstrap nodes. What we could do is basically if... are we gonna do this here? I think we could do it here, right? You could say if the length of as bootstrap nodes is 0, and maybe we have an empty string. Maybe we have an empty string. That could also be the case, to be honest. Yeah, it's an empty string. That's nasty. Probably because we do it like that. Although that check is good, what we could do here is basically if len adder equals 0, we could say continue actually. You see, perfectly fine. So we do this stings. It's fine. We have a logging. Do we actually want that date? I'm not sure. Maybe we're gonna make a prefix. In some sense, we could do that later. TCP transport listening. Yes. We have a new incoming connection. That's fine. New incoming TCP transport. I guess new incoming connection. I don't like the way it doesn't tell us anything. Okay. That's all good, So what we're gonna do? Do we have a send in the spear? Wait, let's first things first. Let's make our server. It's gonna be a map string. It's gonna be a peer. A peer-to-peer peer, like this. I want to have a sync mutex. Wait, let me do peer lock. This is sync mutex, right? Peer is gonna be make me a map string No pointers. Peer is like this is fine. It's gonna be a peer-to-peer peer. Yes. We could also do some mechanic where we add peers and delete peers based on a channel. But yeah, I don't want to over-engineer channels. You know, I did this in my blockchain series. I did this in, I think I did this everywhere. This add peer with these channels. I'm not gonna do it this time because why not? Why not a mutex? It's not gonna do anything. It's not that it's a performant action. Adding a peer is just, I don't know. It doesn't matter. It doesn't matter. Now we need to add peer func, right? Func file server on peer. It's actually nice to test our own peer-to-peer lib. Maybe we should actually make one, but actually open source one, but a good one. And I think for now it's working fine. We have on peer, which is basically where is dial listen except close. No, on peer is basically just where is on peer coming from? It's just a TCP transport thing, right? On peer doesn't matter. The thing is, should that be in an interface where the transport needs to call on peer each time it has a peer? Actually, maybe this needs to be in our. Of course, it needs to be because. No, because it's TCP transport ops. Next level, right? Or not? Next level or complete garbage? It's either one of two. It's binary, right? There's either a next level move, or it's either just complete dog shit. There is no in between. And the weird part is that I have no clue what it is. Because, you know what? You could say, yeah, but transport needs on peer, right? Because each transport will have a peer, which is an interface. And each time it's connected, the transport can call on peer, which then everybody has that transport interface, can call on peer on it, and yada yada. That's not true. I think this is the best option, where we have an on peer, which is a generic function, which is also generic, right? It's not something that's hardcode, it's a generic function. This is actually crazy because this TCP transport ops and we do on peer, which in my opinion should not take a peer, but a TCP peer, to be honest. Yeah, I think that's the thing. Maybe we're gonna change that. Let me know what you think about this. I think it's fine because now what we can do, I think, is where is our on peer thingy? And that's what I love to do the most, man, is making these things. It's insane. I like it. And once we have a good lib, a good peer-to-peer lib, we can use it in all of our projects, right? And it's a lot of boilerplate all the time. So we have on peer, which will basically takes a P, which is going to be a TCP peer. But that's nasty. Actually, we could say peer. It doesn't matter. So this can be compatible with everything later on. Something we need to think about. And an error, right? Because this takes in a peer. Oh, wait. Actually, I think I'm going to keep it this way. Because I'm going to keep it peer. Because why? Because this will make it compatible for other transports. This on peer. Because we have this pieces. Yeah. Because then we can call on peer on each transport. Because now it's only TCP transport, but it could be that we have WebSocket transport, UDP, whatever you want to, gRPC, whatever. So and that's why we have this generic peer thingy, right? This could be a peer over TCP. Could be a peer over UDP. So this on peer can work on everything. If we decided to, if you or me or whatever is going to use this, decided to add other transports. Right, okay, so this debate is done. The debate is closed. And hey, guys, listen. If you have remarks or things you think, hey, why don't we do this? Or let's collaborate, right? Hey, I'm open for everything. I'm open for everything. This is how I should do it, but it's not. This does not mean that this is the best way. It is a way. It works for me, but maybe something is better, right? We don't know. And actually, to know that, we need to use it, right? That's why I'm going further and further and further, because by using different stuff, we know, damn, actually, or a function we just implemented is not gonna work after a couple days or something, right? And that's why you can make things better and better. On peer, what we're gonna do with on peer? We're gonna say as we're gonna peer lock this thing, and then we're gonna say defer as peer lock unlock or boy, and then we're gonna say as peers with how are we gonna store this? That's a good question. It doesn't actually matter. We could say peer. We cannot store this guy. We need to have some more function in our interface, peer interface, right? We only have peer. I think we need to have like address, or maybe we can make it compatible with Golang, and we say remote adder, which is gonna return a string, right? And then TCP peer close, and we're gonna say func p TCP peer, and then we could say remote adder string return p com remote adder network. We don't care. I see. It's are we gonna do a net adder? Why not? Let's make it compatible. I mean, if we make this more compatible with the Go thing, I think it's gonna be good, right? Especially if we want to open source this peer-to-peer lib, returning a net adder. Think a lot of people will appreciate that, because, to be honest, let me go back to TCP peer, TCP peer, TCP. It's in transport, yeah. And another thing is basically, yeah, why is TCP peer in TCP transport and not in TCP peer package, TCP peer file? It doesn't matter, right? I like to group things. A lot of people like to split things out and make TCP peer a file with only 20 lines or something. I think it doesn't make any sense. But that's also a personal preference. I don't matter. I don't care. I like to group things in one file because, yeah, I don't scroll through the files that much. I just try to search for things, and I don't care if a file is 1 million lines or something. 1 million is too much, but hey, you get the point, right? So remote adder is basically, let's say a remote adder implements the peer interface and will return the remote, and will return remote address of the underlying connection of the peer, of its underlying connection, maybe of its underlying connection. All right, that's fine. So now back to here, we could say as peers p, and then say we could say remote adder. But we are using strings. We could actually use remote adders ourselves, but we're gonna say string like this, right? And then we're gonna say it's gonna be p, right? That's it. And then we're gonna return null. So yeah, that's this. And maybe we're gonna do fmt log or something. I don't know, log print ln or f. connected with peer. Wait, connected with, can we say added peer to the peer map something? Connected with remote, which is going to be this. And we can actually do P. We can actually do something nice, right? Because P is just a peer. I don't think we have a stringer. Yeah. We could implement string. Yeah, we're not going to do that. We're not going to do that. We can say a remote adder because a remote adder will it has a stringer interface, which is cool. Because I think if you go to remote adder, it's going to be a net adder, right? You see, this implements a string. Do we want that to be implemented in our peer? I don't think so, right? I don't think so. Connected with remote, right? Let's see what's going on here. Are we doing... Wait. First of all, we have our own peer, but of course we need to implement this into... our TCP transport. Where are we making this? You see the problem already? Let's go to main, because we need to implement this on peer. We need to inject the pointer of this function into TCP transport, right? This on peer, you see, it's going to be on peer here. So that basically means that we need to have our server first. Can we do... Let me see what I can fix. So the server is going to be this guy. We're going to return the server here, and then we're going to say that the on peer, transport.on peer, is going to be the server on peer. So yeah, is that going to work? Make run. Yeah. So we have a new incoming connection from our TCP transport. I don't think TCP... we actually want that. What's this new incoming connection? Yeah, we don't want that actually. Let's log in. Connected with remote. So they're both connected. It's pretty fine. Actually, maybe I was thinking maybe we want a string. I don't know. Or maybe we don't. So we can connect with each other. That's fine. The next thing we need to do is, I think peer has a send function. TCP peer is going to be a longer episode, a little bit, doesn't matter. Yeah, so TCP peer has this con. No, wait, where is transport? Yeah, peer. Remote adder close, we also need a send, right? We're going to send, which will take in a slice of bytes, and it's will returning an error. That's what we're going to do. Very important. And we're going to go to TCP peer transport. New TCP peer, remote adder close, and all that stuff. We're going to write, which is basically a very simple function. We're going to say TCP peer send bytes like this, and we're going to return an error. Yes. And the only thing we're going to say is underscore r is going to be peer com write. Right like this. We're going to say b, write the bytes, and then we're going to return the error. We could also just start this thing, but I don't want to do that. We are handling the read functions here, which is fine. Yeah. So, and the next thing we're going to do basically is, now that we have the send function for our peers, is each time we want to store, we're going to send that to the other one. He's going to get that message, a store message, and then he's going to also replicate it. So that's for the next. It's going to be amazing. I'm actually thrilled to continue. The previous episode, I think we created our server, right? we created our server, which basically, I think we also had something in main. Yes, we created our server. We have connected server 1 with server 2. Let's make run real quick. What's going on? Make run. Yeah, so they're basically connected with each other, which basically means that we can start sending files, right? Of course, we need to encrypt and all that stuff. And another major important thing is that we cannot, for privacy reasons, I don't think we can store. I will explain, because we're also storing a key, and it could be that our key would be, for example, my nudes, which basically we don't want that key is being stored on remote servers, right? So we want to basically store directly the hash of the keypad, of the pad key, right? But that's for later on. Today we're gonna do, I think, some interesting stuff, because we need to stream large files over the network, right? So let's get started. Yeah, so let's open up main. That's already here, right? Let me put that a little bit higher. So what we're gonna do, for example, is let's say we have as server 2 is being started, right? So what we could do is basically say something like S2, and we could say store file, right? Something like this, store file at a given key. And then we're going to say, I don't know, we could say that the contents, the data, it could be an IO. It's going to be a new reader. Actually, not IO, it's bytes, right? It's going to say it's going to be bytes, new reader. And it's going to be, for example, my big data file here, like this, right? And then we're going to store this data here. That's the thing. And what's going to happen is, let us go over to server. Bootstrap network. Yeah, let's do it here, right? So we could say, for example, this is going to be S, it's just a file server, right? And we're going to say store data or store file, anything, right? It could be legit anything. It's a forever anything store, right? That's going to be, we're going to store this at a certain key, which is going to be a string, right? And then we're going to say it's going to be an R, which is an IO reader, and we're going to return an error here, right? That's the thing, like this. Let's return nil for now, right? So the first thing we need to do is basically, first of all, store this file to disk, right? Then we need to basically broadcast this file to the network, right? That's the thing, to all peers. Actually, store this file to all known peers in the network, right? Because it could be that we only know 2 peers, but these peers are going to broadcast it back, so everybody is going to get that file. That's the main goal of this. And of course, we need to encrypt that stuff, right? That's for sure. That's for sure. So how we're going to do this is basically, let's make a simple broadcast function, right? So we can try to scaffolding this out. Let's say it's going to be broadcast. And we want to broadcast a P. What's going on? We want to broadcast a P, which is going to be a payload, and we're going to say error, right? So this payload is going to be a type, which is going to be a struct. And this payload is going to have a key, right? Because we're going to send this file, but the people need to know, the receivers need to know, the peers need to know which key is going to be stored. Of course, for now, we're going to just store the key like it's going to be, let's say, let's go back to main. It's going to be the key, for example, my private data, right? That's going to be my key. Of course, we don't want to store my private data as a key, as plain text. It could be, we know that, but the others cannot know that, right? Of course, it's not that big of a deal because everything is being encrypted, but still, right? Still, privacy first. That's very important. So, but for now we're gonna just store it like this. We're gonna send it over like that, and then later on we're gonna just put the hash. So actually, maybe we should already put the hash. Anyway, we will see. So there's gonna be a key, which is gonna be a string. That's what we know, right? And then we're gonna have I don't know, maybe the data, and that's gonna be a byte, like this, right? It's gonna be a bunch of bytes. So, but we want to stream, right? We want to stream that bytes because, of course, we need to copy this once, but we don't want to copy this to, you know what I mean? We want to stream this to all the peers because if we, it's very important lesson actually. If you go to peer, TCP, no, yeah, TCP is fine, right? We have this send function, right? You see here, con write. So it basically takes these bytes all the time. They want to do that. We want to basically stream the whole shenanigans over the connections to all the peers at once. Some coffee. So, able to do that, we're going to refactor peer a little bit. Let me return nil here, right? So what we're going to do is, what I want to do here, let's make this more clear. So in broadcast, we could say, for example, for underscore peer in range as peers, right? Then we could say, for example, let's read the bytes here. It's going to be, for example, B is going to be IO util read all. And we're going to... Actually, the payload is already bytes, right? Yeah, no. What we could do is basically do make a buffer or something. There's going to be a new bytes buffer like this. And then we could say if R is going to be hop a new encoding, new encoder. And we're going to say the buffer because that's a writer. And then we're going to say encode the payload, right? And if the R is not nil, we can return the R, right? Return the error here. Something like that. What's going on with P? No, it's not. It's going to be... Yeah, this is the buffer. Yeah. And then what we could do, so everything is in the buffer right now. And then we could say, for example, P send buff bytes. What's going on here? Buff bytes, like this, right? That's something we could do. But I don't like that. So what I want to do is basically delete this whole thing. What I want to do is basically this. I want to return hop, or actually any encoder. We can make an interface for that. New encoder. And I want to basically encode directly to the peer's connection, but we don't have access to the peer connection. And then we could say encode the payload, right? But then, and then we can loop to all the peers and do the same with one peer, if that makes sense. So let's make this. You're gonna make this very clean. Listen, this is gonna be insanely good. So in able to do this, what I want to do is if we open up transport, right? This peer interface, we have remote adder and all that stuff. And we could say, so we need the con here, right? We need the con of the peer to make this work, right? But it's a private variable. So what we could say is make a function, right? Like this, make a function and say con here, right? Which is going to return a net con, because a net con is basically a reader and writer, right? That's what we could do. Why is it not working? Yeah, of course, because TCP/IP does not implement this. But why are we doing this, right? It can be even simpler. So instead of doing this, we can do interface embedding, right? We could say send can be here. We could just do this, right? We could say net con, just like that. And then instead of saying con here, we could just do peer, because peer is already will have all these functions attached to it, right? So if you go to TCP peer, instead of doing this remote adder close stuff, right? We can delete all of this, and it will be perfectly fine, I guess, because yeah, the only thing we need to do here is instead of making this con a variable, we could just say netcon here, right? Just a netcon. We could actually say that this is going to be the underlying connection of the peer, which in this case is a TCP connection, right? And instead of doing this, we can, as a private variable, we could do this, make con public, right? So what happens now is that the TCP peer will instantly implement as a netcon. It will be a netcon. It implements all these functions. So that means that we can use this directly as a writer or a reader, right? Directly into this encoder. Of course, P is payload here, so not going to work. But we could do, for example, this, right? For range peer in as peers, like this, right? We could do this. We cannot return because it's going to be an issue. We're going to say gob new encoder peer directly. You see? That works perfectly fine. And then we could say if r yada yada, r is not nil. If the error is not nil, then we can return the error, right? And in this case, we're going to return nil. This will work fine. But still, what we could do is even something better. And it's basically say that we're going to make peers. And peers is going to be, I want to stream this directly to all the peers, like a streaming service. So what we could do is say peers is going to be a slice of peer, right? Any peer. It's going to be a peer-to-peer peer, actually peer-to-peer peer, like this, right? Then we're going to loop for, actually this is going to be peers, yeah. Let's delete every 10. And then we're going to say peers is going to be append peers peer, like this. So we have a slice of peers. And then what we could do is say that we have a multi-writer. Multi-writer is going to be an IO. Multi-writer, actually. And we're going to say it's going to be peers. I think it's going to be this, actually. It's not going to work because multi-writer wants... we're going to say it's going to be IO writer. Right? And that's going to work perfectly fine. So this is very important to understand, right? So our peer, or TCP peer, or even peer in general, is an interface. But peer embeds the netcon interface, which basically also implements the writer-reader interfaces, right? This is the peak of Golang engineering. I swear to God, this is the peak of Golang engineering. So netcon also implements reader-writer. So what we could do is basically tell us that the slice of peers can be a slice of IO writers, which we can just append peers into it. So we can then make a multi-writer of all the peers, and then we could just return gob new encoder, which is going to be the multi-writer, encode me the whole payload, and we're done. That's nasty. That's not nasty. This is basically insane. I'm not gonna lie. Yeah, I did this before using the multi-writer, and we're gonna do some cool stuff. Yeah. So that's it, right? That's cool. What's going on in main here? Yeah, it's store file. Yeah. We don't have store file, right? Store data, actually. What's going on? Right, my private data. So now we are here in store data. So this is interesting because what's going to happen is that we need to make this payload thing, let me quickly delete this and paste it in here. And we, of course, going to split things out. So what we're going to say is that the payload, we're going to make a payload. So the first thing we're going to do is basically store this on disk. And you can see that we're going to have some problems. So we're going to say if r is going to be as store write the file, the key, the reader. If there is an error, we're going to return the error, right? So first of all, we're going to store it to our own disk, which basically means we're going to read from the reader. But at this case, here, after we read, the reader is empty, right? Because there is already being read. It's completely empty. So what we need to do, because we need a reader, because we need to also send it back over the network, right? So what we're going to do is, I think we're going to make a buffer, which is going to be a new bytes. And actually, I can show you first. Let's do some demonstration what's going on. So let's say, let's make the buffer. Yeah, let's make the buffer. We're going to say it's going to be a bytes buffer. Actually, new buffer, maybe. It's going to be a new bytes buffer. Right? And then we're going to say IO copy. We could say, we don't care of this. We're going to say the error is going to be IO copy, which will basically do a streaming copy of reader and writer, destination and source. So we're going to say, wait, what's going on? I think copy, the first thing is the destination. What's going on? I cannot. Man, nasty. Copy is destination. Right? So the destination is going to be the buff, right? And the source is going to be the reader, right? We're going to say if the error is not null, we're going to return the error here, right? And then we're going to say fmt println and print me the buff bytes. Right. So if we're going to say here, yeah. If we run this, wait, of course, we basically block here, right? So we cannot do anything here. So we're going to say go. And let's time sleep here so it has time to boot up. We're going to say time sleep. Let's say 2 seconds, right? That's maybe 1, actually. Yeah. Right. So we're gonna go start this thing. Right. So we written to disk. Right. That's fine. We written to 22 bytes to disk, but then we see that the buff, even though we copied from the reader, the buff is empty. So if we want to send that buff, because we're gonna make a payload, right? We're gonna say here this is gonna be the P, which is going to be a payload. And actually what I want, this should be a pointer to a payload because I don't want to copy the shenanigans into a function, right? Because if you have large files, so we're going to point to the payload. And then we're going to say that the key is going to be, okay, we need to have the pad key, so we are sure we don't expose the plain bytes of the key. But yeah, that's for later on. So we're going to say it's going to be the key. And then we're going to say that the data, right? The data could be the buff bytes, right? That's what we're going to do, buff bytes, right? And then we could say here, return as broadcast. We're going to broadcast the payload. That's what we're going to do, right? And then we're Gucci. But the problem is that it's going to broadcast nothing, right? You can see this, I think, if we do make a run. Actually, let's block here so we can see what the other side is going to receive. Make run. You see, it's getting this garbage thingy, right? Wait, let us make this real quick. This is actually interesting, guys. This is so interesting. You probably need to watch this a couple times to completely understand. But this, if you know this, you're literally a god. If you can do this, guys, I swear to God, this is years of experience and years of figuring things out, how things work. This is nasty. So this is transport.consume, right? So we're going to print out this message. But what we're going to do is basically say that we're going to decode this into a payload. So we're going to say P is going to be a payload. Or actually make it better. P is going to be a payload, right? And then we're going to say if R is going to be gop. What's going on? Gop new decoder, right? We're going to decoder. Now, hence so called. What are we going to decode? We're going to make a bytes new reader p. No. MSG payload. Actually, we could make this into a reader directly from the thing. There are so many things we can do, not gonna lie. And I'm gonna say decode me this thing into a payload. Can we make this a pointer? I don't think it's gonna work. Yeah, it is. If the error is not nil, then we're gonna basically log fatal out for now this error. Because actually we should not fatal out, we could loop, right? Right, this is what's gonna happen, right? Let's make run. Wait, what's going on? Is payload. I think it's just wait, fmt println. Let's say we're gonna receive. Let's see if receive. Version refused. What's going on? Yeah, I think we need to. Who is dialing? Maybe we need to sleep here. Give these guys time to boot up before they connect. Yeah, so we receive a message. Yeah, we receive a message. Cool. Yeah, I forgot. We need to do this. I'm going to say printf, right? And we're going to say there's going to be a percentage plus v. Like this, we're going to make a new line, and we're going to say it's going to be the payload, right? So let's make run this again. You see, so it's telling us the key. So that's the first problem we have. So this is being received on the other side, right? So we store to disk and we broadcast, and this output is basically on the other node of the network, right? And we already see it's my private data, which is not good. But hey, we're gonna fix that. But you can see that the data is empty, right? That's a problem, and that's because we already read from the reader. Can I not close this? Yeah. So how we're gonna fix this is we're gonna do some nifty mechanics, of course, because we are the club of the high-value engineers, high-value software engineers. So what we're gonna do is here. So what we're gonna do is we're gonna make this buff, but we're not gonna copy, right? What we're gonna do is what's going on? We're gonna make this buffer. Then we're gonna make a T, which is gonna be IoT reader. Is it a new T reader? No, it's IoT reader. And it writes through the reads from. Yeah. It writes through. So we're gonna make the buff here and the R here. Is that correct? So we're gonna read from. Wait, am I confusing this? Yes. Yeah. It's this. It's gonna read and it's gonna write to buffer. That's cool. But we need to do this before we write this to the store, right? Make the buffer here. And then we have this T reader, right? So what we're gonna do is we're gonna write a T reader. And then we have the buff bytes. Boom. We written to disk and we broadcasted it to everyone. That's what we did. So because if you don't believe me, we're gonna say buff. Can we do buff string? Actually, buff string is here. Yeah. What we're gonna do is on the other side. We're gonna say story that we're gonna say this one. Let's do a string of p data, and then make run. What's going on here? Unexpected end of file. You see? Okay, I think there are some issues, and it's basically the sleep. We need to make sure that it's okay because they are. We will see. So you see my big data file. That's what we receive on the other side, which is perfectly fine. I see sometimes we have an issue, I guess. Let me make run. We will debug this. Yeah, I think it's something to do with this connection, with the time sleeps. Maybe second is not enough. We will see. We will see. Yes. Okay, so the thing is, this consume, we're not gonna make our logic here, right? That's not the best approach. What we're gonna do is basically, we're gonna make a function. We're gonna say here as file server, because we also need to store it on disk, right? On the other side, we're gonna say handle message, I guess. Handle message, or handle payload is maybe a better thing. It's going to be a P, which is going to be a pointer to a payload, like this, and we're going to say an error. I think the payloads. Wait, I have an idea. I think it's going to be handle message, which needs to be a message actually. Oh, we can make this even better, I'm thinking. So we have a payload key string. We could also make a message, which is going to be sent over the wire. So it's going to be a structure. And we're going to say that the... man, this is nasty. Maybe you should say from. It's going to be a string. And then we're going to say that the payload of the message, that could be any. I think something like that, because then we can actually... and this is a payload. I don't think it's going to be... We could make it as a data message, which is going to be a key data. So this is going to be a data message, right? But then we need to make this into a message. So we're going to say, we're going to broadcast. We need to broadcast a message. So we're going to say here, a message, and we're going to encode the message here, right? And then we're going to say broadcast a message. And we need to make a constructor. We're going to do that later on. And it's going to be from. It's going to be... And we don't know the listen address. That's crazy. We don't have that. That's maybe interesting. What we need is the listen address of the transport. Let's go to transport real quick. Dial, listen, and accept, consume. Actually, do we need that listen address? I think we need, to be honest. listen adder, which is just gonna return the listen adders of the transport, I think. Is that a thing? Because we make a new file server, but we don't store the listen address. Because we store the transport here, I see. Yeah, so I think a listen adder is pretty fine for a transport interface. TCP transport, let's make this real quick. We're gonna say func p. This disappeared. We don't need that. Transport here. Here. Func t. Let's put it higher. It's gonna be a TCP transport listen adder. It's gonna return a string. We're gonna say return the listen adder. We don't have this in it's private, I guess. We don't. What's going on? What's going on here? Ah, it's... I see what's going on. It's the same thing here. How are we gonna fix this? Because we make the transport, the problem is, in main, you can see we make the transport. We make the transport here, and then we put that into, yeah. Wait, we're gonna fix that later on. Where is transport interface? Because I don't like to have a listen address here, to be honest. So we're gonna just do something nasty. And we're gonna say from need to be to do. And then we're gonna say that the data. No, it's gonna be the payload of the message, I guess. Yeah. The payload is gonna be P. It's this data message here. Yeah. And this is gonna be then we're gonna say it's gonna be a message. Right? And we're gonna encode into a message instead of a payload. Because we can send other messages also, right? A message here. Oh shit, it's the same. That's nasty. Let's say M. Payload like this. There's any. We need to switch this. And then here we're gonna say handle message, which is gonna be a message, We're gonna return this. Actually, we could check the error. If R is gonna be S, handle the message, which is gonna be the M, and M, and M. And if the error is not null, we can log. Yeah, we need to print these things actually. Right, and then we call this function. And what we're going to say here is basically switch MSG payload type. Going to be a V actually. We do this, and we're going to say case if it's a data message, right? Then we could say print. Actually, we can do it like this, right? We can actually say print. Is it printf? We don't have that. That's nasty. Let's do fmt. Printf. I'm gonna say received data plus v, new line, v. Let's return null. Is this gonna work? All right, we still have this unexpected end of file. We need to figure out why this is happening. We will see. Normally it's gonna work perfectly fine. No, it isn't. Wait. What's going on? So this is data message, which is gonna be the payload. You're gonna broadcast that message, yeah. Key, biv, and bytes, and then we're gonna say this is from. I don't think we need the from, by the way, but hey. The end of file, why do we have that? Is it biv bytes? And the message in broadcast, and broadcast will actually basically hop and code the message I think it should work, but I think we have. Let me quickly check what's going on here. Do we need to sleep longer? I have no clue, to be honest. I don't think it's a problem, to be honest, guys. But hey, we can try. Okay, so we write it. That's the thing, right? So that's cool. So if we open up our thing, that's fine. Still have some issues. I think you make a mistake. My big data file here. So that's perfectly fine in the 4000 network, which is basically server 2, all working like intended. Just one more thing. I wanna. What is this? As you can see, the camera is at the top right, and I have the Lunar Vim shenanigans going on. I think it has a better terminal. Bigger fonts and everything, so that's fine. So let's make run, and so we can continue where we left off, right? And I'm gonna say the next couple of episodes gonna be super important. We're gonna do advanced stuff, and I can swear to God that if you know these concepts very well, you're gonna know more than everybody else. I can swear. If you grab 10,000 Go developers, I think only a handful will know how these things gonna work. So we see that we have this corrupted data here, right? So basically, that's because if you go to our decoder, right, you can see our decoder, which is basically, let's open up TCP. I'm gonna show you real quick. Normally you guys should know if you follow along. The decoder is basically the staying in the read loop where we decode a message, right? And what we do is we decode a prefixed set of bytes, a pre-allocated slice of 1028 bytes, and you can already imagine that this is perfectly for our normal messages, but it's not suited for big files, 4 gigabytes, 8 gigabytes, 10 gigabytes. That's impossible. It's already too small, and upping the size will basically make every computer crash because most of the computers don't have so much RAM to work with. So what we're gonna do is we're gonna stream. We're gonna stream data directly to a file, right? So we need to do some changes for that. So we have our server here. The first thing we're gonna do is we're gonna delete some stuff, test some stuff, and then make it better. So basically, this data message, we're gonna delete this real quick. This message is perfectly fine. Everything in here, I'm gonna basically comment out. And the next thing we're gonna do is basically, let's test something. Let's test something real quick. I'm gonna say for underscore peer in range as peers is going to be this. We're going to say if r is going to be %, some bytes, which we don't have yet. And then we're going to say r not null. We're going to return the error. Here, then let's make a simple message. I'm going to say this is a message. This is from. Are we actually going to use this? I don't think we're going to use this message from, by the way. We're going to say that the payload is going to be a slice of bytes. Just to test. This is just to test, to give you a concept, what's going on and why we need to do this. It's very important to understand. This is really, really, really important. Trust me. So we're going to say here, for example, there's going to be the storage key, for example. We're going to send the storage key. A simple thing. Then we're going to actually encode this with GOP encoding. We're going to say if r is GOP new encoder. And we're going to say we need a buffer actually. Let's make a buffer real quick. We're going to say buff is going to be a new bytes buffer, which is basically just exactly what it is, a bytes buffer. We're going to encode that in the buffer because a buffer is a writer and a reader. And then we're going to say encode, and we're going to encode the message. I don't know, do we need a pointer? I don't think so. And then we're going to say r is not null, and we're going to return the r. Let me find the plus sign here. What's going on? Like this. Perfectly fine. So we're going to have a message. We're going to send that over to all peers. And then we're going to return null here real quick. We're going to clean everything up. Trust, trust, trust. And then we're going to see where we're going to fetch the message on the other side of the network. On other nodes, right? Where do we do this? It's here, right? So we're going to handle this message. We're going to comment this out. We're going to comment this out. We're going to call this. We're going to delete this. This is going to be an RPC. This is going to be an MSG. We're going to say RPC is going to be RPC payload. We're going to decode the MSG like this. And then we're going to say FMT print ln. Or maybe print f actually. I'm going to say receive percentage %s. And we're going to make a string out of the MSG payload, and we're going to cast that to a slice of bytes because payload is an and we're going to make better messages. This is just for testing. A payload is an any type, and we are sending bytes on the other side. Remember, we made this storage path byte thingy. So we're going to cast that and we're going to print that out. So let me quickly run this to see what's going on. Of course, in this peer send, yes, we need to put in the buff bytes. Just like that. And we're going to say make run and see data message. Okay, we still have some relics left over. Message. I'm going to search for these guys. Here one, and then we have, I think that's it. Let's do make run. Okay, so the thing is running. That's fine. Okay, so we received storage key. So everything is working like intended, right? So, but that's not what we're going to do. We are going to send a message type, a specific message type. It could be, hey, a message type store file, which will basically means we'll hold the key. And so we know, oh, the next thing we need to do is open up a stream. Because we're going to receive a file and we need to store it, right? That's what we're going to do. With all complications that probably will arise. So how are we going to do this, right? So we're going to mimic a stream. We're going to mimic a stream. We're going to mock one here, right? So basically this one. So we're sending this, right? What we're going to do is we're going to make a simple payload, right? And we're going to say this is a slice of bytes. And we're going to say this large file. Right, this is going to represent a large file, which is clearly not, but hey. What we're going to do then is we're gonna again loop again to all the peers, and we're gonna make this better. It's just for demonstration, right? So the first thing we do is we send the message describing what we're gonna do, storing, retrieving, blah blah blah. So and then we're gonna send the big file. That's what we're gonna mimic here. So we send the message and then we send the big file, which need to be streamed, right? But we're not gonna send the buff bytes. We're gonna send the payload, right? Yes, right. That's what we're gonna do. So if we test this. Right, you're gonna get some issues, and that's normally fine. That's because let's open up server. We are in server, by the way. Right. I think we already received this first, right? Yeah, it's this unexpected shenanigans. So we received the storage key already, which is fine, but then something happens, right? So we're gonna fix this real quick. And actually, what I want to do here is a new line, right? So what I want to do is, in this case, I basically want to read, right? So we first read the message, and then we're gonna open up the file for the stream, right? So what we're gonna do is I'm gonna make a buffer. No, we don't need to. Wait, the first thing we're gonna do is, we cannot read here, right? It's very important, and it can be some confusing, I'm not gonna lie. But hey, you can always jump in the Discord and ask questions. So what you could do here is basically, we cannot read here, right? So, well, we are reading here, but we always transferring this RPC message to our server. That's the way we communicate. But we need a way here to read from the peers, if that makes sense. And the way we're gonna do this is to fetch the peer first. So we're gonna say that the peer OK, and that's why we need to have this from address in the RPC method, right? So we're gonna say peer OK is gonna be as peers RPC from, right? And we're gonna say if not OK. Maybe I'm gonna quickly, can we return an error? No. Let's panic here, because that's very important. We have a peer. We're gonna say no peer in peers map. Actually, peer not found, maybe. Peer not found in the peer map. Right. Then we have a peer here. Let us see if we can find the peer, if that's working fine. Let's say just peer. It's probably not gonna format, but it doesn't matter. Just for testing purposes, real quick. Right. RPC from. We don't have that, right? So I think we have a problem in this message, real quick. Yes. We're gonna delete this net address. So we're gonna make it just a plain string, and then we're gonna open up TCP here, and we're gonna say instead of a remote address, we're gonna make it a string. Which is fine. This mouse is in the way. Then we're gonna make run, just like that, and see what's going on. See if we get the peer. Okay, so we still have this interface nil conversion. What's going on here, real quick? Stop the user quit action. That's nice. Server 143. Actually, what's going on here? Yeah, it's this one. I know. So what we're gonna do? We have the peer is working. That's good news, right? So what we're gonna do is we're gonna say, we could say peer read, but we can't, right? And we're gonna fix everything. But first of all, I wanna show you something, right? I wanna make things work. So what you're gonna say, this is a TCP peer, right? So what we could do to access the read function of the connection, of the underlying connection, right? Actually, I think now we can't. Is that? We can read. That's amazing. That's amazing. So we're gonna say peer read. Let's make a simple buffer now. We're gonna say make a slice of bytes. Let's make 1000, and we're gonna read B, and we're gonna say underscore R is gonna be period, so we know that something is wrong. Maybe we're gonna do this. This needs some need some refactor, that's for sure. But just to make things clear, let's panic here on this error because normally it won't happen, I think. Right. The problem is right now that we are stuck at reading. Right. So we basically are stuck at reading here from the connection. I think let's panic here. And if the panic is not getting triggered, we know that we are stuck. I think we are stuck. Yes, we are stuck. Right. The problem is, guys, the big problem is that in this TCP, we have a read loop here, and it's the same read loop from this connection, right? This connection is the same connection sitting in this peer here, in this peer, right? So the problem that's gonna happen is that they're gonna read at the same time from this connection, which is not the problem why we are hanging. It's the problem that maybe after hanging we're going to have inconsistent results, because who is going to read first and so on. So we need to find a way to communicate between this go routine or this thread or whatever and this read loop, because if this message is going to be a message stream, a store message or something, then we know we need to add a wait group or something. And that's exactly what we're going to do. So I'm going to install a wait group, and I'm going to say it's going to be a sync wait group, like that. And we're going to say VG is going to be a sync wait group, just like this, right? And what we're going to do is, and of course we need to check the message, and we're going to do all that stuff. You will see. First of all, I want to test things if this is actually going to work, what I was thinking to do. So what we're going to do is we're going to decode this as all fine. Let's say we're going to we do peer VG. It's going to be VG add. And we're going to say add 1. Then we're going to say print FMT println waiting till stream is done, right? Then we're gonna copy this here. We're gonna wait. The wait group is gonna wait here, right? And then we're gonna say here stream done, continuing normal read loop. That's what's gonna happen. All right, so let's try it out. Okay, so we are waiting till the stream is done, right? So that's cool. That's good. That's a very important aspect. So the thing is, if we are waiting here, we cannot continue the read loop, right? We cannot continue this for loop, which basically means that this decoder decode will not get triggered, so it will not read or read stream and will interfere with the stream we are actually going to read here. If that makes sense. That's the thing, and I think it's pretty nice. Of course, we have some issues because this reading shenanigans is not going to work for some reason. Although we are sending this file to all peers though. Yeah, I think I know what's going on. Yeah. We need to sleep here, I guess, because it's gonna send so fast after each other that we are gonna decode this into one message. I think that could be the problem. Not quite sure. I'm gonna sleep for the to be sure actually. It's gonna be let's sleep 3 seconds or something. And the reason we are gonna fix this later on is again a fix we need to make is to fix our or a default decoder. That's not enough. Wait, so we received the storage key, which is nice. That's the first bunch of bytes we need to receive. Is this one? That's fine. Oh, what are we doing? No, it's fine. We're sending the storage key here. And then we are gonna send back a payload over these peers. Yeah, peer send payload, which is this large file. That should be fine. So why don't we receive it here? Wait, I'm a little bit confused now. So we make this byte, we read, and we cannot panic here. For some reason, it's not going to trigger. No. We need to wait 3 seconds before the stream will arrive. Yes, oh, we panicked. DDD, that's fine, that's fine. Yeah, I see. Of course, we are doing this. We are so bad, We don't need to print this here, right? We're gonna... Wait, man. We're gonna print here, right? That's the first thing we're gonna do. We're gonna print our first message, the storage key. Then we're gonna grab the peer. Then we're gonna read from it. And then we're gonna print again, but we're gonna receive big data. Wait, we're gonna just do nothing. We're gonna say, wait, this is gonna be this. It's gonna be a string of the buffer. I think that's fine. Let's see what's going on. Boom, then we have a large file. That's perfectly fine. This is what we see. So I hope you guys see what's going on. So the storage key is getting fetched from here, which will then be piped into VG group, which will then be piped into this RPC message, which will be consumed here. We decode the message here and we print it out here. Right? Here is where we print out the message, the storage pad. Then we're gonna fetch the peer from who did we receive it. We're gonna fetch that peer in our peer map. We're gonna make a byte and we're gonna read the next incoming, which basically should be the stream that's incoming, right? Because this is not gonna read because we block with this group, right? And the next thing we need to do here is basically after we received our big file, what we're gonna do here is just say peer vg and we're gonna call it DOM, right? Like this, and then we can make run a PWG undefined. Yes, of course. The reason why we cannot do that is because peer is basically transport here, right? Peer is an interface, and we only have net and send and netcom and send, right? So what we could do is we could give it actually another interface, and we're gonna do that. But another neat trick is to basically cast this to a TCP peer. But I wouldn't do that because then it basically abstracts completely the way it will not abstract the way why we made this peer dynamic and generic, right? So we're not going to do that. We're going to fix that later on. We're going to make run and to see if this works. So normally what we should see is a complete round trip of a complete streaming shenanigans, right? We're going to receive, you see, we received the large file here, and then it said stream done, continuing normal read loop, and everything is Gucci. Okay, but now we need to refactor this into something that's actually usable, because this is spaghetti wetty, right? This is arms are heavy and knees weak at the same time. So, first of all, it's good that we have this, right? Yeah. So what we're gonna do is, first of all, we're gonna have a message which is a payload any, right? Then we're gonna make. Actually, we should we should split these messages out, but let's do it here. For now, we're gonna say type. It's gonna be a message store file. The question rather is, yeah, why not? I'm taking because message store file, a pad key. If somebody receive I'm sending a pad key to you. That means that I want to retrieve it. No, it's gonna be store file. We're gonna say the key, and the key is gonna be a string. Maybe it's gonna be a pad key, to be honest, or a pad name. The pad. Actually, the key. Let's make it key. That's better. So we're gonna store a file based on a key. So what we're gonna do, if you want to store data, we're gonna make a payload, and that's gonna be not this one. It's gonna be the it's gonna be a message store file. Yes, and we're gonna say that the key is this small case. Actually, we're gonna say that the key is going to be the key we give it right there at store data. That's fine. That's fine. Then we're gonna encode the complete message. We're gonna send that to all the peers. That's fine. Right. Let's keep it like this. We're not gonna hassle with these things right now. So we're gonna comment these guys out. And the next thing we're gonna do, oh, my back hurts once again, man. The next thing we're gonna do is basically see if we can fetch this thing on the other side, which is basically here. What is this? A T reader. Yeah, that's because we're gonna. Yeah. See, that's for later on. Here. This is gonna be the message. I think this is not gonna work, right? This payload byte is gonna be nasty. What we're gonna do here is quickly. Actually, what we're gonna do is let's print it out in a dirty way, in a printf way. I'm gonna say percentage plus v new line, which then we're gonna say a message. Maybe let's only print the payload. Let's see what we get. Nothing. We're gonna decode the RPC. Yeah, that should be a message. What's going on here? Shit. What is going on? So we make a new bytes buffer, we encode that into the buffer, we range over all the peers, and then we're gonna send the buffer bytes to all the peers, yes. So why don't we receive anything? We don't have any error even. What's going on here? I'm confused real quick. Don't we get any messages anymore? What did I do? What is going on? Wait, no, nothing is happening. Oh, is main broken? You're gonna store data, which is basically this private key, my private data. Yes, yes, yes. But you don't consume anymore. Why is that? You're gonna add one, that's fine. What's going on? Am I still sleeping? No. That's possible. We don't consume anymore. Why is that? Are we actually calling this? What the hell's going on? We panic in DDD, that's fine. Because we call store data, right? So that's good. We're gonna encode this, we range this. Let's panic here maybe to see if it's being sent. Of course, I think so. There's no reason to. Wait. Did we made a mistake? We are blocking at peers. We are blocking before we send peers gonna block, I think. It's the hop encoder. It's the hop encoder. For some reason it blocks. Yeah. You can see that we are basically blocking here, but not here. It's probably to do with these messages, I think. I know what it is. I think we have a bug. I think it's I know what it is. It's look at this, guys. And we need to fix this thing. It's going to be a GOP register, actually. GOP register. It's going to be, which is the thing? Message store file. And that's the interface type you need to register, right? Is anything that we are placing in the anything that we are placing, any kind of type we are embedding in this any type. Let me open up message. Message. Here. You see this payload? All types we place in there needs to be registered with the GOP encoder, otherwise it cannot register an interface. That's the problem. I hope that's the problem. I'm not quite sure. That's why it fucks up. No, it's DDD. It's the same thing. Let's DD. I'm gonna delete this. Right. So now it's working, right? Let's make run. Yes. Payload is key my private data. That's perfectly fine. So we have the key. We know it's a storage. We know that the message type is a stream, a store file. So we now can open up the connection for streaming, open up a file, and pipe these two together and make that happen. And that's what we're going to do, and refactor that stuff. In the previous episode, basically, let me comment this out. We basically did some shenanigans where we could where we could actually send a message type store file. And if we receive it on the other side, on a node, we can, we know it's a store file, so we need to open up a connection, a streaming connection, right? And we get this large file right here. So now it's actually time to store that into a file, right? To store it into a file and to clean things up. Yes, so let's get started. So basically, we make this message here, of course. Let me quickly think. We're gonna encode this stuff, and then we're gonna send that to our peers. We're gonna sleep here. That we need to fix later on. All right, so let's go to here, right? Because here is where we're gonna read from the peer, right? Here is where we actually need to store that stuff. So why don't we clean this a little bit up, to be honest? So we have this handle message here. Wait, let me see. We decode the message. Yes. Okay, cool. What we could do here is basically, let's comment this out. So we're going to handle a message, which is going to be a type of a message, which is fine. We don't have a data message. We're going to say case, probably the message store file. Yeah, like this. Let's make another function. You're going to say file server handle message store file, which is going to be, what's going on? And that's going to be, I think, do we need a from? We probably need that, right? From is going to be a string, and then we're going to have the message. I think it's going to be, yeah, a store file message, I guess. Message store file. Maybe an error here, right? And let's, what we're going to do is return null here and see if we actually can make that work. We're going to say printf. We do a %v plus v, new line, and then we say the message here. We're going to say return as handle message store file. Need to warm up, not gonna lie, and we're gonna say v and from. We don't have that. I think we're gonna do here in handle message, we are going to get a from, which is gonna be a string. Pass that in here. So we're doing all that shenanigans. Let's comment this out. We're gonna decode it. So we're gonna decode this message, and then we're gonna say if r is gonna be s handle message rpc. We could actually handle the decoding there in handle message instead of this thingy, but it doesn't really matter. So we're going to say message. I think it's going to be the message payload, right? Yeah. If the error is not nil, we're going to maybe a println here. Like this. The error, and then maybe return or continue. Not quite sure what we're going to do. This is going to be the message then. What's going on in handle message? Wait, let me quickly see. It's going to take a message itself. Yeah, I see what's going on. We need the message here, and then we need a pointer, which is this, which is fine. All right, let's see if this is going to work. Let's see, make run. Wait, are we receiving this? Let me quickly check. Received store file -g like this, right? Should work. Delicious coffee. Yes, receive message file. Private data is the key. That's fine. Okay. Okay. We can clean things up, right? So we're gonna fetch the peer and all that stuff. Yeah. So that's what we need because we're gonna open up a connection, right? So what we're gonna say is the same thing. We're gonna say peer okay. It's gonna be as peers from, right? If we don't have okay, we're gonna say fmt error f peer and then %s in the peer map. We could say from some nice error. Then we have a peer here. That's fine. And let me open up a server on the other side so we can actually see much better what's going on. And I'm getting a little bit of a cold or something. I'm not quite sure what's going on. And that's my own fault because I'm basically walking outside without any jacket or something, you know. Just bare naked almost. I think this is good. It's here. So we have the peer. And then, yeah, okay, cool. So what we're going to do then is basically we know that's a file. So we could say as store write. We're going to write the key. We're going to write the key, and then we need a reader, which is basically the peer, right? We're going to read from this peer. And if the error is not nil from the storage, we're going to return the error from here. Actually, we could return, right? We could just return this. Are we going to return this, or are we going to do it like this? Maybe there need to be some logic here later on. Not quite sure. Well, let's just return it. Let's just return it, and we're going to see what's going on here. Okay. Taking a comfortable position. Yes. What's going on here? So we have this payload. That's my micro CD kicking in right again. Once again. So we're gonna handle the message, then we're gonna do la 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 and the speed and done and all that stuff. We're gonna basically do delete this. And then we are going. So what we're gonna do here is basically again assert this to a TCP peer. Do we have this with G? It's gonna be a peer-to-peer TCP peer. I'm gonna call done on this. We need to fix that. Let's delete this folder because we're gonna see if we're gonna store something. Let's see what's going on, right? Let's see what is actually going on. Okay. I think we have this folder, but we don't have any contents in it. Okay, and I also saw that we have two read streams, which is not what we want. Of course, we are legit trash, right? Look at this. Of course not gonna work. What we need to do is this. And if the error is not null, we are going to return the error here, and then we need to call done, and then we can say return null. Let's see. Wait till the stream is done. Okay, we are blocking, and I think I know why. But still, I think we should have some file. Yes, that's already been done. So we can already call store on a server. It will broadcast this, and then the other server will just store it, but we're blocking, and I know why. I will explain. I will explain exactly what's going on. So basically, what's this? Let's kill this. So what is going on is, let me open up store real quick here. So if you open up store, let's go to write stream. It's actually small caps, right? Write stream. Here. So write stream is basically going to copy, right? And we tested this and it's all working fine. We don't block here. But you see, I'm going to do a panic here. So you know, here, with some exclamation marks, you will see that we are blocking and that we don't hit that panic. Although in our test it's working perfectly fine, that's because we're using a bytes. We make a new reader out of a slice of bytes, which basically will return end of file if we had the last byte written, right? You see, stream is done and we don't panic out. So the problem is that if you read from a connection, right, a connection will always will not return end of file. So that's why basically our storage keeps waiting for new stuff to write in that reader. So what we need to do is a couple things we could do. We could say copy n and then say we only want to copy 10 bytes or n certain bytes, right? That's how we can fix it. But we also can fix it by using some kind of a limit reader. But where are we going to do this? Limit reader. Where are we? Where are we? Yes, so we basically sent this file. Of course, this needs to be a file. That's for later on. Let's first fix. Where are we doing that stuff, man? Here we store, right? So we need to have a way to find out how many bytes this is going to be. Because we could make this into an IO. It's going to be a limit reader. Limit a reader. Like this. And let's say we want to read, how many bytes is this thing? Let me open up, I don't know, let's say we want to read 10 bytes or something, right? And we're going to make run. Then normally it should, you see, now we panic, right? But the problem is we only, because the limit reader basically will say, yo, this is a reader, but only read the amount of bytes you specify. If you now open up this file, you will see that this large, right? We only have written 10 bytes. So it's actually an easy fix, right? So we need to find a way to get to get the size of that thing. We need to let the other side know what's coming in. So what we could do is basically open up our message. This one, message store file. We could say actually the size. It could be an int, right? So that's what we're gonna do. And in this case, large file is basically this large file is 15, right? And you will see we're gonna specify the correct size, not hard coded in a bit of time. So we're gonna send that over. So basically that means that if we handle this message, handle message store file, this is here. Right. So we can say a limit reader, and we're gonna say it's gonna be What's going on here? It's going to be peer and MSG size. What's going on here? Yes, like this. What's going on here? An N64. Okay. It's all fine. We're gonna change this. Hey, all good, my man. And let's make run real quick and see what's going on. What's going on? Everybody's sending me messages, man. It's legit crazy. Boom, everything is working like intended. We get this panic, and let us see. Boom, this large file. So now we have a way to actually completely unblock here. And we are fine, right? So we're gonna close this. It's fine. Okay. Okay, but now we are sending this large file, which is basically not what we want to send, right? What is this reader? That's going to be the reader we give it, so that's fine. So let's delete %, and let's do something like IO copy, which is going to be a streaming copy, right? We're going to say IO copy, and we're going to copy to the peer, and the reader is going to be the reader we give it. Or we could say bytes. Let's just try it with this. Bytes new reader payload. And we're going to say, maybe we're going to say nr this, and then say if the error is not nil, we can return. No, we cannot return. Can we? Yes, we can. I'm going to return the error here, and then we could say here fmt println received and written %d. We can't to disk. And we need to do it like this, and just for logging purposes. And let's see if that's gonna work. Yes, 15 bytes to disk. All good. All good, but now we're basically doing still this. Are we doing this large file? Yeah, we're doing this large file, right? Let me quickly see if it's working. Double check. Yes. All fine. So what we're gonna do now is actually take this reader, right? That's what we're gonna do. The reader, we actually give it and store data in our main, right? You see? In our main, we are calling here bytes new reader, my big data file here, and then we're gonna store this at my private data key, and it's gonna be the data we give it, right? So instead of making this payload here, we're gonna say we don't need to make a bytes new reader because it's already a reader. Let's test that out. Make run. Okay. Unexpected end of file. How is this possible? We're gonna copy from R, which is this thing here, right? I see what's going on. Or not. No, I don't see what's going on. I thought it was something to do with this, with the file size. Maybe it is. Is it? We can't, right? I think it is, by the way. storing at the same key. Yeah, I think the problem is that we don't know. That's gonna be 15. 22. Just count the bytes manually. Is that the problem? Yeah, that's the problem. Now it's working fine, right? All right, so we need to find a way to get actually the size of the file. So if we want to make this reader, right, the first thing we need to do is actually store it, right? We're going to say r, it's going to be as store. And we could say, no, not store, as store write the key. It's going to be the all right, and then you're going to say here r not null. You could return an error here, right? Just like that. But the thing is that we need to do, or let me open up server real quick. T, do we have a T? T. Why can I not type? What's going on? T. Here. Man, what is it doing? T reader. Yeah. So we need this T reader. That's what we need. We're gonna copy this. Hop, hop. Do it here. Let's delete this. We can do this. Right, we make a buffer, we make a T reader. We're gonna store the file. This buffer, can we reuse that buffer? No, I don't think so. Let's make it a message buff then. Let's make it a message buff. What can we do with this T? We can't. T can only read, right? T can only read. So we have, we store it to our own disk. Then we're gonna send that to the network to broadcast this. Oh, it's actually in here. All right. Let's delete this function. Okay. So what I want to do actually in store is find a way to return. If you do write stream, what I'm going to do is actually return this. And it's I'm going to return an int. So we don't store nothing. We written nothing. 0 and null. Actually, no, that's not true. It's going to be n. That's an we're going to do it an N64. For some reason, it's an N64, like that. And of course, our test will be broken. It's going to be right. We're going to do the same thing. It's going to be an N64, which is the file size. Yeah. So now we could say this. We could say it's going to be T. We could say N. Or actually size, maybe. Yeah. If add is not null. And then we pipe the size. Well, pipe. We're going to assign the size to the size. It's good. Very nice. And then I think we're good. Let's open up this thingy. Let's delete this. What's going on? Whew, Windows, man. All right, so all folders are gone. Let's make run. Let's see what's going on. Store right. That's basically in server 160. Yeah, I see. It's here, right? Let's do this because we don't need this. Make a run. Yeah, I think we fucked up our T reader. Not quite sure. This is T. Buff bytes. It's this buff. Yeah, of course. I think we made a mistake here. This needs to be the message buff, I guess. Is that true? Received and written 0 bytes to disk. Ew. Of course, we got these two files, right? And we got nothing here, right? But we got big data file here. So it's... Who is sending this? Yeah, it's two, right? So we store the data. So we store it at our own disk is fine, right? We store it at our own disk. But broadcasting is in problem. Or not? What's going on? Yeah. So broadcasting is a problem. Wait. Oh yeah, we do R. That's not true. Of course we made a mistake. This needs to be the buffer. Wait, but we need to be careful, right? Because these file namings are basically cock blocking us. Yay! Oh, we did it. I think it's gonna work. So we have 3000 here, file there. Yes, we distributed our storage, man. Amazing. All right, but hey, we are still not there because it's garbage, right? It's garbage code. Let me quickly do my the serious position, the position where we yeah. If I'm in this position, it means things are gotta get serious, right? All right, so we do these things. I have this mic OCD, man. It's crazy. What's going on? Why do I have that? Okay, so I want to change some names because this is the buffer. This is the message buffer. Message buffer. That's fine. How are we gonna name this? Let's make it a file buffer, right? Let's make it a file buffer. And then we're going to say here, that makes more sense. File buffer. That makes more sense. That is fine. Hop, hop, hop. Cool, cool, cool. I think the store data is kind of good. Maybe we should do this to make it even more cleaner. Right, that's fine. I like it. MSG is this one. I like it. Then we decode the message here. It's fine. It's fine. Okay, cool. That seems good. That seems clean. Where is this one? And then this message thingy, handle message. What we do here is basically this one I don't like. We need to fix that. We store it here. What I'm going to do in store is actually delete this thing. So we can actually do it here. And we're going to say n. Like this. And then we could say here lmt written bytes to disk. New line, of course. What's going on here? What's going on here? And then we're gonna say it's gonna be n. And then we're gonna call peer done. But still, we need to fix some stuff because there are a lot of things not okay. Because right now we do this here in TCP transport, right? You could see we are hard coding this stuff. Because it could be that we are just sending a one-off message, then we don't need to log the stream. So we need to have functionality for that. That's what we need to do. What also we need to do is try to retrieve files. If we can store a file, if we can retrieve a file, that's fine. We need to do the encryption, clean stuff up, make some tests, and I think then we're almost done with this. Of course, you can expand upon this much further and further, but I think if we all have these things in place, we have a very nice project that we made, which you guys could use to get a, I don't know, a higher paid job or something. This basically, if you show this, guys, be honest, they don't know what's going to happen. In the previous episode, correct me if I'm wrong, we could actually distribute our files. So if we store a file on a certain key, we can actually distribute that between all the connected nodes, which is perfectly fine, which is actually the intention, right? So basically, it means that if our computer blows up, our file is safely stored somewhere else, which we should able to retrieve if we don't have it, right? So that's what we're going to do now. Yes, that's what we're going to do now. So let's open up this thing. First of all, I think we need to do is basically in store data, right? What we do here is this bunch of thing, right? This whole shebang. What this does is it basically encodes the message and then it's going to send to all the peers. And I think we should have a broadcast message. Do we have that? Yes, broadcast here. I think we're going to rename this to stream and actually make a new one. We're going to say file server broadcast. And we're going to broadcast a message. It's going to be a pointer to a message, which will return an error like this, right? Let's delete, let's clear the highlights, and then we can actually copy this thing. So let's copy the buffer, boom, place this in broadcast, and instead of, we could say just buff here, like this, just say buffer, and then we're going to say buff bytes, and return null here, I guess. So this is going to basically encode it and broadcast this to all the peers. And now we can here say if the error is going to be as broadcast pointer to the message. If the error is not null, we're just gonna we can return R, which is fine. Then we're gonna sleep, and we're gonna fix the sleep very soon. Then we're gonna copy the whole shebang, and I think we should do a multi-writer here soon. I'm gonna say to do, and let me do a high comment. GFG is gonna be green, like this, fine. To do at NDM, use a multi-writer here, like this. A multi-writer, yes. So that's fine for now. Is this gonna work? Let me quickly test, make run to see if this all working perfectly like intended. Yes. Right, we have written 2 times, which is basically one on 4000 and one on the 3000 server. Good. So the next thing we're gonna do is store data. Actually, what I'm gonna do, I'm gonna rename this to store. Actually, it's not gonna work, so we're gonna say store. Perfectly fine. Everything is okay. We're gonna call this store, and then we're gonna say func as file server. And we're going to call this get, which is going to be a key string. And that will return, I think it's going to return an IO reader, right? And an error. Like this, right? So if we want to do a get, it's basically the first thing we're going to do if we're going to say if as store has, if we have the key, then we can retrieve it locally, right? Then we can say return as store read key, right? But if we don't have the key, right, then we can actually say I'm gonna return null here. Actually, let's just panic, right? Don't have, actually. Yeah, you could do. Don't have file locally, right? That's what we're gonna say here. Which then, because I think we already have these files, so we can comment this out. And then we're gonna say or error is gonna be s2 get, and let me get some foo, which we don't have. And if the error is not null, we're gonna log fatal the errors, right? And otherwise we could say that the bytes R is gonna be IO until read all the reader here. If let's copy this real quick like this, and then we can say fmt print ln the string of the bytes, right? Let's make run real quick. It's gonna panic out, right? Because we don't have this foo thingy, right? Don't have file locally, which is fine. But if we say that the key is gonna be my private data, right? And we do make run, then it's going to, what's going on? It's read all. What am I doing? Private data, like this. That normally we should get a file. Big data file here, right? That's actually you can see big data file here. That's what we stored in these files, right? So that's good. It's working like intended, right? So if we don't have the file locally, we're gonna actually search for this file in the network, right? So we're gonna say type message type get, no message type, message get file. It's gonna be a structure, right? And we're gonna say, I think we only need a key for now. Right? And then we could say something like the message is going to be a message. The payload is gonna be a message get file. And we're gonna say that the key is gonna be the key we want, like this. And then we could do if R is going to be as broadcast. I'm going to broadcast this message. And if the error is not null, we're going to return the error like this. And instead of saying panic, we could do a print f don't have file locally. Okay, all right. Don't have file locally. We could say fetching from network. Like this. And then we're going to broadcast that stuff, and that should be handled on the other side of the network, hey? So we're going to handle a message here. So we're going to say case message get file. We're going to say return as handle message get file from v. We don't have that, so we're going to say func as file server handle message get file. What's going on? Like this. And that's going to be from string, and of course a message get file. Is it a pointer? We don't need a pointer because we didn't do it on the other side. We're going to return an error. Yes. Let's return null and say fmt println okay, we need to get a file from disk and send it over the wire. Let's see if this is gonna work. Actually, what we need to do is block real quick on get, otherwise it's not gonna work. We're gonna broadcast this and I'm gonna say select real quick to test it out. What's going on? Clear, make, run. Yeah. Of course, we just copied some stuff. Actually, handle. Did we? 79. Nee, that's not gonna work. And then 89. Yeah, of course, we turn. Yeah. Yes. Of course. Cannot use message as message and broadcast. Okay. Fair enough, my friend. You're right, and if you're right, you're right. So we're gonna do this shenanigans. My big data file here. Yeah, okay, cool. That's because we actually we have this key, right? So we're gonna see a new key we don't have. That's something we don't have in our storage, right? So normally it should now send message. Okay, so we can see don't have file blah 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 locally fetching from the network. That's fine, but we also need to make sure we can send our new message over the network. Is this thing we're gonna what's going on? Actually, what did I do? Copy this, paste it in, and then we're going to say message store file. We're also going to say message get file, right? So remember, for the GOP encoding, we need to, everything that's basically could be an interface in an any type, anything that could be in there, we should register that to the GOP encoder. So that's what we do. And then we could make run to see, cannot use blah, blah, blah. Again, I think we made a mistake. It's because, like this, right? My bad, my apologizes. So normally, right now, we should have, yes, so need to get a file from disk and send it over the wire, right? That's a thing. Wait until the stream is done. Why is that? It's because we lock it. Yes. We need to fix that because it's a dirty thing. So we sent that over the wire, that's fine. Completely Gucci. Here. So what we're gonna do here is, first of all, we need to make sure that we what we're gonna do here? Maybe we could do if s has, because it could be that our remote doesn't has it, right? They're gonna ask for all the peers, hey yo, give me a file, but if he doesn't has it, he doesn't have it. And I think we should respond with something. I'm not sure what we're gonna do here. I think you're gonna say if has MSG key. If we don't have it, I don't think we're just gonna print something out. You're gonna say println of printf rather. Cannot fetch. Cannot read file from disk. Actually, file does not. On disk, alright, that's that. And if we have the file, we need to basically fetch the file. We need to fetch the file. It's gonna say that the it's gonna be a reader and an error, right? And that's gonna be s store read. We're gonna read MSG key, right? And if there is an error, of course, then we're gonna return an error. And then we have a reader here, right? So we have a reader here. That's what we're gonna send over the wire. So we need to open up a stream actually with the connection, and that's basically the peer. Okay, is gonna be as peers from, right? And if not okay, which basically means the peer does not exist, so we could return an fmt error f peer not in map, whatever, like this. Then we have a peer. So what we could do then is basically copying files from this guy to the peer. We could do that with n r is going to be IO copy, very important thingy, and the destination is going to be the peer, and what we are going to copy is basically the reader we just fetched from our disk. And that's why we're using readers, right? You could say, yeah, but why are you using readers in our storage, and people always use bytes. Stop using bytes, right? Stop using bytes. You should use readers, because it's compatible with the whole universe. You know what I mean? Reader is so compatible. You see why we're using readers, because we need them. It's plug and play. It's plug and play, boys and girls, and everything else. Then we're going to say if there is an error, of course, we're going to return an error. All right. And then we could actually log this out. Or you could say print f row. Is row the thing? And then we're going to say written n bytes over the network to from. And I made a mistake. That's fine. Now let me quickly see. I don't think it's going to work, but hey, let's test it out. Listening to the transport. Of course, we're not going to have that file, right? So we're going to say it does not exist on disk. No such file directory open. That's cool. That's cool. Why is this? We are opening stuff. Oh yeah, of course. What are we doing? fmt printf. We could return an error. We need to return this as an error, actually. we don't need a new line here. Is this. So right. So this is going to be much more cleaner. So like this. Right, so it's telling me need to serve server file, but it does not exist on the disk. Right, that's cool. Just this little typo here, like this. And then we're going to say file server stop due to server action quit. Not quite sure why that is. Is it probably for handle get file here? Is here. We're going to handle a get message. Oh yeah, we return here. Yeah, I see. Can we continue here? I'm not gonna do anything actually, because these errors causing need to serve file, but I think that's better. Yeah, and this error is basically not that good. File server stopped due to error. Or user quit action, something like that. It makes more sense. Each time we return here, this function is going to get T first, right? And copy and code, I think we're going to do the same thing here, to be honest. I don't want to quit. We just want to print out the error, right? And we could actually say decoding error. Like this, copy this, paste it in here, and we're gonna say here handle message error. Much more cleaner, right? Alright. Whew. Intense, I'm gonna lie. It's intense, boys. But it's nice, it's cool. I like it, I love it, and I hope you love it too. I just want to make sure you guys are absolute animals on the keyboard. With Go. And it doesn't even matter if it's with Go. This is basically programming. This is about programming, right? This is Go, okay, but you can do it in every single language out there. It's just knowing how to do things. It's just knowing how connections work, it is what it is. If you can literally give me any language and I will make the same thing. Literally. Just Rust, I don't care. Rust, Python, even a JavaScript. Call me a language and I will make it happen. Although Golang is my best language because I know a lot of things in the top of my head, and in Rust I don't, but I doesn't care because all the things I don't know, I know where to find them. You know what I mean? It's all the mindset, it's all knowing how to do things, and if you know how to make these decentralized distributed storages, you literally can make so much because you know these concepts. That's the most important thing to know. And even though these concepts, maybe you don't want to build a decentralized content addressable storage, knowing this stuff can help you build other things you want to build, right? It's just knowing these principles, these mechanics. All right, so okay, cool. What we're gonna do is we are at 4,000, right? So what we could do is we are 4,000. Which we're gonna delete the whole folder of 3,000, 4,000. Yeah, what's going on here? Still, is this a filter? It's real weird. What's going on? Anyway, it doesn't matter. So we don't have our folder. So we're gonna get the my private data stuff, which then basically will this we will have this, right? So we're gonna actually we can make a log line. We could say fmt print f real quick here, and we're gonna say got file %s serving over the network. Actually, serving file over the network, new line. MSG key. Like that. Make run real quick. Yes, so we're serving file my private data over the network, and then it says written 22 bytes over the network to that guy. Wait until the stream is done, and then we have a decoding error, yada yada yada. So we copy this, right? That's good. That this copy is working is perfectly fine because that's a reader. We're serving that over the network, and of course we get this decoding error because right now the file is being decoded in the TCP loop. In the transport, in the TCP transport, the file is being decoded here, right? Here, this thing, we got it here, right? But that's not because we don't basically. I'm happy with the result already, but the problem is that we use a multi-writer, yada yada. Here. Right, so we do a broadcast, but then here we need to actually open up a stream. Looking for my words. So how are we gonna do this to open up a stream? Is basically we need to broadcast this to read from every peer. That's what we need to do, and we need to find a better way soon. But hey. Gonna be range as peers. And we need to do a copy. We're gonna say nr is gonna be IO copy. And we need to make a file buffer. Actually, we need to make a file buffer for everyone because we actually don't know if you have a file. Maybe we should first ask. There are a lot of mechanics we could do to make this better, guys. We could first, instead of assuming they're going to serve it, we could first ask if they have it. And if they have it, then we open up. So we could say, hey, do you have this file? He responds, yes, I have it. Okay, I open up a stream. Or you could say, what we're going to do right now is basically, yo, do you have this file? I'm waiting for you. Actually, not good. So we need to fix it. We need to fix it. But hey, we built this up. Don't be too greedy in your over-engineering because that will basically kill your dopamine levels. So we're going to loop through this piece. We're going to make a file buffer, which is actually not true. We're going to make a file buffer, which is going to be a new bytes buffer. And then we're going to say who is the destination. The file buffer is the destination. And the peer is going to be the reader. And we're going to say if there is an error, of course, we are going to return that error. Actually, we should not do this because, but yeah, we're going to fix this later on. Because if we return here an error, this get is going to basically return. And it could be that just is an invalid peer, right? It could be that the first peer is going to return an error while the next peer is going to serve it or the file perfectly fine. So we cannot do this. But for now, it will be fine. And then we could say that we are receiving fmt println received I think something is wrong with my let me quickly check. Is it Windows, Intel once again? No, it's US. Hey. So I've basically, I don't know why I have two keyboards. One is US, one is international, and I don't need the international. I don't know why Windows keep doing that. Should probably delete it. But hey, deleting in Windows is a pain in the ass. Not quite sure why that is. Can we actually print out this buffer? Actually, we could do buff string, right? Is this gonna work? I assume not. Buff. Of course not. How many buffs do we have? Where is buff? Okay, let's 109. Let's open up this line real quick. Did we not save this? What the hell's going on? Just not saved it. My bad. All right, so we're gonna do those shenanigans. Ooh la 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 la. What's going on? So we're waiting till the stream is done. I think that may be a problem. Wait till the stream is done. These VGs in our peer. We need to fix that soon. So don't have file locally, fetching it from the network. Then we wait till the stream is done. Not quite sure who that is. Serving file, my private data over the network. That's the remote. We're then going to write 22 bytes over the network, which is fine. But for some reason, I think this I'm thinking for a good thing. Receiving stream from peer. And we could do this and then say peer remote header or something like that. I think it's blocking there because we already read it from our other loop, which is not closed. Wait until... Right. Receiving stream from a peer. I think it's the same issue once again, where we need to make sure that we time sleep here, because we need to fix that, guys. I'm gonna lie. We need to fix this stuff, because otherwise we're gonna read the whole shebang into the buffer, into this decode function. You see, so we have this 10,028. So basically, because we're broadcasting here and then we instantly trying to receive, is it? Not quite sure. I think I'm wrong. I think I'm wrong, to be honest. I think I'm wrong. Sometimes I can be wrong. It's a decoding error, which comes from an unexpected kind of file. I see. We need to be careful because it's this copy thing. The copy thing is a problem. Yes. Wait. Two problems. Two problems arise. It's a copy thing is first because it's a connection which will not stop. Don't the file probably fetching from the network, that's fine. Receiving from the peer. Wait until the stream is done. It's still not done. He's sending 22 bytes, right? So the problem is basically that we, in our TCP transport, that we read here first, once again. So it's going to be some juggling around with these wait groups, and I think it's going to be a very good a very good start to do this, because we cannot leave it like this. We can't. We just can't. It's bad. Like I said, it works. It worked till it was good till now, right? Some things you implement things to make things work, but for at a certain point of time, things cannot work anymore. You know what I mean? And then you fix them, and that's how you come to a complete solution. So the good thing is that we have a way that we actually can request files from the network. We are copying them, but we have a problem receiving them. So we need to do some couple fixes, and I think it's going to be an excellent episode to do these fixes in the next one. So let's continue with our forever store, and let me quickly do a make run to see where we stopped. So I think we started with retrieving a file, but the problem is if we don't have the file, then we need to fetch it from all our other peers, of at least from one peer, right? The problem is we're gonna run into issues, and the reason is if you go to this transport, right? This transport, we have this peer VG add and VG wait. It basically means that we hardcoded this, right? Because why do we need to wait is because we're going to receive a message, like a plain message, which we GOP encode, right? And decode on the other side. But the problem is that we need to find a way to close that. We're doing that in our server somewhere. But the problem is the way we are doing it right now is causing issues, right? So everything was fine until it lasted, right? Until today. So we need to do some crazy shenanigans to fix that, right? To support it in our lib. So what we're gonna do is we're gonna support streaming in our library. Super important, right? But the first thing I'm gonna do is I'm gonna open up main real quick, and instead of doing this get thingy, which did not work yet, right? We're gonna test it with data. With our store, with this function basically works perfectly fine, right? If we delete these two bad guys here, if we delete these permanently, right? And we then do a make run here, and normally it should basically work like this, and everything is fine, right? So we have this network here, 3000 with the file, big data, all good, and then we have 4000 with the file, big data, all good, right? So the best thing is that we test. There's a very common practice is that you always, if you want to do a refactor, you test this with things that are already working instead of things that are broken, right? Okay, so how are we going to do this? Very, very important episode. I'm not going to lie. This is, how do you say that? The cream on the pie or something. I don't know. Yes, the first thing we're going to do is we are going to open up encoding here, right? Because what we do right now is we read this 1028 stuff, and I already mentioned this in the previous episode, that's causing issues. So what we're gonna do is, I was thinking about this, and I'm not gonna lie, I was thinking about this for a long time, but I figured something neat. I figured something out, which I'm gonna teach you. What we're gonna do, actually, I think it's implemented in a lot of other stuff also. What we're gonna do is we are going to make a peak buff, right? A peak buff, and that's going to be make me a slice of bytes. And we're gonna make 1 byte. So we're gonna peak the first byte, right? And we're gonna say, first of all, we're gonna do something like if R is going to be nothing, because that is the bytes written, right? This is R because we're gonna read from the reader, right? I'm going to say R read me into the peak buff, and if the error is not null, then we are gonna, what's going on here? Please, VS Code, yes. Then we're gonna return the error like usual. What did I do here? If R, what's going on? All right, so if R, we're gonna read the shenanigans here. And then we're going to say that, first of all, what I'm going to do is going to open up message, right? And we're going to add some support for streaming in our RPC. We're going to say stream, which is a Boolean. right? Because then we're going to know that we are streaming. And if you're streaming, we know exactly what we need to do. We need to lock our stuff. And then we need to have a way to unlock it when the streaming is done, so we don't receive other messages in that read loop, right? That's important, and I'm gonna show it once again, right? This is the read loop. This thing is our read loop, which will basically, each time there is a connection, this read loop will run in another Go routine, reading from that peer, reading from that connection. But if we need to, so each time there's a message being sent over the connection, we're gonna read it here, decode it into an RPC, pipe that into our channel, and we can read it in our server. But if we are streaming, we need to lock this read loop, because otherwise we're going to have problems, right? So we cannot open up two streams of reading, two read loops. It's impossible. So we're going to lock the main read loop. We're going to say, hey, lock this because I'm receiving a stream, so we can fetch the stream directly in our server. That's what we're going to do. I think it's a very, very, very nice option we're going to add to our lib, right? So message here, we're going to have an option, a support for streaming in our lib. So we're going to say here that stream is going to be the peak buff, the first byte, right? Because it's only one, right? And that's going to be equal to, for example, we're going to say 0x2, right? And actually what we could do is maybe we could do in we're gonna do this in message. We could say, for example, how we gonna call this variable? That's a good thing. If the peak buff is streaming type, I don't know, man, maybe stream type or something. It's going to be 0x2. Actually, what is it, the type? You could say const. Const stream type is going to be 0x2, and then message type is going to be 0x1 or something, right? And actually, why do that? I can do this, delete this, and this. Something like that, right? So we go to peer-to-peer stream type. What's going on here? Shenanigans. We are in peer-to-peer. Yeah, it's my bad. So if it's gonna be if the peak buffer is a stream type, actually, sorry guys, I'm gonna incoming message, and I'm gonna say incoming stream. So if the peak buffer is an incoming stream, yes, right? Now we're gonna say if stream, right? So if it's a stream, then we're gonna say that the message, which is our, why do we call this actually a message? Anyway, it doesn't matter. We're gonna say the message stream, right, is going to be true, right? Otherwise, it's going to be false, and we're gonna return here, right? We're gonna return. There is no need to decode, right? There is no need to call this, right? You could say in this case, in case of a stream, we are not decoding what is being sent over the network. Why am I actually searching for W? Like this is better. We are just setting stream true. So we can handle that in our logic or something. I don't know. It is what it is. All right. So we're going to say stream true, and it's fine. Then we need to go to TCP transport, right? So for TCP transport, what we're going to say is We're gonna decode this, right? And then we're gonna say, first thing we're gonna do is if RPC stream, right? Then we're gonna, actually we can do this, this RPC from can be on top, that's all good. The VG add, if it's a stream, we're gonna add the VG, and we're also gonna wait for the VG, for the wait group, right? That makes sense. So if it's a stream, we're gonna wait. So we're gonna say fmt print f, and we could say this. We could say the address of the thing. How are we gonna call this? Incoming stream, waiting, I don't know, something like that. And then we're gonna say here, actually a new line maybe. And then we're gonna say here, it's gonna be, do we have the com remote adder so we know who is saying that? And then we're gonna say here, resuming, stream closed, resuming, read loop. Like that, that's cool. And then we're gonna say continue, right? Because there's no way, because we are streaming, which basically means we fetched everything we need to have on the other side, on our server or something, or somewhere else. So there's no need to pipe an RPC into it, but basically hold no bytes, right? So we're gonna say VG add, we're gonna say VG wait, right? That's the first thing we're gonna do. All right, so you can already imagine if we run this right now that we're gonna have big troubles, right? We're gonna have inconsistent data, because we are basically sending we are peeking the first byte, and then the rest is basically completely broken, right? So what we're gonna do is in our server, right? In our server, and I think it's broadcast we need to have. Broadcast. It's actually, I need to search for broadcast here. Yeah, like this. So here, what we're doing here is basically we are sending just a normal message, right? Broadcast is just sending a plain message. It's sending, give me a file, store a file with the file name and all that stuff and a file size. But it's not doing any streaming shenanigans, right? It's not sending us that bytes over the network, those large file bytes. So what we're gonna say here is, instead of we're gonna say peer, we're gonna send. We are going to send the streaming, incoming streaming type, right? This byte. We're gonna say peer send. We're gonna send a slice of bytes, and it's gonna be a peer-to-peer incoming message, right? I'm gonna say incoming message bytes. I don't know. Not quite happy with the naming yet, right? So we're gonna send an incoming message. So we know that if we are here, right? If we are in encoding here, right? So we peek. So we know that this is the first byte. This is the first byte we are sending. It's gonna be the peak buff, which is gonna determine if it's an incoming stream or just a normal message, right? The next thing we need to do is find out where we are sending that stream over. This is get, receiving stream from P. This is a receiver, that doesn't matter. Handle message, get file, store file. You see, here are we closing, right? Here are we closing the wait group, is because the stream is done, right? So what we need to do is, where are we sending this? So right, so we need to, somewhere we need to copy. Here. Right, so what we do here is we broadcast a message. We're gonna receive that somebody is willing to store a file. So we have the file name and the file size. We then prepare on the other side. We open a file on disk, which is basically our storage, right? Write stream. And then after 3 seconds, this guy is going to send the stream. So the first thing he needs to do is basically say peer send, right? Each peer we need to send a byte, and that byte is going to be, you already guessed it, it's a peer-to-peer incoming stream. Just like that, right? And normally, and I said only normally, this should actually work perfectly fine. Not quite sure. Let's see what's going on. Yes. Yes, I think it just worked perfectly fine. Incoming stream, we wait in, then we receive the stream, we are written 22 bytes to disk, and then we close the stream and we resume the read loop, right? So to make this even more testable, actually happy because it was, it's advanced, guys. This is advanced. I say, if you know these stuff, it's insane. Let's open up main because I wanna basically, let's open up main here. So I'm definitely not coding in this window. I'm gonna make this like a 4 because I want to make it a little bit more performant, and I don't think that the sleep of 3 seconds is needed. Let's do 10 times. Let's copy the whole shebang inside of here. Let's paste it in here. Yeah. So what we're gonna do here is we're gonna send it, and then we're gonna do a time sleep, because if we don't sleep, you cannot. There is no use case it's gonna send so fast. This is going to send as fast as the CPU can, which no other node will ever do. It's impossible. There is some kind of a round trip in HTTP, so we need to sleep. Otherwise, it will fuck us up. It's gonna be time sleep, and we're gonna say, for example, I think maybe 5 time. I think millisecond is even enough. Right? 5 milliseconds is fine. And then here we wait 5 milliseconds to send. I don't think it doesn't matter. Wait, it's the same thing. What the hell is going on? Where do we sleep? Oh yeah, it's in server. Yeah. I see. Here, this 3 seconds. We don't need this, but I think we need to sleep a little bit. And this is all normal behavior, I think, because milliseconds. I don't know, 5 or something. No clue. We can test that out and make it even better. Like I said, we're just gonna make it work. We're already downgrading from 3 seconds, right? Make run. So let's see. Hopefully we don't have any encoder decoder problems and also not quite sure what's going on here. I think just one more thing I want to do real quick is actually in server. Something we forgot is basically open up or quit channel. No. It's in our TCP transport, by the way. TCP transport. Like now, we don't have a buffer channel. We have an unbuffered channel, which is not good. We're going to say 1024 is going to be good. And let me quickly see what's going on. Normally everything should be fine, I guess. But we're never sure. Yeah, that's ourselves. Is this actually doing what it needs to do? I don't think so, to be honest. It isn't. What's going on? So we sleep 5 times milliseconds. I'm gonna make it a little bit bigger here and in server also. Yeah. I don't know, maybe 500, which is actually. Let me see, right? Let me see. We're gonna build things up, right? We're gonna make things better for sure, All right, this is this weight group, negative weight counter. Yes, I see. The question is, why is this happening? Did we miss something? This is our main. This is fine. So received and written bytes to disk, that's all fine. I don't know, maybe let's make it 1000. Let's see what's going on here. Something is still not quite right. Right, so we sent this. You say it's going to be a stream. Yeah, that's fine. Then we do. I think that's fine. Do we need to sleep here seconds? I don't think. Is that a thing? I don't think so. So incoming stream waiting. See, so there is something it's not closing. Let me quickly do one real quick to see what's going on here. Because with one it's actually working, or did we make a mistake in between? That could be. This is fine. So we add, we wait, and then we continue. Let's go back here. That's fine. Did we miss something in encoding? The stream, we say it's a stream, and we return, right? So it's gonna be, we peaked it here. Yeah. Did we? I'm thinking, what's going on here, real quick? Oh, maybe we are actually. Yeah, this is get, right? We don't care about get. We don't care about get. Where is store? Wait, the broadcast is fine, right? So our broadcast. We don't care about the stream message. Broadcast is here, right? Make a new bytes buffer. And then we first of all send this to our. It's going to be an incoming message. Yeah. So we can read that. And then we send the buff bytes. It's fine. I don't know what's going on. We sent the incoming stream. This is get file. We don't care about that. It's a store file here. So we check the peer. And at the end, we unlock that. Wait, first of all, let us do this real quick. Let's make some nice stuff. And you're going to say written %d bytes to disk, which is fine. And it's going to be... there's no way to check actually what address we have. Let's open up transport, TCP transport real quick. Let's open up transport itself. What I want to do in this transport is basically expose an adder thingy, which will return a string. Or it could actually even... No, I want to say adder, which is going to return a string. And then in TCP transport, we're going to say func TCP transport. Yeah, adder. And adder is going to return... What's going on here? It's going to return a string. And we are just going to return the listen. Do we have a listen adder? What's going on here? Oh, it's because maybe I fucked it up here. It's going to be a T listen adder. Yeah. Okay, cool. That's fine. We could say that adder implements the transport interface, returning the address. The transport is accepting connections. Right. Cool. And then we can do actually here, we could say s transport other, and that's fine. All right. If you make run, it should be all fine. Received and written bytes to disk 22. and then we say we written 22 bytes to disk, and then we close the stream, closed, resuming, read, loop. That's what we want to see. The problem is in main that we still, if we do this, for example, for 4 times or even 10, it shouldn't matter. That should also work. And I don't know quite an idea what's going on. You see, it's an incoming stream waiting, but I think we are blocking here. And I don't know, not quite sure why that is. Right, I think we're blocking here, so we cannot release here. Are we sending it too fast? I don't think it can, right? That's impossible, right? I think we made a mistake, to be honest, but where is it, right? Where is it? Let's do it 5 seconds. That's actually enough, right? It's so much time for everything to figure out what needs to do. Right, we close the stream. Incoming stream. Received and wait. You see, that's a problem because we don't. Something is wrong. We made a mistake. Where? I think I know what it is, guys. I think I know what it is. I don't know. Is this it? Is this what happened? Nah. Five seconds is too long. Yeah, you see what's going on? Ha! It's this, right? So, yeah, man, this is, you see, this nasty. Even this can happen. You see, you will encounter these stuff, and that's why I'm doing these stuff real life, without pre-record with a screen next to me, so I can see the solution, so it all looks fluently, and you think you learned something, which actually will be, but you can see that. Seeing myself making these mistakes will you make more aware, and even myself, right? So making this mistake, the next time I'm gonna do something like that, I'm gonna pay attention to these things, right? It's a stupid mistake, but it's so important, and I cannot emphasize this enough. It's so important for you guys to understand something is not quite right, what is going on, but you see that I'm looking at certain places where this can happen. And at a certain point of time, you can see that I figured out that it should be something with this, because Deep Mama said, okay, we set the stream to true, but we continuing. I was thinking at this continue, but this will be true, so it will keep thinking it's a stream, which is not, and then, you know what I mean? And I hope it's this, right? Because you're not 100% sure. We're not 100% sure. I think it is, because so this time second, guys, this is actually this is way too much, right? Such an application we cannot write. So, but we need to sleep. We need to sleep here for just a little bit of time, because you cannot. Nobody can process this at the speed of CPU, right? That is not real life stuff. So let's just do a 5 time millisecond. I think that should be good. What's this here? Millisecond, right? That's fine. And then do we have a time sleep here also? It's 2 seconds. That's already way too much. You're gonna say milliseconds. I think 5 milliseconds is fine. I think even 1 millisecond is good enough. Let's make run this and see if it finally can work, so we can continue live. Yeah, I think it did, right? You look at this. It's nice, right? Incoming stream, write to bytes, stream closed. Incoming stream. The only way to test is basically to open up these folders here. Actually, I'm going to delete these guys. Delete permanently, like this. And then what I'm going to do here is, instead of making this key, we could do something like an FMT. I'm seeing that I'm not coding in my window here at the top. FMT, I think an sprint, right? An sprint f. And we're going to say my private data underscore percentage d. And then we're going to say y. Right? So it's going to have a different key. So it's going to write all these files 10 times, hopefully 10 folders. Make run. Let's see if something happens. Yeah, of course. I was thinking, why are there 2 folders? But it is because the root, right? So yeah, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. And here also, not quite sure if there is something in big data file. That's fine. Yes. I think it's working, guys. I think it's working here. Yes, big data file, and of course in our thing here. Yay! Haha! Woo! Yes, it sounds silly that I'm so happy, but it was nasty bugs. And I was thinking, I'm going to be honest, I was trying this for a bit because it was a very nasty thing we need to solve with this prefixed byte, what we needed to do. And I was testing this, and how can we do this? Because I cannot figure these things out at hoc, right? Although this is not scripted, but I still need to pre-think up front how a potential in my head, right? It's not on file, not on my keyboard, but in my head I was thinking, how can I do this, and it took me some time to think about that and to figure out what we needed to do, right? That's something that I do, right? Is thinking up front before I actually make a video, because otherwise it wouldn't be fun for you guys that I'm sitting here for 10 minutes just thinking in silence, right? Okay, cool. So I think what we're gonna do here. Let me quickly check. So I think everything is set up fine. What we could do is to make it a little bit better is in transport the speed. Let's call this a function. And why? You see here TCP, right? There is no TCP. Yes, here, right? We say peer TCP. We cast this to a TCP peer to lock, to close, to set done. So basically, the read loop can continue. So what we're gonna do is basically say we say close streaming. Close stream. Yeah, and that's not gonna do anything, but close stream will close the stream. Something we need. And then in TCP peer, what we could do is basically make this VG public, private. My bad. I'm gonna make this VG private, so it's gonna be VG like this. And then we are going to make a function func. It's gonna be TCP peer. I think it's close stream. Yeah, like this. And then we're gonna say here p VG done. We're gonna call done on the VG. And then I think we have these capitalized VGs at the bottom. We're gonna make them RW. Why is this? What's going on? RW. Yeah, I think that's fine. And then instead of calling this peer here, we could say peer close stream like this. And hopefully that's gonna be the same outcome. And then we have a little a dynamic implementation without hard coding shenanigans. Yeah, I think it's working perfectly fine. Yes, I'm happy. I'm happy because this is actually never did this before, and for me this is also a nice project to do because, like I said, guys, I'm not doing. I never did this before. Well, I experimented with these things, but this is the first time I did this in a bigger scale. All right, this is looking good, man. This is looking so good. Yeah, and I think for the next episode, because we're already at 33 minutes, the next episode, we are going to handle our get, because right now we have a nice and clean way to handle streams. So now we can get the file. If we have it, we're going to fetch it from our local disk and everything is fine. If we don't find it on our local disk, we're going to get it from our other peers, which is the power of our decentralization, right? And I think then what we need to do still is our encryption. And I think then we are coming close to the end. In the previous episode, let me make run real quick. We fixed our TCP transport to enable to support streams, right, for big files. And as you can see, we are writing a lot of files to the network, which we have Node 3000 and Node 4000, and they have all the files we need to distribute, which is good. But now, that's fine, working fine. The next thing we're going to do is basically open up a server. And maybe on the other side, we're going to open up, I don't know, maybe nothing actually this time. This time, nothing. So, we have, let me put out this cursor here. We need to fix our get, right? So, let me search for that real quick. Get, here, right? So, basically, we can store, that's fine, but what we also need to do, and we already did that, but it was a little bit scuffed because we need to fix our streaming option first, or streaming support first, right? So what we're going to do is we're going to fetch a file. Wait, let me open up main to show you better, right? So we have main here, and what we're going to do is we're going to make one file. We're going to store one file real quick. Let's do this. We're going to say cool picture, maybe cool picture.jpg, like this, and we're going to store data, right? That's what we're going to do. Let me quickly delete these folders real fast. Delete permanently. Oh, he's gone. Get him out of here. All right, so let's do a make run. So we just store one file. Like this, of course, stream close, resuming read loop. I think we also need to fix one more thing because we're hanging, and that's not good. Oh, yeah, let's deselect here. I see. That's no big of a deal. So if we open up our folders right now, we don't see anything. Is that okay? I think it's a VS Code bug, to be honest. It's a VS Code bug because if I ls in the folder here, we see the 3000 and 4000 network. So what I'm going to do is I'm going to remove wait, we are sending this from 4000, right? Yeah, so I'm going to remove the 4000 network like this. Not quite sure why VS Code is not showing this, but anyway, a little bug, why not? So that's fine. I'm going to comment this out, and then we are going to comment this in back in, and we're going to say we don't want to get the private data. We want to get the file, and it's going to be cool picture.jpg. What's going on here? JPEG, right? That's what we want to fetch. So basically, we're going to try to fetch this, and we're going to check, first of all, we're going to check our local disk, right? And if we have it on our local disk, we're going to serve it from our local file, from our local server, from our local disk. But if we don't find it, then we're going to grab the network and try to fetch it from one of our peers. That's the main goal, right? So we're going to get here. The first thing I'm going to do is make some, because now we have support for our adder, right? So it's very nice to prefix this with the adder of the server. So we're going to say as transport other, and then this is going to be the key, right? Like that. Let me close this because, yes. So we're going to get it. What we could do is basically say here, if we have the file, we're going to say, let's delete all this junk. Serving file from local disk. Yeah. And it's going to be the file, which is the key. Yeah, fine. And if we don't find a file, then we're going to grab it from the network, do that stuff. That's all good. We broadcast this, so we're gonna prefix that with the message byte. That's good. Receiving stream from peer, I don't think we need this. Maybe we're gonna do a little time sleep here. Not quite sure. We need to check these sleeps. Time millisecond maybe. Millisecond. What's going on here? I'm gonna say 500 maybe, something like that. What am I doing? What am I doing? Still sleepy. Time millisecond times 500, that's fine. We're gonna range to the peers. Then we're gonna say here maybe a printf actually. We're gonna do this %s received this amount of bytes over the network, which is gonna be a %d in a format over the network, and maybe we could do from. This is going to be S transport adder. It's going to be N, and then this is going to be peer remote adder. Right, that's fine. Then we can print a buffer here, but we don't need a buffer actually, right? We don't need a buffer because we need to store it to our disk. But let's try it first like this. And we don't need to forget that we need to send a stream message to this peer. Wait, so we're going to say get this here. So we're gonna receive it here, right? That basically means that we're gonna say peer close stream. Something like that. Let's see if this is actually gonna work. Yeah, let's try this real quick. No, we need to send. This looping stuff. Handle message get file. We're gonna do the same thing here. Need to serve file, but does not exist on disk. So we're gonna say %s, which is gonna be s transport adder. Serving file over the network. Let's do the same thing here. S transport adder. Yeah. Let's make it clean. We're gonna read from store. We're gonna check our peer. And then we're gonna copy here, right? So the first thing we're gonna do is peer send. We're gonna send this peer-to-peer incoming stream thing. Like that. And then we're gonna say here, we need to do a lot of clean login stuff. Written this amount of bytes over the network to this guy, that's fine. And we're gonna say it's gonna be again S transport adder. I'm gonna return null, right? Okay, let's see where we at. I'm gonna make run real quick and see what's going on. All right. So we don't have the file. We're serving the file. We've written over the network. We have a stream. We receive the bytes, and then we say, and you can see that we fetched it, right? You see it here. Of course, it's not gonna be in our these. Not quite sure what this is, what's up with these folders, by the way. If you do an ls all, we can see we don't have 4000. That's because we don't store it yet onto our disk, so we need to fix it. Some coffee never hurt. Gold of the world, it is coffee. Okay, so what we need to do, I think, actually, it works pretty fine. Now that we have the streaming support, it walks like a breeze. What we're gonna do is this one, right? So received. What we're gonna do is we're gonna try to receive from every peer. That's not the best option because we need to check the first peer sending or something. I don't know, but that's for later on. It's fine to receive it from each peer, doesn't matter. And we can actually use goroutines for this also if you want. So we don't need a file buffer and we don't need to copy. What we're gonna do is S is do something like if n r is going to be as store right. It's going to be the key, I guess. And we're going to use the peer. Yeah, and if the error is not nil, we're going to return an error. Or what do we return here actually? A file. A reader actually. We're going to say null r, right? We don't need the shenanigans. So n is working, that's fine. We cannot do that. We need to do this. If r, right, like this. Then we have the r. This file buffer, we don't need this. We're going to close the stream. We're going to stop doing this. And then what you could do is return. We could actually pipe this into a T-reader or something so we can write to disk and then return it. But the problem is that we are in this loop. So I think a good option is to just return, once we're done with this reading, is basically just return as store, I think read the key, something like that. So we can actually fetch that in our main. So we can fetch that here, right? And actually, do we need to select? We don't need to select. Let us see what's going on here. Let me see what's going on. So we don't block here. So why are we hanging? We are hanging. Let me see. But we have the file. We have the file in the network, which is good. I see what's going on. Of course. Remember in wait, where is our limit reader? You see, remember this limit reader where we need to tell if we're writing to the store how much we're gonna read from this connection? That's the exact same thing we need to do. The problem actually is the problem that we have is basically that we don't know the file size yet. Where are we copying? Here, right? So what we need to do, if we write here, we need to make this an IO limit reader. Like this, and then we're gonna say, let's say 22 bytes here, right? You know what I mean? Because we know it's 22 bytes. But of course we cannot we cannot hardcode that. I know. We're gonna fix that. We're gonna say make run to see if now everything is working fine. Let me see. It's working fine. Look at this. But we have it. We're gonna say rm because we serving file from local disk. Yeah, that's so good. rm rf. We're gonna say actually, can we do S2? Can we remove something from disk? Let's make that real quick, to be honest. S file server remove. Yeah, this remove thing should also remove from the yeah. That's yeah, I see. What we're gonna let's just do an RM because we also need to remove from all the peers then. So that's it's gonna take some longer than just a couple lines. So we're gonna say RM RF is gonna be 4000, right? Because we're sending. We don't need this. Fine. Let's make run. Let's see. Received. Received 20 bytes of the network. What I was testing actually. Totally forgot. Yeah. You see, that's the 22 twice. Right? That's why I prefix it to 22. So we're gonna fix that. There is basically, I don't think, a way to know the file size if you want to send that, right? So what we're gonna do is we're gonna send the file size over, right here. So what we're gonna do is we're gonna send. I'm gonna say first send. First send the incoming stream byte to the peer. First send incoming stream to the peer. Incoming stream, and then we can send the file size. Yeah, then we can send the file size. And it's gonna be as an N64. Okay. So we're gonna send the stream, and then we're gonna say what is the file size actually? We read it here. Yeah. Let's hardcode it. Let's send it hardcoded over, and then remove the hardcode here, right? Piece by piece. So we're gonna say, for example, var file size, which is gonna be an N64, is gonna be 22, right? Then we're gonna say binary. Actually, yeah, we're gonna say binary dot write. We're gonna write to the peer. We're gonna say it's gonna be a binary, a little endian, and we're gonna write this file size like that. So we're gonna write that as binary, and then we're gonna copy that, right? So now we need to fetch it on the other side. Let me find for 22 here. So the first thing we're gonna do is read the file size, so we can limit the amount of bytes that we read from the connection, so it will not keep reading or hanging. Right, that's what we're gonna do. So we're gonna say var file size, which is gonna be an int 64, like that. I'm gonna say binary. Can we read that? Yeah, binary read. Did we a binary read? We need to do a binary write. Did we do this correctly? Yeah, binary write. Okay. Fine. We did it like it. Okay. Here. So we're gonna say binary read. We're gonna read from the peer's connection. We're gonna say it's gonna be a binary little endian. And we're gonna take the file size like this. And then we're gonna say here file size. Right, so we removed the hard-coded stuff here. Yeah. Okay. Let's delete this again. rm minus rf 4000, not 3000, because yes, like this, and make run and see. All right. Looks good. Okay, cool. So let's open up 22 here. So the problem with this 22 is that we need to have the file size to send it over. The problem is the only thing we get from read is basically a reader. So you could say, yeah, why don't we read it into a buffer and get the file size? But I don't think it's a good idea. Because I will need to read it into a buffer and it's just nasty. So I think I'm going to open up store here. And I'm going to open up the read stream. Do we have that? Guest transform func. Read stream is this one. Where is read stream? Damn, it just open. Write stream, read stream. Is this actually a good way? Because we... This is actually... I think we are reading this into memory, to be honest. Instead of piping this directly to... We need to fix that. I'm going to say instead... We first copy this in to a buffer. Maybe just return the file from the read stream. Yeah, so we have this here, right? And then we have this read closer, which is also a reader, and then we copy it first. So why don't we why don't we remove this, right? We could remove this. I think that's an important aspect. We're gonna fix that. It's good that we have this this to do here. Or maybe a fix me actually. All right. So what we're gonna do here is we have this n, right? We have this n, so we can return the amount of bytes we have. But the problem is that if we're not gonna use this later on, then we don't have this n. So we cannot return the file size. So what we could do is in this read stream, we do an OS open here on this full path. Can we do an OS stat? Full path with root. And if the is not null, we're gonna return null. What's FE? Do we have an S size or something? We have. That's amazing. All right. So what we're gonna return here in a read stream, we're gonna change this a little bit up. We're gonna return a size, which is gonna be an N64, an IO read closer, and an error. I'm gonna do this, and we're gonna say that the file error is gonna be this. Can we do file size? Wait. Let me do this. What does it return? A file of an error. We're gonna return here 0, nil, R. It's actually a little bit nasty. You're gonna say fe r is gonna be stat. You're gonna stat a file. I'm not quite sure why there is an error. If you already open up a file and then you stat it, why it's gonna return an error, to be honest. So we're gonna say return the same thing, 0, nil, r, right? And then we're gonna return fe size file null. If that makes sense. Of course, our tests are gonna be broken. I know. Of course, this read is gonna give us some issues because that's gonna be n. And we're gonna return also an N64 here, right? We could do n here. That's fine. This is crazy. Let's fix this. I don't like this. We're gonna say n r store read, right? And then we have already an n. Let's make it size. Or file size, maybe. Maybe that's even better. File size, we're gonna delete this. We're gonna copy the file size here. Yes. Something is wrong in server. Not quite sure what it is. Let me do a make real quick. 89. I need to sneeze. I'm so sorry. Live on video. I'm my bad. I'm not gonna cut it, man. I'm not gonna cut it. Hey, like I said, this is the live off. You know what I mean? This is the real deal. It's the real deal. I love you guys. All right, so are we going? I don't think we're gonna return this. What we're gonna do is basically do this reader r, and then we're gonna return r reader r, right? Something like that. Maybe we return the file size. I don't know. Could be. 122. The same thing, right? What is this? Get. Yeah, I see. I'm gonna return a store here. And store read is gonna return us this thing, r, reader r. And we're gonna return r, reader, right? Something like that. So I think now everything should be not hard-coded. From local disk, I see. I'm gonna rm rf 4000, yes. Make run. See if you get it from the network. Yeah. Man, this is insane. This is insane. So that's fine. So what I want to do with this binary read stuff. Actually, I was thinking maybe we should abstract that, but to be honest, I think it's pretty fine. I mean, a little bit of logic is fine. Multi-writer. I need to fix that. It's a to-do or a fix me. Let us see in our test real quick. Do we have a store test? Yeah, here's right stream, right? sRead is going to return us n. What is right stream doing here? What's going on with this? I cannot initialize one variable with two. Oh yeah, that's returning an error also. Yes, tests are working fine. That's already taken care of. All right, the next thing I want to do is this. I'm not happy with this read stream. Because we do this file, yeah, that's fine, but this is bad, this read. We copy it here. Why do we do this actually? Why don't we just return... Right, we could actually just return this. Because we don't close the file. But does it matter? Right, we could just do this, right? Look, we could actually just do this and actually get rid of one of these functions. We could just return as read stream the key. Like this. The question is, are we gonna... This should be better actually. That works perfectly fine. Now it's gonna fetch from from local. I hope you see what the problem was, right? So let's revert this real quick. You see, so we get it from the... So we do read stream, right? So we do our shenanigans, we get our file. And then what we do is we basically say, yo, copy everything into a buffer. But can you imagine that's a 10 gigabyte file? Then we fetch it from the store. Then we're going to read it into a buffer. And then we're going to copy that buffer. That's not good. That's not what we want, right? So I think... I know it's a little bit weird. So we're going to just return the read stream here, right? That's fine. So we can remove this fix me already. Of course, you see this function has nothing in it. It just returns this. So we can... Maybe if you have a cache, right? Let's keep it for now. Let's keep it like that. The thing is, what I want to do is... I'm going to... search for store read. Because this is going to... We return that. So we return basically that stuff here. So in main, it's a reader, so we cannot close it. That's why we did it, right? I see. That's why we did that, so we could close it first. Need this one, right? This R. So we should actually do like a defer R close, but we can't. What we could do is... can we do this? There should be a pointer to a read closer, maybe. Can we do something like this? Maybe... that's nice. Yeah, I'm gonna explain. Actually, I was thinking too hard. So basically, what we do is we check if the thing we fetched the reader. We check if it's a read closer. If it's a read closer, we're gonna say defer rc close. We're gonna close it. And I wanna... Let me quickly see if we can test that. Make run. And we can assert this. I'm gonna explain real quick. Close and reclose, it's fine. That's cool. So what you could do in Go is basically you could assert if certain implementations are true, right? So you could say the read closer, a boolean, equals the reader. Is that a read closer? If it's a read closer, this okay will be true. If it's not, then it will be false, and then we don't care. The thing is, this RC, I think I should do it like this. If something like that. Something like that. Of course, now we're gonna fetch it from local, so it doesn't actually matter, I think. Yeah, it's fine, it's fine, it's fine. All right. So I think that's good. Very, very, very good. I think it's actually perfectly working. So what we also do is a delete thingy. That's so we can remove files. We need to do our encryption. And maybe a separate thing where we do some cleanup, and then I guess we have our thing. Of course, you can, like I said before, you can make this as complex as you want, right? You can do so many cool features, but I think that's a very, very good practice for you guys on the other side of the camera, where you can have this working thing, but you can extend it with some cool functionality you think it should have, right? Because like I said, we can keep developing this for months and make it better and better and better and better. But the question is, where does it end, right? So we're gonna do a couple things more, so it's gonna be good and robust. And after that, we can close that series and we can start another series. So the previous episodes, we can store files, we can retrieve the files, we can retrieve them. We can store them in a decentralized distributed way. We can retrieve them from our peers if we don't have the file locally. It's all good. We have stream support now for our TCP library, peer-to-peer library, by the way. And I think it's a good time to implement encryption, right? Because as you know, if we're gonna store the file, and we're going to store the file on other peers in the network, we don't want to store the plain bytes. We want to encrypt it with an encryption key that we and only we have. So if we want to retrieve the file, we can decrypt it back and we can see the contents of it, right? So of course you could say, are we going to encrypt the files if we store it on our disk? You could, maybe you should. Not quite sure if you're going to do that, but we are going to make sure they are encrypted, that they are stored encrypted on our peers. Of course, they don't want to see our nudes, right? So, so what we're gonna do is basically, and I'm gonna look up some documentation for that while I code it, because it's you don't do this every day, right? So you cannot know this on the top of your head. The first thing we're gonna do is actually, let's delete these two bad boys. And then we create a new file. We're gonna make this crypto go. Then what the hell is this? What am I doing? Crypto go like this. Let's close it. Yes, we're gonna say package main. And then we're gonna call this, as you can see in our storage, right? I think we also have something like IO copy. Like this, right? So we're gonna make something like that, a streaming way. So the very important aspect is we are not gonna encrypt them into memory, because, like I mentioned before, we are supporting streaming. That basically means that we don't need to read every single byte that is being transferred into memory, but only a portion. And I think if you want to know how much that's gonna be, you can see copy here. We do copy buffer and copy buffer basically here. So you see that the size is gonna be 32 times 1024, right? That's basically the buffer. That's the maximum amount we are going to read into memory. And we're going to do something similar with our function. And I think we're going to call this copy encrypt. encrypt like this. We're going to take a key, which is going to be our encryption key. It's going to be a byte. We're going to take in a source, which is an IO reader. And we're also going to take in a destination, which is going to be an IO writer, like this. And I think we're going to return the amount of bytes that's being written. And very important is normally you should say we're going to read and then we're going to encrypt and write, but we're not going to have the same bytes written as wrote, write, and read. I don't know what the correct verbs are, but we are going to write more bytes than we read because we're going to prepend or IV, which is a cipher thingy. We need that for our encryption, right? So we're going to say it's going to be an int and an error like this, right? Okay, cool. So I'm gonna a little cheese a little bit. I need to look things up. So I have some documentation here, and I will link the documentation in the description, of course. Right. So the first thing we're gonna do is I think we need a block R, which is gonna be AES. We're gonna use AES encryption, and it's gonna be AES rather. We're gonna say new cipher. Is that? Yeah. New cipher, and that's going to be, we're going to give our key. That's will return as a block, a cipher block. First of all, we're going to say if the error is not nil, we're going to return, actually, could we, let's return 0 and an R here. Just like that. And then we have a block. Let me quickly see if I'm actually recording, but it's not the first time I'm doing these crazy shenanigans. It's all fine. Then we have a block here. And we're going to need that block because we're going to create an IV, which is going to be... And that's the thing we're going to store, actually. We're going to say make a slice of byte, which is going to be a block size. And I think this is going to be 16 bytes. Not sure. 16. Not quite sure if that's true. We will see, we will see. So we have this IV. The next thing we're going to do is fill it up with random bytes. We're going to say if underscore R is going to be IO read full, right? And we're going to pass in a reader, which is going to be a random reader, right? Like this. And then we're going to say IV. And if the error is not nil, then we're going to return 0 because we didn't wrote anything. And the error here, that's fine. Let me scroll a little bit down to see what the next thing we need to do. Right, we need to make a buffer and a for loop. So we're gonna for loop here, right? But first of all, we're gonna make a buffer, and the buffer is gonna be make me a slice of byte, and that's gonna be 32 times 1024, which is basically this thing here, right? That's gonna be the buffer. That's the maximum amount we're gonna copy in memory. And I think we also need a stream, which is going to be AES. Is that? It's going to be a cipher, actually. New CTR. Okay. Not quite sure what it all is, but we need a block and the IV here. So we can have a stream. And actually, you could do a var to make it a little bit cleaner, like this. All right, so now we can start reading from our source. What you're gonna say? Not quite sure if you need the n. First of all, let's do n. Yeah, we need the n. We need the n for some checks actually. The amount we read, we need that. We're gonna say here it's gonna be source read. We're gonna read everything into the buffer, right? Yeah, if there is an error. I don't think we're going to check the error yet. We're going to say if n is bigger than 0. That's important. And then we're going to say stream. Source stream. That's what we want. And we need the buffer. And then we're also going to say the buffer and the buff with the amount of bytes. It's going to be, yes, this, right? The amount of bytes written. Read, actually. Amount of bytes read. And then we're going to say that the destination... We're gonna write the buff n. Yeah. Yes. Yes, yes, yes. We're gonna write everything. This stream is gonna write everything into this buffer. Let me quickly see what's this is bytes. XOR each byte, yeah, that's what he wants. XOR each byte. Yes, yes, yes. It's gonna XOR each byte. It's red. I'm gonna place it back. And then we write the encrypted stuff into a destination. Yes, of course we're gonna check this with an error, and if the error is not null, then we're gonna basically return 0 and the error, and we're gonna do the amount of bytes written later on. To be honest, what is this? This is gonna be perfectly fine, and this error is here. So we're gonna say first if the error equals an IO end of file. Then we're gonna break, right? We're gonna break. Then we're done reading, and then we're gonna check the error. So if the error is not null, then we're gonna return the error. Right? Yes. Okay. And then here we're gonna actually return. We need to return some value. We're not gonna do that quite yet. We need to return the amounts we wrote. The thing is that we also, this IV is very important, right? This IV needs to be in the file because we need that for decryption. So what we're gonna do, we could do two things. We can either store it, we can append it to the bytes, or we can prepend it. And I think I'm gonna prepend it. So enable to prepend, we could say prepend div to the file. So we're gonna say if underscore r is gonna be the destination. So we're gonna write the IV, just plain bytes, so we can write it like this. And if the error is not null, then basically we're gonna return 0 and the r, right? And then we're gonna start reading. Yes, yes, we're gonna start writing to the file after the IV is inserted. Okay, cool. So let us open up. Actually, let's make a test, right? That's gonna be a good thing. I'm gonna say crypto test.go package main. We could say test, func test encrypt test copy encrypt t testing.t. What's going on here, guys? Yes, save it. Cool. So what we could do is basically say we're gonna have a source, right? And that's gonna be a bytes new reader, like this. And we're gonna say it's gonna be bytes, and we are going to encrypt foo not bar, something like that. And actually, yeah, that's fine. And then we're gonna say an out, or a test actually, a test, and that's gonna be a new bytes buffer, like that. And then we're gonna say we could say n r is going to be a copy encrypt. And we're gonna say, I think we need a key actually. Yeah, we need a key. That's a problem. We don't have a key. Let's make one. Let's make a key. We're gonna say func new encryption key. Encryption key. And it's gonna return as a slice of bytes. We're gonna say, how are we gonna do this? I think we can say that the buffer is going to be the key buff. It's going to be make me a slice of bytes. It's gonna be 32 or something. And then we're gonna say IO read full rand reader into the key buff. And then we can actually return the key buff bytes. We don't need to, we can actually just return it like that. So then we have a key buff. Is this a capitalized? No, it isn't. New encryption key. Like that. Then we're going to say the key is going to be here. We're going to say the source is this, and then the destination is that file. And then we're going to check if r is not null. We're going to t error the f. This n is going to be 0 anyway, so we're going to skip that for now. And what we could do is basically fmt println, and we're going to say that the destination bytes. We're going to print the bytes out. And let's run this test real quick here. All right, so we have these encrypted shenanigans, which is cool. One more thing I actually want to test is basically this one. Func test new encryption key t testing.t, and we're going to say key is going to be new encryption key, and then we're going to say for the length of the key. First of all, we could if key y equals, can we do this? Is that a thing? Not quite sure if you could do that. 0 bytes. Not quite sure. Oh, we have it now. The question is, I think these keys are fine, to be honest, but I cannot check it with 0 bytes, right? Because I could actually do fmt wait. I could print out the key all the time. Of course, there will be a 0 byte, right? You see? I think this key is fine, to be honest. I don't think we need to test it. It's fine. Because there will be 0 bytes. Doesn't matter. Okay, so test copy encrypt. Actually, what we're gonna do is copy test copy encrypt decrypt. Like this, right? So the next thing we're gonna do is copy decrypt. That's the next function we're gonna make. We're gonna say, actually, let's make it at top. That's better for you guys to follow along. We're gonna say copy decrypt. We need a key for sure. It's gonna be byte, and then we're gonna say that the source is gonna be an IO reader, and the destination is going to be an IO writer. And then we're gonna return an int, of course, again, and an error. And we need to fix these ints, these bytes written and read soon. All right, not quite sure what we're gonna do here. Do we need a block again? Let me quickly speak and peek my my thingy. I think we need the block again, right? So we're gonna copy this. We make it the block with the key. That's what we need. Now we need to read the IV. Read the IV from the given IO reader, which in our case should be Alright, so read the IV from the given IO reader, which in our case should be the block size bytes we read. Yeah. How are we gonna do this? So I think so we're gonna say something like this. IV is going to be make me again a slice of bytes, which is going to be a block size like this, right? And then we're going to say if underscore r is going to be the source read me this IV r not null. Then we're going to return what's going on here 0 r. Then we have an IV, all right? And I think we need to for loop again. Then we need again this block, right? This stream once again. And this buffer also. So I'm gonna copy this. I'm gonna paste it in here. Buff stream. That's all fine. Then we're gonna do the same thing, right? We're gonna say n r is going to be source read into the buff. If there is an if n is bigger than 0, we're gonna stream.xor stream, I guess. Again, the buff and the buff n. And then we're gonna write the encrypted things, the bytes we encrypted back to dest. We're gonna say dest write. If it's gonna be nr dest write the buffer, but we write the buffer what we have written, actually encrypted. And if the error is not nil, then we're gonna capsing locking. We're gonna return 0r, right? And then the same thing if r equals io end of file, break if r the thing is, could we actually not reuse this? Wait a minute. No, we can't, right? Because we need to read the IV in this case. Well, some stuff we can actually split out because we're copying too much stuff here. But the problem is that there are a lot of things gonna change because we're not gonna. We will see. We will see. Not the end of the world. Not the end of the world, right? So what we're gonna do here is basically we're gonna say. Let me open up back my OBS so I can see what's going on here. Yeah. We're good. Okay. So what I'm gonna do here is basically so we have this is a destination, we have our key, we encrypt it here, then we can say out. It's gonna be make a new buffer, right? And then we're gonna say that if underscore r is copy decrypt t. No, what am I saying with t? It's gonna be the key source. No, it's gonna be the destination, right? It's gonna be the destination, right? This destination is gonna be the encrypted file. And the source is going to be, well, the new destination is going to be out. If that makes sense. Arrow out, and then we're going to say out, and let's make a string here, so maybe we can see what we, because our encrypted stuff is basically foo not bar, right? And maybe we should also print out the encrypted here, right? And the encrypted here, in this case, is going to be the destination. Destination string and then the actual string, the decrypted string. I hope it's gonna, we need to test actually. Can we do this? Let's just test here. Yes, so you see it's working, right? So we encrypt it and then we decrypt it and we have foo not bar, which is good. It's working. And our tests are passing actually. Passing, we need to say if out string is not equal to actually it's gonna be foo not bar, right? Payload. Now we can check it actually. Out string should be the payload. T error f expected encryption failed. I don't care. I'm gonna say encryption failed actually. Decryption failed actually. All right, that's gonna be it. That should actually work all fine. So we're gonna do make test real quick. Boom, everything is fine. Let me test this here. Boom. Pass. Yes, yes, yes. Good, good, good. So we're gonna delete these things. Wait, is it like this? Yes. Okay, encryption done. Right. Nice AES encryption. Copy streaming support. And I was looking for some coffee, but I don't think I have one. Maybe a little bit. It is what it is. A little bit caffeine. Okay, so there is a little problem, right? So I'm gonna tell you what the problem gonna be, because if you go to server, right, and here, this copy, I think what we are doing. Wait, I think also in the limit reader is gonna be a problem. Yes. So it's a message size, right? But the message is size like this, right? For we have this. It's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? It's going to be 11 bytes. The problem is that the destination file, the encrypted file, is not going to be 11 bytes. It's going to be 11 plus 16 bytes. Because we put our IV, right? We placed our IV into the file. The first 16 bytes normally, right? So how are we gonna do this? If you go to crypto real quick. Because if you check this N, wait, let me test something. So we're gonna do this, copy encrypt. You're gonna say fmt. You're gonna say println, right? And we're gonna say println len payload, right? So if you send len, it's not gonna be, boom. It's gonna be 11, right? So it's 11 bytes. That's fine. But if we print a len, this len out string. Wait, that's basically the same thing. Wait, I'm stupid. You're gonna say print a len, the destination, right? The destination is basically the destination of the encrypted stuff. Wait, we cannot do it like here. We need to do it here. Boom. You see, it's 27, right? Because that basically means if we do 11 minus 27, you have 16. Right? So the IV is 16, and we can test this by doing len block size, right? What? We cannot do len print len without the fmt. Why not? Wait, we don't make it. We need to. We have this test here actually. Boom. You see, 16, right? So that's fine. So how are we gonna make sure we return the same thing? We're gonna only check what we wrote. So we're gonna make an NW, and written is basically 0, right? It's gonna be block size. All right, and then each time we're gonna write here, it's gonna be an NW. I don't like this, to be honest, because we have an N already. We have an NW already. So we're gonna say this is hard. How are you gonna call this variable? An N or something? I don't know. Gonna be an N, and here we did our best because we wrote here, right? It's fine. And so we're gonna say that NW plus is an N. What's going on? Block size int 64. And what is this? Int. What the hell's going on? Oh yeah, see, I'm stupid. And we're gonna return NW. right? But that's only in copy decrypt, right? So we could say this. And this is going to be 16. We're going to quickly test, right? We're going to say 16 times. Basically, it's going to be len out string. We can actually say out len, right? Yeah, but that basically means I'm going to say len payload to make it sure. Can I say tfail or something like this, man? Fuck it. I mean, all right, so that's working fine, right? I know it's a bit nasty that we're doing this thing. Because it's important that we return these bytes because we're gonna need them to send it over, right? We're gonna need them to send it over because if we're using a server, right? Let me say it's store. You want to say we store a file, then we have basically here, because this is locally, right? This is locally, so this size is going to be in this case 11, right? But then we're going to broadcast yada yada yada, and then we're going to say here there's going to be a stream, and we need to can we just copy this? Because we're sending that it's going to be size, it's going to be encrypted. So we need to say here plus 16, right? What's going on here? I'm losing my slipper. I'm losing my slipper. So we're going to say plus 16, and I don't like the way this is happening. Because it's a hard-coded thing, so maybe we should... And we don't can... Unless... This size is going to be 11, right? So, 16. It's going to be fine, I guess. And this needs to be a copy encrypt, right? So we're gonna first of all, we're gonna say our server, file server options actually, and we're gonna say that the enc key, which is gonna be a slice of bytes, right? Yeah, slice of bytes like this, and then we're gonna say, yeah, okay. So we have an enc key. And then where is store? Here, what we're gonna do then is basically we're gonna not use this, but we're gonna say R is gonna be copy encrypt, right? And it's gonna be the S enc key. It's going to be the destination, the source. What's going to be the source? The source is going to be... Where is that file buffer? This is the file buffer here. This is our T-reader we use for T'ing here, which will then write in file buffer. So the source is the file buffer. Yeah, and then the peer is gonna be our destination. Yes. It's a little bit different than copy works, because copy takes in the destination as first argument in the function, right? So we can return R in this case, and then we can say receive into bytes. Is this gonna work? I have no clue. Let's see. Make run, I guess. Wait. First of all, guys. Very important. We need to have an enc key in file server options. We're going to say the encryption key is going to be new encryption key. Let me close up this thing and make a run and see if we get encrypted files, please. Let it all work just fine. Oh yeah, of course. We are our main is basically we are fetching stuff, but we cannot fetch anything because we don't have anything, right? So we're gonna just do this, make a cool picture thingy, sleep 5 seconds, no idea why we do that. Make run and see if we can store that file. You see that we received and written bytes to disk is 0. Zero. Okay. And actually, guys, I found something. Like, remember in the previous episode, we had this issue with these folders, but you can just click refresh. So we were 4,000, right? So do we have our file in plain text? Yes, we have our file in plain text. But do we have our file distributed encrypted? Yes, it's encrypted. Aha. Hey, that's good, right? That's a very Gucci. Okay. That's all good, but we had one issue, and I think it's basically because let's open up crypto. I will open up here. Bytes written to disk. Because if we decrypt, you're gonna tell how much we decrypted. Wait, why am I'm in the wrong crypto? No, I am in the right crypto. It's fine. It's in copy encrypt, right? That's what we use. I think we can do the same thing. We could say this is gonna be block, and I think we can make this function even better. What's going on? Ah, we cannot do this. Block size. What did we do here? NNW. And then it's actually the same code. We need to be. We're gonna split that out. We're gonna write to the thingy. We're gonna say NW is gonna be plus equals NN. And in this case, we're going to basically return NW, right? So basically, we're going to store it. Right now, we should have the correct output. We received and written 38 to the disk. That's actually not true. Because we're not encrypting it. Maybe we should encrypt it locally. Because we're gonna write if we copy encrypt, right, what do we mean by this int? That means that how many bytes did we copied and encrypted? Right? So in this case, copy and encrypted, how many bytes did we copy and encrypted? That's basically... It's difficult because this block size, we actually have the IV in the file, so... But we copied only... the file size. Yeah, that's something we need to think about. We're going to see that because in the next... I'm going to cut the video out here, and correct me if I'm wrong, but I think if I do a git log, the previous episodes we did encryption and decryption of our files. And I think that we basically, yes, we could store things. And let us actually rerun this real quick. Let's delete these two bad boys. Hop, and then we can just say make a run and see what's going on. Normally, I think it should be distributed, and let me refresh these folders here. We're gonna have 3000, which is gonna have nothing. And this guy, what is going on here? We have a little issue. Is that? What is going on here? What a nice way to start, isn't it? Is that a thing? What do we have here? Nothing. All right, no worries, no worries. Make run. Let's see what's going on. No panic. We don't choke. Stream closed. Resume read loop. That's the thing. That's a thing. So 3000 doesn't have the files. It has. What's going on? Let us delete these two guys once again. Delete permanently. Maybe it was just I don't know. So basically, right now we don't have any files. Right? No folders, no nothing. That's fine. Let's make run. And normally everything should be distributed, right? Make run. Let's see what's going on. Let's see what's popping. All right, received. This is better, right? This looks better. So we have this guy which is encrypted, and then we have this guy which is not encrypted because it's our local disk. Okay, cool. Not quite sure what happened there. I think I don't know. Maybe we have no clue. Let's not worry about it, right? Let's not worry about it. Okay, so the next thing we need to do is basically find a way to retrieve these guys, right? And if we open up server on this side, and maybe main the other side, then we're gonna see that I think it's handle get file. Is that a thing? Handle get file. Here, this one. We do a copy here. But this is sending, right? So we are sending the file, that's fine. Right, if you get a file, yeah. I think, yeah, it's get, right? If we ask for a get here, right? And we cannot find this on local disk, then we need to basically fetch everything from store write. That's the thing, right? So we gonna fetch the files, we're gonna write, but the problem is we're gonna fetch these files in an encrypted way. So store write is not gonna work here, right? So we need to open up store, and we need to search for write. This guy, right? And this write is calling write stream. But write stream basically just copies here, right? You see this IO copy, it basically just copies what it gets, and that's not good because it's encrypted. We need to decrypt this, so we should replace this with decrypt, copy decrypt. The thing is, maybe I want to do something like func as. Let us see that I'm not coding in my window. We're gonna say write decrypt. Which will take an N key. It's going to be a slice of bytes. It's going to take in a key, which is a string, and of course an IO reader, which will return an N64 and an error, just like this. And to be honest, everything is the same, right? You could copy the whole shebang. It's only this. Of course, we need to make this a little bit better, because just copying this is maybe not the right idea. And this is going to be, I think, copy decrypt, but with the enc key. And we need to be careful. Let me open up crypto. Copy decrypt takes in a source and a dest. The source is R and the depth F is a little bit different than IO. Copy. And of course, I think this R, this N, is going to be an int 164. Which basically means we could do something like this. N64N, and then of course the error if there is one, so we could check that. Yeah, we're gonna refactor this real soon, but because there's a lot of duplication going on here. You see, it's the same thing here. You could actually just delete this, right, and just return these things. Actually, can we not just return the whole thing? Look at this. It's basically the top part that needs to be refactored. Yeah. Okay, so how are we gonna call this, right? We have this write decrypt. So what we could do is basically say something. Let's just test this real quick, and then we refactor this, right? So let's do a write decrypt. Let's make it public. Right, I'm gonna make it public. So instead of saying, what is this? This crypto. We don't need this. Instead of saying this, store write, we're gonna say nr is going to be s store write decrypt. Right, it's gonna be the n key. S n key, and then we need the key itself, and then we're gonna say an IO limit reader. And the spear, and of course the file size. Like this. I think we can delete this. Just the top part actually, and then we have the same thing, right? I think that should be good. Is that true? Do we have all the files here? Yes, we have this encrypted thing. So what you could do is delete 4000, right? Then we're gonna comment this out. And then this. Let's see what's going on if we make run. So it's yeah, I see. We get some stuff. We get some stuff, but we get encrypted stuff. And I think the problem is actually, the problem is this. Yeah, it's this thing. It's this new encryption key. That's the problem, because each time we boot up this make run, we're gonna make a new encryption key, which basically means that if we have stored something with another encryption key, it's not gonna work out fine for us. Because it's going to encrypt, it's going to decrypt it with a different key, right? So what we could do is basically, we could say, let's store this, right? And once it's stored, we're gonna say if r is gonna be s2 store delete. We're gonna copy this everything inside of these brackets. Of course, we need to. We're gonna say that is the key. We're gonna delete it here. We're gonna say key here, and then we're going to say get the key. Not get the key. Yeah, we're gonna get the key, but we're also gonna delete the key, but only on the S2 server. And if the error is not nil, we can. What's going on here? We're gonna log fatal, I guess. Like this. Right, so we're gonna store it, we're gonna delete it on our side, and then we're gonna fetch it again. So it should be coming from the network. So let's delete these two guys. And let us see what's going on here. Let's make a run and see what's going on. I have no clue. Normally it should work. I think it's working, right? If you get it, yeah. It works perfectly fine. What's going on? This is insane. This is encrypted. Yes, yes, yes. And this is my big data file. So that's good. It's all working perfectly fine. The question rather is, can we do... All right, that's good. That's good. All right, so there are a couple things we need to do. We also have something in server we need to fix. I think we have it to do here. Yes, use a multi-writer, which is a little bit better. And then we have this thing, right? So we need to check what's going on. We have write decrypt, and then we have a write stream. Wait, what is this? We could say s store open file. Open file writing, yeah, why not? You're gonna say key. Do we need the key? Yeah, we need the key. It's gonna be a string. Do we need the IO reader? I don't think so. And it's gonna return, I think it's an OS file. There's a pointer, I guess. And maybe an error. And I think you could do this, right? We could, yoink, actually delete this. Paste in here. Which we actually then just could return this. Alright. And then we could say fr is gonna be s open file for write then. We need the key, right? If r is not null, we can return 0 and the error, right? And then we're gonna return IO copy with this thing, which is fine. What is this? We could say null. All right. And with write decrypt, you could do the same thing, right? So we have this copy decrypt. This is the complete file. We could delete all the shebang here. I could just say fr is going to be open file for writing is going to be the key. That's fine. Return 0r. And then we can do this thing. Is this going to work? Perfect. I think it is. This basically eliminates some code duplication, which is fine. My big data file here. This is going to be exactly what it is. Yeah. Okay, cool. That's fine. Taking care of that. So write will go write stream. One more thing I want to actually change is basically this write. We could do an end key in this. We have write and then we have write decrypt. I think it's fine. Write and write decrypt. Let me copy this real quick. Write stream. I'm gonna copy these guys. I'm gonna paste them below this write because I think that makes a little bit more sense. We can call write. We can call write decrypt. And it's working perfectly fine. So the next thing we're gonna do is fix this to do. So basically what we could say is that the peers is gonna be a slice of IO writer, right? And then we're gonna say for underscore peer in range as peers. And then we're gonna say that peers is gonna be append peers peer like this, right? And then we could do something like I'm gonna say that the multi-writer is gonna be an IO new, is that multi-writer? Multi-writer. I'm gonna say, yo, all the peers here. Like that. And then we're gonna copy this. But we're gonna say it's multi-writer. And we're gonna write this byte, right? This incoming stream, so we can notify every single writer that we are basically sending a stream by notifying them. And then we could do this, right? We're gonna copy this, copy encrypt. We're gonna yada yada, file buffer, and instead of this peer, we're gonna say all the peers, right? So we're gonna delete this. And then we're gonna print out that we receive to disk. Maybe we're gonna do a printf, do a %s here, and then say maybe a new line here. Received and written. We could do this, %d, bytes to disk. And then we're gonna say s transport other, like this. Multi-reader, it's fine. Millisecond also good. Let's see if this is gonna work. Make run. It works perfectly fine. Also fixed. The next thing I want to do is basically, instead of doing, let us test how far we can get this thing. Let's do maybe 20 or something. Let's paste that in here. The key is not going to be this cool picture. We're going to say that the key is going to be an fmt s printf, and it's going to be, let's do picture underscore %d, which is going to be the y. Do we want JPEG? PNG. It doesn't matter. 20 times. Alright, I think that's good. So we're writing 20 times over the... Okay. Now I want to see what's going on here in our folders. I see some issues. What's going on here? This is encrypted, that's fine. Wait, do we need to... Ah, that was it. Refreshing. Look at this. We have all these files here because we are creating 20, 30 files. Yeah, let me see what's in here. All right, so this file cannot be displayed. Yeah, it's fine. We cannot see what's in here. That's crazy. Yeah, I see some encrypted files, right? Yeah, it cannot open it. Yada yada. It's because maybe if there's some character in it, a special character that VS Code cannot grasp. And then of course in these things should all be the same thing, my big data file, right? And all these things. Right? Yeah, it works. It seems that it works for me. That sounds pretty good. Let me quickly see. All right, so can we do some optimizations, right? That's the thing. Not make run. I want to go to server, right? Something I really want to test. Actually, what I want to test is if we go to main.go, right? Why don't we add another server, right? We could say another server is going to be S3. It's going to be make me a server, and that's going to be a port 5000. And we're going to connect with 3000. Of course, what I want to say is that we need to have... There's not really a way to automatically connect to all the peers. I know. Normally, you should have some peer-to-peer protocol where you ask for the other peers, so you could do peer discovery, and once you get one peer, it sends its peer list, and everybody is connected, right? Just like I'm doing in the poker game on stream, right? That thing, poker game has that. That's something we also could do. The question is, do we need to do? Maybe we should, maybe we don't. Could be a good exercise for you guys to implement this. Because if we really want to make this distributed, we need to do some extra stuff, right? And then we need to broadcast. We're going to broadcast this, that's true. So we have S3, right? So what are we doing here? We start as 1. Let's start as 2. Let's start as 3. S3 is connected with everyone, right? Let's just test that. First of all, what I want to do is let's get rid of these folders real quick. Let's delete them. I'm not quite sure what's going to happen here. So we have all these folders. We boot up S3 at port 5000. We connect with 3 and 4. So this can be interesting. I'm going to run it and see what's going on. Just YOLO. Of course, yeah, I see. That's because we need to wait here a little bit. Maybe 1 second. I have no clue if that's gonna work. Connection refused. Who is this guy dialing 4000? Who is dialing 4000? Ah, it's this guy. What's going on? Wait, do I have... Ah, yeah, I see. I'm doing this. This should be S3. S3. I'm not sure if that's gonna work. Stuff is happening. So that's good. I'm curious what's going to happen actually. Let us refresh this. Boom. We have 3 folders. We have this 3000. We have 4000 has nothing in it because it has some issues. And 5000 is doing its thing. 5000 should have the files. And 3000 should have the encrypted stuff, which is very good. The problem is this 4000 guy. What's going on? Can he not play with us? So we make a server. Right? What's going on with make server actually? Well, let me see. Make server. Transport options, yada yada. And then we're gonna dial probably. But we're gonna dial. We wait a second, then this guy, and then 3 is starting here. Is this not enough? It should be enough. It should be enough. Why can I not connect? Connection refused. Who's dialing actually? Why is it refused? Why is it refused? What's going on? Oh, my neck hurts. I don't know what's going on. They are dialing. It's the transport. Where do we do this? The stream thing can actually be removed. We don't need this anymore. Good that we see this. So we have a new file server. We have broadcast, get. I think it's somewhere at the bottom. On peer, loop, handle message. Bootstrap network. Yeah. So we're going to bootstrap all the networks. What we could do here is actually do a printf and make this a little bit better. We're going to say %s, so we know who's doing stuff. Attempting to connect with remote. There's going to be %s, and of course we're going to do a new line. And it's going to be s transport other, and it's going to be the other, just like that. Let me quickly see who's calling who. Wait. It's doing stuff I know. Yeah. So 5000 is attempting to connect with 4000. And attempting to connect with 3000. That's fine. It feels like 4000 is not starting on a port. We have this listen to 3000, listen to 5000. Why is 4000 not booting? So for some reason 4000 is not booting up. Although we do it, why we say S2 start. We don't care about this, right? We care because S2 is going to connect. Is going to connect with 1, so we need to sleep a little bit. Yeah. Times, I think millisecond. Millisecond is fine, to be honest. Unique millisecond, yeah. No, what am I doing actually? What the hell's going on? 500 or something. S2 start. We do listen and accept. And then bootstrap the network, right? I don't understand why it's not booting up. You see? The TCP transport listening on port 3, it's not working. What am I missing? Let's do 8000 or something, I don't know. No, not 8000. 8000 is a nasty port. 7. It's not calling it. It's so weird. What's going on? TCP transport listening, TCP transport listening, but 7000. Of course, we cannot connect with remote 7000 because it doesn't boot up. Okay. This is crazy. Let me open up server. fmt. We're going to say printf. Right? We're going to say this guy, %s, starting file server. On port. Actually, we don't care because that's support, right? Starting file server, maybe a new line. S transport other. Let's make run and see what's going on. Starting file server, listening. Starting file server, listening. Do I miss something? Do I miss something? Yeah, of course I see. I don't wanna. Let us quickly do. Let's return here, right? Let's do a return here so we don't interfere. Maybe he's just coming too late to the party. I don't know. I can't really see it. Maybe you guys already saw it. Let me also select here. Select. This is a nasty one. I'm gonna lie. You see, he doesn't want to start. What's going on? Am I missing something? S2, S3, S1, S2? Ah, of course. Of course we blocking. Oh no. Oh no. Oh, I'm legit garbage, guys. Ah, that's the cool stuff that I'm of live recording. Right? You can see how many stupid mistakes do you guys already see me make? Man, I'm a fraud. You know what the fuck is going on? Oh yeah. So it's so stupid. It's so stupid that it's funny. The problem is we do like this is what we had, right? The problem is this S1 start is basically blocking. Right, this is blocking. This is blocking, right? So S2 cannot start because this guy is blocking. So what you could do is basically do something like this, right? Can I do go? Lock fatal. Then we're gonna sleep, and then we're gonna say go this one. I'm not sure if it's gonna work. Probably it is. And then we're gonna go start the third one, and if we make run this, then you're gonna see that they're all booting up. What's going on? Thing is, can we do this? That's the question. Do I not need to do... Let's do this and do S2. Not quite sure. Okay, cool. That's what we want to see. And then we have 5, right? So everybody's connected. That's cool. Yeah. Okay, cool. That's what we need. We finally have what. Yeah. So now we have a 7,000. Actually, what we're gonna do is delete all the folders here, right? How do I do this? Select this one, and then delete permanently. Boom. Let's get them out of here. All right, let's do a make run. Let's gonna see what's going on. So everybody's connecting. 3,000, 7,000, 5,000. Yes, let's go. Then the serving. Ooh, yes. The serving shenanigans, pictures, the whole shebang. Let's see what's going on. Because we're not sure. So we have 3,000. Not quite sure. Where's this guy? Encrypted stuff. Not quite sure if 5,000 has something, to be honest. Yeah, he has file 7. I don't... Encrypted stuff! We did it! We did it! Of course, I understand. If you're really going to dig deeper, there is no automatic peer discovery. Hey, I know, there's no automatic peer discovery. But hey, it does not need to be. It does need, but for the sake of this tutorial, to this course, this series, I don't think it needs to be, because we can take this so far, and then within 4 months, we are still developing this stuff, right? So I'm happy. It's working perfectly fine. It's distributed. We can get files. It's encrypted. Because we are S2 on our disk, it's not encrypted, and all the other nodes in network have this distributed encrypted. So it's all good. It's all fine. I'm very happy. We are reaching the end, ladies and gentlemen. It is what it is sometimes. We cannot keep going forever. But a couple things we want to do. I want to put the dots on the Y. You know what I mean? So, yes. Let us see. Okay, cool. So first things first. Let's go to crypto, right? This, what is this? New encryption key, copy, decrypt, and all that good stuff, right? So what we see here is basically we have this for loop, right? It's basically a copy loop, and this copy loop is basically exactly the same as this copy loop, right? So we should refactor that a little bit, because duplicated code is not. Sometimes it can be good, but sometimes it's bad news. So what we could do is basically make a function. Why I have 2 copies here? Let's open up server. It's fine. So what you could do here is basically say, I don't know, maybe copy stream or something. Copy stream, and then we're gonna have a good question. I think we have a stream, which is gonna be, is it a cipher? Cipher stream. Yes, it's a cipher.stream. I don't think it's a pointer. We need a source file, which is be an IO reader. And we also need a destination, which is going to be an IO writer. We're going to return an int and an error. And I think we also need a block size. We're going to say block size, which is going to be an integer, I guess. Something like this, right? And what we can then do is basically copy this bad boy right here and paste it in. And we're gonna read the buffer. Oh wait, we need to copy the buffer also, I think. This block size. Actually, I'm gonna copy this whole thingy and paste it in here. The stream we don't need. And this can be the block size. And then we can actually return. What's going on? We can return this NW, which is N wrote and write it. And probably nil here. Right? And then we have this nice copy stream. Yes. And then we could do something like. Let's comment this out before we're gonna delete this. I think we can actually return that stuff. You can say copy stream, which is gonna have a stream. a block size, a source, and a destination. And this buffer can be deleted. We don't need this. Actually, we could do just that. Return, delete this. Yes. And we could actually do the same thing. We can copy this. We can do the same thing with encrypt. Return this, delete the whole shebang here. Something like that. Or something like this. I think that should be fine. Is this gonna work? Let us test real quick. Make run and see what's going on. And in the meanwhile, I'm gonna sip my coffee. All looks fine. Based on the log. The logging's in the terminal. I think it's fine. So we're gonna delete this. Boom, boom. All right. So that's being fixed. Now we have this nice copy stream, which basically prevents us from duplicating this copy code, which if we need to adjust something, we only need to adjust it at one place. All right. The next thing I want to basically tackle is if we store a file, right? If we store a file, we need to provide a key. And if we store this on our own storage, local server, local machine, it's fine that we say, hey, store, for example, minute.jpg. But if we basically gonna distribute that, we already encrypt the file, which is fine. Nobody needs to see our newts, right? But the problem is, it still can see, we still put the key, the name of the file, the key, in plain text, so they can see what it is. And that's also not a good practice, right? So we're gonna fix that. And how we're gonna fix that is, I think we could do, maybe we can do it in crypto, by the way, in this file. New encryption key, we could say func, for example, hash key string, returns a string, for example. And we could do any hashing function we want. We could even make this an interface. We could say, for example, the hash is going to be maybe an MD5 sum of the key. It needs to be bytes, right? So let's make it a byte slice. What's going on here? Shit. My caps lock is turned on. And then we can actually return a hex and code to string of the hash and do it like this, so we have a nice slice. There's basically a simple function which will hash the key in an MD5, which is a one-way hash function, right? So there is no way they can you can even make it a SHA-256, whatever. But there is no way that they can see what's inside of that hash. Only we know that. So we could do, if we're going to store, right? And we're going to say, if you want to distribute this message, right? This thing here, we could say, instead of the key, we could say hash key. Put in the key. And if you want to retrieve that, right, if we comment from local storage, can be the key, the plain text. But if we want to fetch this, then we need to basically hash it again. So we're going to say hash key like this. Make a run, and that should actually be the same thing. Although it's going to have another path. But that doesn't matter because it's going to fetch it anyway, right? Yes, yes, yes. Closed and all that stuff. Big data file is coming out. Everything is working as intended. So that's fine. All right, the next thing what we need to do is we have actually a problem, and I was not quite sure if we should support it, but I think it's a good way. I'm going to show you how to do. It's basically, for example, what we're doing now is if we don't have the file locally, right? We just gonna send a message, yo, give me this file name. The problem is that what happens if we don't know that file name, right? Because maybe our house is exploded or something, I don't know, and we actually don't know what files we had in our storage. Then how are we going to sync, right? Because if we don't know the key, we cannot fetch it. We cannot ask for the key. So how we can solve that is by, and I said, like I mentioned before, you can make this as complex as you want. And you could even do it with a public key, private key, and then sign your things and sign your messages, and then we could validate and all that stuff. So only you can store to your ID, which is what we're going to create. So enable to fix this is what we do now. Let me open up store actually. I'm going to open up the other side, by the way. If you have store here, for example, let's go at the top. What we do now is basically we create a path, right? We create a path, and that path is basically based on a transform, func based on the key we give it, right? And the key is, for example, that could be a file name, and the file name could be clown.jpg, right? We're going to transform this file name, right? And that's going to return as a key, which is going to be a path actually. It's going to be a path, right? And then we have our root. We have the root of the folder, right? And we're going to have a path, right? So what we're going to do is basically, as we could store it in a root, because that's where we're going to store everything, right? Files from everybody that want to distribute these files and our files. But we could actually do something in between, and it's going to be a root and then an ID, right? And that could be a pub key if you want. That could be some kind of a random ID or a random string, if you know what I mean. So basically, if we then need to sync, the only thing we could do is ask for a sync and give it this random string, right? Which basically is a random identifier of our storage, of our server, whatever node, whatever you want to call it. And then we can actually fetch all the files inside of it and send it over, right? So how can we implement something like that without doing too much refactor? And that's basically something like that's actually a good question. We could do if you go to crypto, right? We could do something like not quite sure if crypto is a good thing to do, a good place to do it. You could do it in a util function or something. But hey, but you could, to be honest, it would be nice to have a public key enabled to do some stuff with it. But I'm gonna use a simple ID, right? You're gonna say generate ID, which will return a string like this. And we could say, for example, it's just to give you guys some ideas, right? Because for you it would be nice to extend this forever store, extend this distributed file storage with some of your own functionality to learn, navigate through the code base, and to implement your own IDs, right? That's the best thing you could do. But you could watch this series forever. It's very important. It's a very big mistake I also made in my career. Is what a lot of people, or mistakes a lot of people making, and it's not only with coding, it's with everything. They watch a lot of videos, which is good, which is very good, right? But they keep watching. They keep watching, but they don't do. It's good that you watch, but it's also very important that you do stuff and figure things out. It's also very important. So we're going to say, let's say we're going to make a buffer, which is going to be make me a slice. Let's call it buffer. Make me a slice of byte. Let's make it 32, right? And then we're going to say IO read all or read full. I think it's read all. Is that? I think it's read full. And then we're going to say IO It's not that. It's gonna be a rand reader, right? And we're gonna read the buff, right? And then we're gonna say return hex encode string. One of my favorite functions, by the way, hex encode to string. We're gonna encode the buffer, right? That thing. And then we have a nice ID, right? And you can already see it coming with this 32. You could use a pub key, and then you could actually enhance this file server. So every message we send is going to be signed with the pub key, and then you could store everything at the pub key location, and you could check if the message is coming is exactly from the guy that wants to store and retrieve stuff, to make it even more cryptographical secure, right? Generate ID. Okay, cool. So what we could do is basically in main, or in server actually, or maybe in root ops, store. That's what we need. And did I code into, let me open up crypto. Did I code into my screen? No. I need to make sure that's not happening. So let's open up store here. Yes. What we're going to do is we have this store ops. So we have this root. Let's give it an identifier, which is going to be a string, right? ID of the owner of the storage, which will be used to store all files at that location. So we can sync all the files if needed. Something like that, right? What's going on? Everybody's sending me messages. Yes. We have this ID. If you're gonna make a new store, are we gonna make an ID? You could do that, right? You could say if len opt ID is 0, then we're gonna make one. Right? If somebody forgot, I'm gonna say opt ID is gonna be generate an ID, just like that. I cannot do this, it's fine. So now we have an ID, and then we could say in storage, it's basically if we open file for writing. Is that what we need? Yes. So you can see we do a root, which is this one, and then we do the pad key, right? And we could do something in between, and that's going to be the ID. Something like that. What is this? As root pad key, I think we need to provide here the ID also. Just like that. And now we need to do the same thing with the read stream, right? So the read stream is getting the root, and we also need the ID. Like that, as root. Then we're going to say as ID. Like this. Hands are cold. Tell me something new, eh? Alright, so I think if you open up store test actually. Not quite sure if this is already gonna expected to have key foo. Oh, we have some issues in our tests actually. Expected to have key. This one. Expected to have key yada yada yada. But got. Ah, we don't have it. I think it's has. That's the problem. The problem we have with has, we need to, yes, that's what I was thinking. So of course we have the root and we also need to provide the ID here. As ID, and maybe that's gonna work a little bit better. Make test actually. All right, expected to not have key. I think a problem is that it's not deleted yet, right? Let me delete these files real quick. Man, this Windows this Windows signing bell is crazy. Blowing up my ears. I think we don't delete this. Where is delete? Right, exactly right. So we have again, we need to refactor this, that we have the ID of the storage like that, right? Make test, please. Boom, yes. Yes, that's fine. So let us hope that make run is gonna work perfectly fine. And I think it is. Good time to sip the coffee. Yes. All right. Let's see. Yes, we have these nice folders. Of course, you can see that I think we do it with 5,000. I don't know who the guy is, but you can see that these folders, right? These paths are basically not the same as this 5,000 paths. You can see, but these are the same, right? So this one, these paths, right? These folder paths are the same as the 7,000 one, but they're not the same as the 5,000 one, right? And that's because the 5,000 one is the guy that is storing stuff and make it distributed. So the two other servers in the network, they will have the encrypt hashed version of the key, which will translate into a different path, right? So they don't know the contents of the file because it's encrypted, but they also do not know the contents of the key, which is amazing. Super secure, well, super private, like this. And I think it should work, right? So if we, encrypted stuff, that's fine. And then 5,000 should have my big data file is, see, these things come together, it's so nice. Yeah, and you can see what happens, right? So you can see that this is the ID. Right? This is the E77A6, right? This is a problem. We made a big mistake, by the way. We made a big mistake because they're storing these files inside of it's good that we have an ID. That's a fact, but I was just thinking about it. I made a mistake, guys. You can see. I also make mistakes, but we identified it, which is good. So basically, the problem is that if we retrieve a file, it's going to retrieve from the ID from the storage. So it works all fine, but it is not working like intended. So what happens if somebody is storing? It needs to store at a certain ID. So instead of Anthony. So instead of storing at our own ID, let's open up server. That's fine. Server is on the other side. Yeah. So I think, to be honest, let's refactor this. Sometimes it's funny. But wait. Where is this thing? This ID thing? Let me find this. ID. So yes, I think we need to move the ID to the server. Yeah, we're gonna delete the ID, guys. We're gonna delete the ID, guys and girls. And if I say guys, it means guys and girls. You know what I mean? It means everybody. I know. We're gonna delete this, right? Okay. Damn. No, we're gonna do it like it's a mistake. and we're gonna take the pain, we're gonna take our mistake, and we're gonna refactor it. That's sometimes what it is. We can go the easy route and re-record the video, but I'm not that guy, and you guys know that. That's engineering, and I want to see engineering at its finest. And if you make a mistake, you need to take it as a man. You know what I mean? And that's what we're gonna do. We're gonna take it as a man. So we're gonna delete this. And I hope you understand what's the problem, right? So because we are storing it at our own ID, which basically has the same problem we already had before, I think we need to refactor the code a little bit. If we write and read, we need to specify the ID of the location where it's the ID of the other node. It could be our ID, but it could also be another ID. It's very important. And that's the only way we can sync. If we don't know, we can basically sync the whole folder to a server, right? If you really want to implement that later on, if you know what I mean. Okay, so I think we are back. These folders are back at the state they need to be, which is good. Luckily, we didn't refactor that too much. Yeah, I think it's fine. To be honest, I think we can make tests and it's gonna be all good. Yes. All right. It's nice. It was good. It was good. It could be much worse. So, how are we gonna fix this? We are going to say we're going to server here, and we're gonna say server ops. I'm gonna give it an ID. It's gonna be a string. We could. Do we need to? It is fine. It is fine. What we could do is basically we could do like this, right? So if opt ID, wait, you could say len. That's how I check if variables strings are empty. You could do it whatever you want. We're going to say if len opt ID is empty, we're going to say opt ID is going to be generate ID. So that's going to be always fine. So we don't need to specify it. It will generate an ID for us if we don't specify it. And if we specify it, it will use that ID. Yes. So what we're going to do. Man. We could say get the key as a string, but we could also say from which ID we want to read. Right? Wait, I'm thinking. Wait. This is already a server. We don't need it here. No, because we could send. Yeah. Wait. Let me open up store first. Store is the most important thing right now. Right. So we could do something like this. I'm thinking, is this gonna work with read and write? Let's open key for write then. Okay. So it's gonna be some nasty, and maybe we should introduce another episode for this. Or I could actually do it in one. We could actually complete it here, maybe. So we're going to say... we need to prefix this with an ID. It's very important. We're going to say string. And then we're going to say %s. It's going to be the ID. All right. Open file for write in. ID. Yeah. The same thing here. ID is going to be a string. It's going to be the ID. That's fine. Reading is going to be the same thing, right? We're going to say ID string. ID here. going to be a problem in read stream, right? I'm going to say ID string. This is going to be a %s. It's going to be the ID, right? Just like that, all fine. Write decrypt ID string ID key. Fine. Write. We need an ID. An ID string, which is going to be ID. No, it's going to be ID key. Delete the same thing. %s is going to be an ID. Yes. And has is the same thing. It's going to be an ID string. You could see an ID as an extra key, right? As an extra key where it's stored, so we can actually do some advanced stuff with it. The question is, what's going on here? Did we actually have everything? ID key, yeah, file, yeah. Write decrypt ID, yes. Write yes. Delete yes. Has also. I think we're good. Of course, now we have trouble in our storage here. So we're going to say new store. Maybe we need to make an ID. And put this ID here. And ID here. It's a little bit of tedious operations, I know. I'm going to make test. Okay, server is complaining, I know. I know. Right. If you want to get a file, you're going to say it's going to be as ID, right? And then the key. So then we don't have it locally, right? Then we need to actually upgrade this payload message. We need to specify an ID, which is going to be as ID. We need to send our ID over, right? That's very important. Where is this message? I have no clue. Let me quickly GD into this message, right? We're going to say the ID. It's going to be a string. Actually, this guy. It's going to be string size, fine. But we also need an ID. Actually, we can do it at top. And that's going to be a string. But I also think we need this in get file. All right, that's fine. So we specify an ID here. Let's put it at top. It doesn't really matter. It's just an OCD. And then we're going to read our key based on our ID. Like this. And then if we store, we need to specify an ID. Actually, is it? Yes, it's our ID. The key. Then we're going to send that this guy needs to store this at our ID. All right. Handle message get read if store has. It's going to be from this guy. Message ID. We're going to read this guy. Wait, and I get message. Wait, so first of all, need to serve. So, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 159 160 Wait, because this is handle get file. We're first gonna check if we have it. I think it's gonna be the message ID. Not quite sure. And then we have this one, handle store file from this peer. So I think we need to store this on the message ID, right? Let me see if make test is working. We still have not enough in main and in server. 112. Yeah, right decrypt, yeah, I see. Yeah, so we broadcast our ID. This is going to be as ID. This is going to be our ID. Which is basically after this encrypt. If this is going to work from the first time, it's going to be this one. And I think we still have some issues in our test. Here in right stream. Make test real quick. It's a problem in main, that's fine. So we want to delete S3. It's going to be S3 ID, right? So that's going to be fine. Let's make test. Yes, okay, test is working. Okay, I'm not quite sure if our thing is, our service is going to work. Could be that we made a little mistake, but hey. Okay, seems good. Seems good, seems good. So how can we make sure that is gonna, I'm gonna refresh these folders because, let me close all these guys here. What's going on? Right, let's refresh. Okay, so we have these three people in the network. And I think it's 5,000 is gonna be the guy we need. Yes, 5,000 is the guy we need. So he has two thingies, I think. Some relics from the past, right? Wait, let me delete these folders and run again because this is going to be confusing as hell. So we're going to delete the whole shebang and then we're going to run again and then we're going to see if these ID folders are correct. Make a run. And if so, we are in a good spot, right? Yada, yada, yada. Yes, okay, cool. Let's see what's going on. So we have... Yeah, I think this is fine, right? Because we have this ID from 5,000. And they all have this ID. And they store everything or files at this ID. Right? At this thing. Which is perfectly fine. Which is what is intended. So now... Our server works like a complete, like a distributed file server. And if we, for example, if 5,000 doesn't have this folder anymore, he can either sync the whole folder, right? He can sync the whole folder, or he can ask for a specific file if he wants, and people will exactly know where to find it because it's his ID. It's in his ID subfolder, if that makes sense. Right. So I think this was it for the distributed decentralized file server, file storage. And something I want to give an assessment for the people that are watching these series. Something that you can do. It's not mandatory, of course. It's what you want. And what I'm gonna give you is, if you can see, we have get, right, and we also have store, right. We have these two APIs we can use for our storage. But what we don't have is delete, right? We have delete in our store, but we don't have delete in our server. So the assessment I want to give you guys is implement delete, right? That basically means it needs to delete the file on our local machine, but it also needs to delete, it needs to send a message to all of our peers we're connected to, so it can also delete a certain file on their machine, right? That's the assessment I'm going to give you. Not too hard, not too simple. I think it's a very nice assessment. And I'm going to, when it's done, you can DM me on Patreon or whatever. You know where to find me. And I'm going to review that and give you some feedback on your implementation. Right? That's what I'm going to do. Cool. Yeah, cool. Thanks for being a part. Thanks for being in the community or whatsoever, for the support, and I see you on Discord, on a video, or on live stream. Thanks for watching. Bye bye.